And yes. Hello, finally, we're all together. Who was waiting for this moment for a long time, believe me, and this is it. Hello, everyone. This is the Software Architecture Summit 2024 by Geekle. Just let me know how can you hear me, if my sound is good, if my picture is okay, while I'm saying hello to our beautiful Sia, who is an event manager of this event. Hello, Sia. How are you?
Hi, Hayat. I'm great, thank you. I was waiting for this day during last months of preparation, and finally we are here.
Yep, absolutely. Well, I'm actually so happy to be live with this community again. Despite all troubles we have on market, we survived and we're still operating and we even pivoting. So I'll tell you later about that. So happy to welcome you here. And let's get it started because I see some links in the chat. Yes, people, please feel free to share your LinkedIn or other socials for hello, finally. Yeah, hello, Osama. Yeah, and let us know, as always, let us know what city, what country, maybe what room you are now watching us from, because it's so exciting for all the team to know how big and how broad the community is now. I'm in France, in Nice, and let me know where are you from. And yes, we're moving to the event. We have more than 2,500 registrations, which is great actually for architects communities. It's huge, let's say. And also we have 23 speakers what Sia managed to gather for this event. 10 junior topics or career day, we say, because it's weird to say junior track for software architects, right? So we call it career track. And 13 senior sessions for tomorrow. If you don't have any tickets yet for tomorrow, you can find on our website. So today we have four blocks and 6 hours in total. Someone asked me in a chat. And tomorrow we'll have three blogs and three Q&A sessions for 9 hours of content. And it believe me, should be real deep stuff. So, yeah, tell us more about this event.
Yeah, so let me walk you through the structure of the event. We have 2 days. Today is a career one. It's free with 10 speakers, and tomorrow there will be a paid day with with 13 senior topics. So feel free to grab yourself a ticket and join us for tomorrow also, and write your questions in the chat during the presentations. I'm so excited that almost all the speakers will be present with us live. We have only one or two presentations recorded, so you will have the opportunity to meet all your desired experts in the field and ask your questions and get the answers, and having small discussions with speakers during the Q&A session, which is a great opportunity for networking and extend your knowledge and have more clarity on the topic. So yeah, be active in the chat and do not forget to write the questions. And everyone who bought a full access ticket will be sent certificate by mail after the live stream, and also individual recordings will be available at the end of the week for those who paid full access ticket.
All right. So, hello from Tunisia. Hello from India. Hello from Sicily. Hello from Francis, from me, of course, from Toronto and Iraq and London and lots of folks from everywhere. Yeah, and I want to say that we have the company who supported our community this month. So Tag Dev Technologies, so we thank you them for their support. They're doing a good stuff. So if you know someone who needs extra help on the project or looking for a coding partner, please consider those who support community first. And these guys are really supportive for us. Thank you, Tag Dev Technologies. And we're moving to actually upcoming events. Sia, tell us more about what's coming up.
Yes, we do. We prepared 2 more events this month for our audience. The first one is TypeScript Global Summit. So it's an online conference on May 14th. It has some junior, some senior topics. It will give you the whole picture on the current trends, on the new practices, on the really good stuff you can implement in your daily work using TypeScript. So if you're interested in it or have someone from your team who would like to join such event, we prepared a great program. And also we have QA Global Summit on May 21st, 22nd, which is one of our biggest events actually. And it has a great program, outstanding speakers. So you have still a chance to buy a ticket at the early bird price. So agenda will be available this week, the whole lineup of speakers. So do not forget to ping your QA colleagues to join us for the QA Global Summit as well.
Yeah, absolutely. Thank you, Sia, for this introduction. And the last thing I want to know, I see people from West Wales, Estonia, India, Nigeria, more from India, Uganda. Oh my God! So from everywhere, somebody's calling me even. Portugal, again, India and UK. Guys, please feel free to follow me, to follow each other, because this is a kind of the place to find new people to follow. What I say, yeah, for the first time in the history of Geekle, we're working not only on the educational content and conferences. Uh, in our Geekle AI labs, we found like lots of AI startups that are working in the field of tools for software development. And we see lots of these code generators, right? Uh, Honestly, we don't think they are heading in the right direction because generating code is only small part of whole process, and especially for you as architects, is not something that really like crucial or game changing, right? Uh, when we talk with the AI enthusiasts or these believers, I always say, well, to build something using this generative AI, I mean, to build some ready to customer product is like, imagine if you want to print the airplane or vehicle using 3D printer. Can 3D printer actually print the big airplane? Well, probably yes, but would you like fly on it? No, you would take the one that has, I don't know, these Boeing or Chrysler engines and test it for years and stuff. So it's kind of that. Yeah, it's useful in some parts, but not in general. What we want to do here at Geekle, we're building Fly Machine, is a kind of assistant that will help architects pick solutions, because we know like modern software is like 90% of modern software is not coded from scratch. It's built from existing solutions. You find solution, you adjust, integrate, and it's a part of the product. So we thought, why not actually leverage the power of AI to actually help with the discovery. You all know we spend hundreds of hours a year in this exploration process, reading lots of documentation, Googling, searching, GitLabbing, and stuff and stuff and stuff. So we were working on a global search machine where you can find any software development solution, compare in the tables, and but it's not the magic yet. The magic part is when you click on this solution, it pops up, so you don't need to download, install, configure, read documentation, and all this stuff. So no, you still need to read documentation, of course, but we're trying to eliminate this process of downloading and installing every software development tool. We just want to actually have it prepared in our Dockers. So once you click, it just pops up, and you see the code in online ID and the interface if it has interface. So the crazy idea, and we're like just started to work here. It's a spoiler. We don't have any waiting list. We don't sell anything. So just to let the community know that we're also looking here, trying to actually make software development process more modern and up to date. So if you want to be an advisor of such project, or maybe you want to test once we're live, or become beta testers, or whatever, you are ready to contribute, Geekle with Fly Machine to build this AI-based project and have fun with us, just hit me in LinkedIn. I just shared my LinkedIn account, and I will do it once again right now, probably. Yeah. So let me know if you're up to talk about that. All right. No more chat, no more stuff, no more nothing. We are going to directly to our first speaker. Thank you, Sia, again. Thank you to every speaker who contributes their time and energy to this community. And also we have people from Vinnytsia, Ukraine, and also India, and Italy, Greece, Catania, Belgium, Tunisia, South Africa. Oh my God, from all around the world. Hi. AI is helpful, but it could never replace the mind of engineers. Absolutely, I'm absolutely standing on that. All right. Yeah, I'm inviting here Artyom. Hello, Artyom. How are you, man?
Hello. I'm really excited. Yeah, happy to be here.
Yeah, I see you like not the first time at our event. I'm so grateful for your support, and I'm so happy you have something to share with the community. What is going on your side?
So everything is fine. I prepared a really interesting topic for everyone, which is the specifications related topic, and I hope that everybody will take some useful experience from it for them.
Great, thank you very much. And the topic of our term is specifications as a better way of development. And I think that being the software engineer in Microsoft, being the part of that actually great team, he has something to share, some insights, and I'm delighted to actually hear. Okay, the stage is yours. Do your magic. We can't wait.
Okay, thank you so much. And I hope that my presentation is visible for everyone. And here we go.
We'll see it.
Yeah, thank you. So, hello everyone. Hi from Czech Republic, from beautiful city Prague. So as I said, today our topic is the specifications as a better way of development. And first of all, I want to start with a quick introduction. My name is Artem, and I'm a software engineer with over a decade of experience in software development of any kind, from typical web services to game development and mobile applications. So I have some experience, and I'm really excited to share it. Currently, I work at Microsoft. In my free time, I try to actively contribute to open source projects because I feel this is really important for the engineering world. Besides, I consider myself a technical diversity advocate, so I encourage people to try new technologies in their daily work, maybe new languages, new stacks, everything. First of all, I want to highlight that this talk will not be about the code in the first place. We will cover some practices that can be used to improve our development experience and software architecture experience, regardless of particular language or stack. Here's what we have for today. I'll start with a bit of introduction into theory, which is going to help us to follow the presentation. Then we'll spend some time reviewing what methodologies we can apply and what kind of tooling is available out there. And of course, it will be reflected by checking out some real-world problems, some solutions, and of course, benefits you can get out of it. There are a lot of things to discuss when it comes to specifications in engineering world. But what is the specification actually? Let's establish the meaning, the key meaning, before we can move forward. Some time ago, I was checking different articles, and I found this particular quote that I really liked it. Because it actually reflects the meaning of the specifications in the development process. So it says, software engineering is the art of turning specifications into miracles. And the meaning of this quote is that if you have proper requirements and instructions, you can build literally any software that might be a miracle for someone. And I think everybody knows that it's true. Nowadays, we have so many applications, and some of them are really miracles. Even this OpenAI thing, and basically this is the chat, and we can talk to someone, and there are some replies. So a few years ago, or maybe several decades of years ago, you can say that it's a miracle. Okay, but let's take also a look at the original definition of specification word, which I copied from the Oxford Dictionary. Here we have that specification is a detailed description of the design and materials used to make something. Please note that it's not a description of how something works. It's an instruction on how to make something. With this being said, we can finally move forward and check the specification examples in the real world that we can use for development. There are several types and even subtypes of them. For example, we have functional specifications or process specifications, which you can see right now on the left and right side of the slide correspondingly. It looks like we have quite a lot of them, and maybe some of these already seem familiar to you. I hope so. For example, before you start the development process or the building the architecture of your software, I suppose you expect some requirements that may be converted later into a design document based on which you can basically implement the product. It is kind of a specification. Another example could be when you have some API and you want to provide information about it to your customers or to other engineering team, you can use Swagger or API docs. It is also a kind of specification. And sometimes even a method signature in your code may be a specification, depending on how you look at it. If you provide the interface to the developer, it describes how to implement something, so how to make something to work. It is basically a specification. Let's take a closer look at one of the most popular specification in web development, which is OpenAPI, also known as Swagger. I bet that everybody who is related to web development knows this thing pretty well. But let me quickly introduce it to you in case you don't know. OpenAPI is a specification that allows developers to define what API looks like and what kind of operations we can do. Usually, it contains a list of endpoints with their data structure definitions, which allows other engineers to use it for integration development. For example, I have a service and you want to create a service which will be connected to this one. So I provide you the open API specification, and you can write code based on this specification or list of endpoints or data contracts. A well-known situation is when backend engineers provide this open API to front-end engineers, or maybe to mobile developers to create a user interface or create a mobile application to work with this API. Of course, there are more usage of this specification, but I believe this is the most common case. And of course, it is not limited to only the communication between engineers, since you can also leverage this for your infrastructure configuration. For example, by checking what kind of authentication is used there, or you can even test your API by using some specific tooling that supports OpenAPI. And there are a lot of examples. But the main question here is, how does it help engineers with the development process or with the designing process of the architecture? And you might be thinking that if there is only communication help, then it's not worth it to introduce specifications at all. But it's not that easy answer. First, I think we should understand what kind of problems we're trying to solve here, right? Nobody wants to use a technology if it doesn't solve a real problem. And here I collected just a few examples of different problems we may face when working on modern services or modern architecture for our applications. Let's say that if you have client-server architecture or even server-to-server architecture, you will most likely have inconsistencies between these APIs or some data contracts. Especially when it comes to backward compatibility, it becomes even harder to maintain everything. The more complex your system is, the less speed of development you get. This is another problem which we want to solve. And if you had bad processes during the implementation or software architecture designing, you may have blocked front-end or mobile engineers awaiting the information from the backend team, which is also not very pleasant experience, especially for a huge company who wants to get the revenue. Also, in big projects, the cost of maintenance is usually very high, and even updating a small part of the project might be quite painful due to technical debt or some MVP solutions and so on. So finally, we can think about probably the most important metric for everyone is which is time to market. We always want to improve our time to market metric. We want to deliver faster. We want to deliver with the higher quality. We want to deliver with less effort. And at the same time, by doing this, keeping the same quality level or even better is a very, very difficult and tough challenge. So one of the options here to solve all of these problems might be specification-first development, or specification-first approach, also called. You can encounter this approach also known as design-first. And it is a way of development when you start with a specification document before the actual implementation. And it might be any specification. Swagger, or maybe some particular document which fit your company standards. So I personally consider it as test-driven development for the API, because it just helps me to understand the meaning of this specification-first approach. You start with a specification, then you prepare test cases based on it. But test cases not for your code, but for your system, for your business scenarios. You do some implementation with different technologies, and moreover, you can start work on both sides, let's say the backend and mobile app or front-end user interface. You can do everything at the same time. Once it is done, we can run our tests and probably make some minor adjustments, because nothing works for the first time, right? And if we are lucky, after tests, we can say that it is done. Or even without minor adjustments if you're a perfect developer. This journey seems very efficient, but it is time-consuming to prepare all the requirements and write all the specifications and test cases in advance. Very few people like doing this way. I believe that not everyone wants to spend a lot of time before the actual result. So we all know how it works. In reality, we have much less probability that it will go that way. I saw hundreds of situations and different teams and companies that follow the other way. They start with an idea and maybe some design documents or maybe even some papers based on which backend team already can start the development. And after initial MVP or maybe some proof of concept version of the backend or the application, they can generate specification and from the actual code. And only after that, they include their front-end team or mobile team and syncing up with them and testing it on the way. This approach, which is the most popular nowadays, is called code-first development. Yeah, it works sometimes, but you can notice in the list on the slide that once you reach point number 7, there is still a probability that you may have several iterations of improvements and bug fixes. I believe this is one of the biggest problems in our development lifecycle. So what do we do to improve that? And I believe everybody already knows. The answer is simple. Just don't write code without specifications. Easy. So what's the reason why we all keep doing it wrong then? And I think here's why. Our industry dictates a different vision. Django, which is one of the most popular Python frameworks, has a package to generate specs from your code, but not the other way around. Flask, also popular in Python world, does the same thing. In Fast API Python framework, they did even include a generator as a core feature. And the same thing happens in other communities. .NET Core has a swashbuckle package that generates Swagger from your code. Azure Functions in .NET Stack as well has it as a core extension. A quite popular framework, Symfony, from the PHP world, also uses this code-first approach. And a lot of other examples. Trust me, I checked it. This is why I technical diversity advocate, because I checked a lot of things and I encourage people to do the same. So based on this list, we can say that basically code first won. I suppose, yeah, at some point, I also accepted this as the right way of doing things, until I encountered one specific solution. I will tell you a short story about the package named GoSwagger, which affected me in a good way. Some time ago, I was working on a microservice project based on the Golang language, and this package was used there to help with code generation. Sounds simple. Let's start with a couple of words about the package itself. As you can see from the name, it works with Swagger specification, which we also know as OpenAPI. But unlike other solutions I mentioned before, it provides more features focused on code generation instead of specification generation. You can start with a spec and generate SDK for your clients, or you can generate the whole application with server stubs, including endpoints, infrastructure, authentication configuration, and even some tests for your API. So everything could be generated from just one single specification. And the only concerns you may have working with the package are support of the version 2, because currently OpenAPI is based on version 3, and the fact that it is written in Golang and is supposed to be used in Golang-based projects. The first release was 9 years ago, by the way, and it is still alive. So if you work with Golang, you can give it a try. And let's take a look at the example of what you will get by using this package or module. There is some command. I, on purpose, removed it from the slide because we're not interested in so much technical details. But long story short, after running this generation command, it will parse your specification and generate all the models from this spec as Golang data structures, such as the one that you can see right now on the left side of the slide. And it also will generate the whole application structure, which you can see on the right side. So it contains some entry points, models, definitions of the endpoints, and everything you need to write your application. This was a huge invention for me back then, and I was really impressed, but depressed at the same time by the fact that we don't have that everywhere. By using this package, I stopped caring about the endpoints boilerplate, creating DDOs, registering the configuration, and writing request parsers. Everything was generated automatically, and it was so much easier to design the whole application because I can start with a small specification file, and later I know that everything will be automated. So finally, I started thinking that specifications are not only useful for describing existing APIs for clients or for customers, but also for defining how to make this API, which is consistent with the definition I mentioned at the beginning. This, of course, inspired me, and I decided to take a look again and see what else we have there besides this package to leverage the power of specifications and bring my designing skills to the next level. And to my surprise, actually, there was a default, or let's say, kind of official package from the Swagger team, which provides a similar experience. You can generate both client and server code, and it supports more than 30 types of client SDKs and more than 20 types of server stubs, which means more than 20 frameworks, but not languages. It is totally customizable, and you can provide your own templates, server stubs, create extensions, and moreover, it also supports the latest third version of the OpenAPI. So let's say it is modern. The only concern, again, is the language, because Java is not used by everyone, so it might take some time to onboard yourself into this world. And right now it has just 16,000 stars on GitHub, which is surprisingly small number for this kind of package, at least I would expect. So that's not it. Later, I found another one, which is a community fork of the same Swagger package, but with more types of SDKs and server stubs. I believe in power of community, and that's why we still have open source, right? And basically, this is a good example because you have at least 2 times more support for different servers, frameworks, and languages. And it has around 20,000 stars on GitHub, I believe, which is better, but still not what I would expect from this kind of packages. So since I started diving into this world, I also found another interesting specification that goes along with the tooling for code generation as well. Its name is Async API, communication between services and storages. For example, you can describe what kind of information you exchange between Kafka and your API, or what messages go into Redis queue, and so on. Once you have your specification, you can generate SDK, you can generate consumer classes in any language you want. It is very similar to OpenAPI, but with a different purpose. It's also based on JSON schema, and this project is not popular yet, but I believe maybe after this event, it will be changed. So it has around 4,000 stars on GitHub. I already used it in several projects, and I would definitely recommend this one to try. Since this time, I already found a few more examples of different open source specifications that help with other features, like the feature toggling or cache storages, and I can spend another 30 minutes just describing them. So what's the conclusion here? If we can do the specification for API or a sync API, does that mean that it will work for other features as well? And I think so. Let's imagine you can define specification instead of the boilerplate code or templates in your project. You can apply specifications not only for API, but also for infrastructure. It is already supported in many clouds, and we have a separate term, which is infrastructure as code. Let's keep it as infrastructure as specification. You can generate code from these specs and remove it from your repository because it will be generated during build process. So you can save your developers' time. You can save your storage of the repositories if it matters, and do a lot of things like storing all these specifications in one place to make it available for everyone. Sounds good, right? So let's reflect. We have a lot of benefits. And basically, specification-first approach can help you to make your QA engineers happy because they can write tests without any API. It can help you to make your engineers happy because there is less code to write, there is less code to review, and there is no blockers for different teams. So it will speed up the development process in general and reduce a lot of overheads and the number of errors due to inconsistencies, for example. You can reduce the communication and the amount of code, and it's everything about improving the performance of your team. But of course, we also know that there is no perfect solution. So we have to do some trade-offs, and sometimes it's not very pleasant, but still. Let's say the tooling which we have nowadays is very language specific. So it requires more effort to integrate it or to implement it in your project. These kind of applications are a bit tougher to refactor, especially when you need to change the generated code. Sometimes there is no solution compatible with all the projects. Yes, we have support for Redis, for Kafka, but sometimes there is some new project which is not supported by your specification yet. And of course, we have some limitations in the specs itself. So we may lose some small benefits of our top-notch technology stack. But you should keep in mind that code generation and this specification is just the templates or template engines. So it's not all powerful. But we can keep it more advanced and help to improve. So I shared a lot of benefits, but there was a task, small task, but interesting, that actually changed my mindset. And that is why I ended up here talking about the efficiency of the specifications. Let's quickly dive into this one. Back then, I worked in a platform team of some company where we had a task to create a catalog of specifications to let everyone easily generate SDKs. Unfortunately, we followed code-first approach. And as a result, we had some services that were generating specifications based on API, and not all endpoints were covered. So we decided to cover them manually and create a specifications catalog to solve this problem. I thought that it would make sense to check what are the options among open source projects, because that's the thing I always do. And for sure, someone already tried to parse and analyze this kind of thing. But apparently not. Back then, there was no package that would allow me to read all the endpoints from the specification and compare it with available routes in my application, for example, Django, Laravel, or Symfony, or any other framework. So here we go to another story about one more package, which is OpenAPI Free Parser. This time it was created by me with only one simple purpose: to read the specification as typed DTO, to allow me to read the endpoints, or to get the request body, or to do something really simple about this specification. And unfortunately, all the parsers I found, they just allowed me to read it as the dictionary or read it as the file content as a string. So I took some other projects and implemented my part on top of it. to get this simple solution, as you can see right now on the slide. An actual solution for my problem was just a couple of lines of code. And as I mentioned before, this talk is not about the code itself, so I will omit the details about the business logic. So here we have just simple Python code that iterates through all endpoints in my spec and prints them in the console. And you can see the output at the bottom. And basically, that is how I solved my problem, by using specification and improving the build process by checking and validating that everything is covered. But in reality, by using such tooling, you can extend functionality even more. For example, you can create your own code generators. You can implement the server toolkit for mocking responses for QA engineers. You can generate fake requests for stress testing, and it will allow you to test your architecture even before the implementation. And if you do your own DevOps, you can introduce a lot of configurations in these specs, such as rate limits or virtual networks. And overall, there are a lot of ways to automate things and improve your development performance and experience. Once I finished my project, I decided to publish it as an open source. And you can imagine how I was surprised once different people started contributing their features and suggesting another solutions to solve their specific code generation tasks. Even companies were using this package as a part of their solution, including even Microsoft. So I was shocked back then. Right now, it has around 25,000 downloads per month, and I'm glad that it helped so many people, but it's just a parser, right? Not a big deal. So that was my story, how I decided to incorporate specifications into my development lifecycle as more important thing. And answering the question, what's next, I would say it's just your imagination. You can introduce a lot of different new specifications for metrics, data, search, storage. It's up to you. And since right now there is a trend to use AI everywhere, that is also an option to leverage custom models to generate code based on your unique specification. So if you want to start experimenting with specifications to improve the development process, I have a few personal recommendations for you. Start with something simple. Try to not cover a huge system on the first try. It will let you get results much faster. Do not reinvent the wheel, as I did, and to some extent. Some tools may fit your platform already. Try to automate and generate stuff as much as you can, even simple stuff, but it will help your engineering teams to reduce the complexity. And we know that if something is optional, then it's not needed in reality. So try to enforce these techniques in your projects. To sum it up, I would like to say that there is no perfect solution that can solve any problem, but I love this principle: done is better than perfect. And that's exactly what you can do even right now. Don't try to solve everything with the specification, but try to optimize existing processes and solve real problems. Here I collected all the resources I mentioned during the presentation. Feel free to check them out. I hope that presentation will be available afterwards. And of course, don't hesitate to reach out to me in case of any questions. I would love to share more. And thank you, and see you later in the Q&A session.
I'm sorry, can you hear me now?
Yes. Welcome.
All right. Thank you very much for this presentation. Like, I'm impressed, for real. I'm sure the community also. And what happened now is I see lots of people sharing their profiles in chat. Please, Artem, share your profile in chat as well, because we always encourage community to reach out directly to the speaker, to his socials, and request I don't know, presentations and links, and ask questions, because people, speakers to be speaker is not that easy as it might seem. when Artem is kind of superstar presenting something. Well, lots of preparation and stuff. So we need some kind of feedback and response from you. So please follow Artem. And I see like 10 or maybe more people in my LinkedIn also connected, and I connected everyone. So I encourage you for this.
Sounds good. Will do.
Yeah, of course. And the question to you, and I see the next speaker in my backstage. I'll probably turn your presentation off, and also add Adam here. Hey, Adam, how are you?
Hello. Good to be here. I'm fine, thanks.
Yeah, I'm happy to see more and more speakers coming back. One more time. Here's a question to you people. Do you use AI in your daily work? Yeah, I see these smiles on every hand because I ask this question to all kind of speakers I really touch to, and I hear real different and weird answers. So yeah, Artem, what do you actually use?
I mean, that's obviously that we use something, right?
Okay.
But for me personally, Copilot is the best thing ever, and
All
yeah, I
right.
cannot imagine to work without it nowadays. So yeah,
Oh my
I'm
God.
spoiled.
All right. People from Microsoft are definitely using GitHub Copilot. That's for sure. But yeah, it's awesome. It's great for sure. Yeah, the most popular answer. Well, ChatGPT is helping me write my emails. That's what most developers say when I ask about. Yeah, and Adam, what do you personally use in your day-to-day job?
I don't really use AI for coding, and I'm going to talk about it in much more depth. But I do use AI a lot for my writing, and particularly I use ChatGPT to critique my writing and give comments and suggestions. I found that very useful.
That's awesome. Yeah, thank you for sharing, Artem. Let's stay in I don't know, connected for the Q&A. And Adam is here today for the presentation. He will be speaking about building the future, exploring the fact-based realities of AI-assisted coding. That's intriguing because on the beginning of this AI era, we heard, "Hey, AI will do everything, will generate everything, and there will be a fire." And now I see more and more mature feedback of what happens, what doesn't happen, and what will never happen. Yeah, Adam, thank you for being here. The stage is yours. Just go on.
Thank you very much. And good morning, good afternoon, everyone. And welcome to this session where we're going to explore these fact-based realities of AI-assisted coding. And in this session, over the next 25 minutes, we're going to cover both the good, the bad, as well as the slightly ugly side of AI. And we're going to do so by starting all the way back in 1977. And the reason I want to go back in time is because I recently got exposed to the promises of AI-assisted coding in a, let's say, unexpected way. Because earlier this year, I picked up a new hobby. I decided to learn to write games for this beautiful machine. Not sure if anyone recognizes it. It's an Atari 2600 from 1977, a gaming console. And that hardware is a little bit special. First of all, when you start to code on that machine, you quickly notice that there's no operating system. You have to implement everything, all the low-level stuff in assembly. Another thing you quickly figure out is that machine has only 128 bytes of memory. So that's a little bit constraining, isn't it? The good news are you're compensated by full 4 kilobytes of read-only memory. The bad news are that you have to use those 4 kilobytes not only for your game logic, but also for all your graphics and sounds. So I think it's fair to say that this hardware is not really LLM ready, right? So I struggled a lot with getting started to code on this computer, but at some point I managed to wrap up my first game and I pushed it to GitHub. And now something unexpected happened. I suddenly get to see an ad that claimed I could code 55% faster using Copilot, one of these AI tools. And that, of course, raised a number of interesting questions. First of all, I mean, do I really want to become 55% faster at my hobby? What do I do then? Do I find another hobby? And on a more serious note, I also start to ask myself, 55% faster at what? So my guess is that all of you have heard this claim of 55% faster. I'm not sure, however, if all of you have also read the research paper that this claim is based on. So let's take a look at the research behind it together. So the actual paper is a pretty good research paper. I like it. And the reason I like it is because, as all good research, this paper makes a very good job at specifying the limitations of the research. And I want to highlight some of these things for you here. And you don't have to read that whole wall of text, right? I'm going to walk you through the important details here. So first of all, what the researchers behind this study are very clear on is that there's no guarantee whatsoever that the measured productivity benefit, this 55% faster, that it actually generalizes to real-world projects, right? They just measured it in an experimental setting. So that's something to be aware of. The second thing I find particularly interesting is that the researchers also finds evidence that less experienced developers benefit more than experienced people. And this is something I find interesting because it could be a positive thing. It could mean that AI might aid the route into coding, right? So that's good. However, what worries me a little bit is the last claim here, that this study did not examine the effects of AI on code quality. And we're going to come back to what that means in just a minute. But what I want us to do now is to really question this. If we can have a tool that helps us generate more code faster, what are the implications? What does it mean to us as software developers now and in the future? And I like to think that there are two major implications. One very human motivational implication and another financial implication. So let's start with the human side. Because I, like so many other people, we went into programming because we like to solve problems. We like the creative aspect of it, right? In solving something new, in designing something that didn't exist before. And now when we make AI good at writing new code, we are basically outsourcing the fun to the machine, the fun and creative tasks. And as the quote here, it's a lovely quote from Kevin Hennis says, we took the fun bit out and we're just going to give ourselves code that somebody else wrote, in this case, a machine. And it turns out that that's a significantly harder problem to understand code that someone else wrote, right? We're in like a constant onboarding mode. And this ties into the second implication, the financial side of using AI-assisted coding. And at this point, I really like us to question, are we, as a software community, focusing AI on the right problem? Because today's AI assistants, they are very much focused. Their sweet spot is on helping us writing more code faster, new code. However, as we see in this diagram, writing new code is really just a small part of a developer's work week, 5%, right? And 5%, just to put that into context, if we have a tool that makes us 55% faster at writing new code, then that translates into 1 hour saved per work week. And of course, I mean, 1 hour, that's good, right? 1 hour is 1 hour. If I had an extra hour, I can spend more time coding on my Atari 2600, so it's a good thing. However, it's not particularly groundbreaking, nor is it particularly disruptive. What I find interesting instead is that if we look at this chart and see where we developers spend time, we see that the majority of our time, 70%, is spent trying to understand existing code and understanding systems so that we know what to change. So to me, this is the big win. What if we could focus AI on optimizing for understanding? And if we do that, then there's no need to settle for just 55% faster. We can actually become 10x faster. And I know that this sounds like a ridiculous claim, but you will be happy to hear that it's supported by data. So let me walk you through the evidence behind the 10x improvement that's possible. So that figure comes from this graph that you see here. And this graph is from a research paper me and my colleague, Dr. Marcus Borg, did a year ago. It's called Code Red, the business impact of code quality. And what we did here was that we categorized code in 3 different categories. You can have green, healthy code. That's code that's easy to understand. You can have yellow code. That's problematic code, right? That's hard to understand. It's full of accidental complexity that don't have to be there. And if you're not careful, you might end up in the red category, which means it's code with a lot of technical depth. It's code that's really hard to understand, on maintenance nightmare. So what we did in this study was that we categorized lots and lots of code, million lines of code in these 3 categories, and then we measured the time spent in development. How long does it take us to make a change to that type of code, adding a new feature, fixing a bug? And that's what you see on the y-axis. And as you see here, making a change to red code can take up to 10 times longer than a corresponding change to green code. So what that means from the perspective of this presentation is that if we have red code and we could somehow use AI to make it healthy, then we could indeed become 10 times faster the next time we touch that code. So code quality seems to be our potential, but there's much more behind this. Because as AI accelerates the creation of new code, code quality is going to be really, really important. Because again, if you look at that graph, if you have a tool that creates a lot of code for you, you want to make sure that that code is green, because at some point you will have to understand and look at that code, right? And the reason this is important is because code quality is not only about speed to market, it's also about onboarding costs. And we see here in a follow-up study to the Code Red study that yellow and red code comes with a significant onboarding cost. So it turns out that if you're exposed to code that you didn't write yourself, and that code has code quality issues, then you're going to need 45% more time to make a tiny, tiny fix to it. You know, like a small task, like a one-line bug fix. If there's something larger that you need to do, maybe you touch a piece of code due to implementing new features, you need to make larger changes, then you have to use almost twice the time you would have needed if you instead worked on green code and had to onboard yourself there. So unless we can guarantee that our AI assistants generate healthy code, we're going to carry a significant onboarding cost going forward. Now, with that said, how can we refocus AI to the big win? How can we refocus AI to optimize for software maintenance, to take red code and turn it green? That process is, of course, known as refactoring. And most of you have probably heard about refactoring at some point. It's basically the process of improving existing code without changing its behavior. And that sounds like a very simple statement, but if we look under the hood, there are 2 really, really important parts to refactoring. First of all, it directly follows that it's not a refactoring unless we improve the design. And this means that we need some kind of objective measure if one design is better than another. How can we get that? Well, in a minute, I'm going to show you. But before I do that, I also want to point out that it's not a refactoring if we fail to preserve the behavior of the code. Because if we fail to preserve the behavior, then we're introducing a bug. And if we violate any of these 2 assumptions, then we are not doing refactoring. What we're doing is something different. And that different, I think, has a name. I think the technical term is refactoring. Yes. So for the process of this presentation, we're going to run with these 2 terms, refactoring versus refactoring. And the purpose of a refactoring is, of course, to optimize for understanding, optimize for the big 70%, the big win. So can we use AI to automate refactoring? To answer this question, me and my team, we did a large-scale study earlier that we published earlier this year that we called Refactoring versus Refactoring. And I want to walk you through the results of that study to see what we found. But before we do that, I want to introduce a metric to you that I've already mentioned. Because remember, to decide if something is a refactoring, we need to be able to objectively measure if one piece of code is better than another. So that means we need some kind of a gold standard for code improvements. And what we decided to do in this benchmark was to use the code health metric that we used in the code red study. And I want to give you a high-level overview of how the code health metric works so that you know what you're looking at. So first of all, code health is a metric that works at the file level. So you basically take a file with source code, could be a module, could be a class, and then you parse it. And then you analyze that code for various code smells. Properties of the code that makes it more complicated than it has to be. That's basically a code smell, something undesired in the code. And these code smells can be at 3 different levels. So at the highest level, we look for things like module or class level design issues. And a good example is low cohesion. Some of you might have heard about low cohesion before. Low cohesion basically means that you have a module and you kind of squeeze the solution to too many business rules into the same module. Now that module is hard to understand because to understand it, you need to understand all these business rules. And of course, there's also the risk for things like unexpected feature interactions, which are some of the worst type of defects you can ever have. Then at the function level, we look for other things, classics like copy-pasted code, or functions that are overly complicated, long, complex functions that, again, squeeze a lot of business rules into the same function. That's known as a God function. And at the lowest level, at the implementation level, we look for various complexity patterns. And to just give you one example, we look for things like deep nested logic, for example. When you have if statements inside if statements inside if statements, and then maybe a loop for good measure. That's deep nested logic. Now, in total, code health includes 25 different code smells that we look for. And what we then do is that we aggregate these findings and categorize every single piece of code as being in one of the 3 code health categories. And I just want to point out that when code is yellow or red, it's never due to a single factor. It's always a combination of code smells that work together to make the code harder to understand. All right. So now that we know what we measured, how we could decide if code is better or not, we can finally start to look at the benchmark. Can AI help us refactor code? And to answer this question, what we did in the study was that we had a large data lake that consisted of more than 100,000 refactorings of real-world code. So we have the before and after example. And I want to show you what we found. So if you look at this table, what you see to the left is the different foundation models that we tested. And you see that we included language models from OpenAI, Google, Llama from Facebook, and so on. And the first thing we checked in the column valid code is the syntax that the AI created. Is the syntax correct? And we see that the AI seems to be really optimized for that. In general, the AI does a really good job at generating valid code. So far, so good. However, the first big drop-off comes in the next column that says code health improved. So here we checked, is it a refactoring? Is the code better now than it was before? And we see that the AI fails to improve the code in roughly 30 to 34% of the cases. So that means in 1/3 of the cases, the AI either fails to improve the code or makes it worse. That doesn't look so promising, does it? Finally, in the last column that says valid refactoring, that's where the really big drop-off happens. Because what we did now was that after the refactoring, we rerun the tests on that code. So we only included refactorings that were covered by tests. And what we see here is that the best performing AI can only generate a valid refactoring that preserves the behavior in 37% of the cases. So what that basically means is that in 2/3 of all refactoring attempts, the AI will either break your code or make it worse. So a 65-70% error rate. What if you had a coworker that broke your system in like 60 to 70% of all commits they were doing? Would you be happy? My guess is that that coworker would be asked to look for new challenges promptly. But when it comes to machine, we somehow seem to accept this performance. So to me, this looks a little bit depressing for the future of AI in software. However, we choose to take a positive outlook on this, because after all, there are good news here. Because yeah, if you break for the 63% of the code, that's obviously not good. But the flip side is that 37% of the refactorings were actually correct and helpful. So what if we could somehow separate the good from the bad refactorings? That would mean that we could fix 37% of all application code technical debt out there. That's a massive, massive win for many businesses, and something that can help make our day job as developers much more pleasant, right? So how can we make that happen? Here's what we did. So we quickly figured out that an AI on its own won't be able to safely refactor code, so we need to build a safety net around it. And the way we built this, and by the way, it's available as a Visual Studio Code plugin that you can try out for free, but I want to walk you through the high-level idea here. So what happens now is that as a developer, I might work on some code, and I see that I've introduced some code smell. What I can do now is I can request a refactoring, but instead of going directly to the AI, we go to something we call a model selector. Now, that model selector has an interesting history, because when we did this large benchmarking report for all these AI services, we noticed some patterns. It turns out that some foundation models are simply better at refactoring certain problems than others. So this model selector is simply a machine learning algorithm that we have trained to select the right AI for the job. So now when my refactoring request goes to model selector, the model selector might say that, okay, yeah, in this case, OpenAI is the best choice, or maybe it's Google. So we send a request to the AI that was selected, and we get a piece of code back. What we do now is that we fact check the AI results. And we do that first by checking that the code health improves, otherwise it's not a refactoring. We also try to check if the refactored code is semantically equal to the code as it looked before. And if it's not, then we know that the AI has broken the code. And in both of these cases, we can discard the incorrect AI solutions. And maybe we go back and try another model, or the same model with a different temperature. And at some point, we might get a good refactoring back. And we can then confidently propose that refactoring to the user as a better way of implementing the code. All right, enough with the theory. Let's look at some actual refactoring examples. So here's an example from some open source code. And I think we can all guess immediately what code smell this is, right? We don't have to even read the code. We can quickly just look at the shape and see that this is indeed deep nested logic. So how can we refactor this type of code with AI? Here's an example on how it looks in Visual Studio Code. So it's the same piece of code here. And I see that the Visual Studio plugin has highlighted that, yeah, you have deep nested complexity here. But you see to the left of that, you see that there's an auto refactor button. So what happens when I click on that button? Well, what happens now is that under the hood, this request goes to the model selector, we find an AI, we get the response, we fact check the results, and we display them to you as a user. And we can now review the code and see, does this make sense? Is that something I want to have in my code? And if yes, then I can apply that change. And I see that the code smell is gone. Deep nested logic is resolved, and my code is now a little bit easier to maintain. All right, that was almost too quick, wasn't it? Let's look at one more example so we can really see what's happening. So here's another type of code smell. This is something that's called a complex conditional. And a complex conditional is simply when you have a complicated logical expression inside a branch, in this case, an if statement. So you see you have element type equals regular element and and so on. So the problem for me as a developer is that I can see all the details. I can see exactly what happens, but there's nothing in that code that explains why it happens. There's nothing that captures the business rule, and that makes that code hard to understand. So again, let's see if AI can help us. So I click on the auto refactor button and I get the proposal back. And I see here at the top here, that's the result of the fact checking. So I can see that this refactoring is guaranteed to improve the code health and very likely to preserve the semantics of the code. So again, I review it, and if I like the solution, I apply it and get rid of my code smell. So let's see what the AI actually did here. And this is something I find interesting because it turns out the AI is very good at one thing that we humans are not so good at. And AI is good at naming things. And we see that what the AI did here was that it took that complicated expression, extracted it to a new function, and put a good name on it. And it might look like a super simple solution, and in a way it is, but it's a simple solution with big benefits. Because what we have done now is that we have encapsulated that conditional, and we have put a descriptive name on it, delivered by the AI. So I would like to claim that the code is now significantly simpler due to that small change. So with that covered, once we have implemented that solution, what we did was that we rerun the benchmark to see how much can we elevate the AI performance on refactorings with the fact-checking model. And you see the numbers here. And as reference, we selected GPT 3.5 that you see in the top row, how well it performs on 4 different code smells. And below, you see the fact-checking model. And what we see here is that by introducing the fact-checking layer, we can, and the model selector, obviously, we can elevate AI performance to 97, 98% correctness. And I know what you think, 98% correctness. Does that mean that if I do 100 refactorings, I will break my code in 2 of those instances? Yes, that's exactly what it means. However, what I want to point out is that 98% correctness actually exceeds human expert performance. So by augmenting an AI with the fact-checking model, we can finally raise above human expertise when it comes to refactoring. So to summarize this talk, I like to claim that now, when we're entering the age of AI, I think there has to be a shift where it's going to be more important that we design for comprehending code over mere writing it, because comprehending code is where we are going to spend our time. And AI is going to impact code quality, and it's vital to us that we approach AI with a safety net and guardrails. Because creating more code faster simply isn't useful if it's driving our project straight into a brick wall of technical debt. So what I want to show you in this presentation is that if we refocus AI on the big win, to use AI on the mundane and hard task of improving and refactoring existing code, then we can optimize for understanding, which is the dominant human-intensive aspect. And I'm going to come back for a Q&A later, but I wanted to drop a couple of references for you here in the slide deck. So first of all, you have the Code Red research paper if you want to read up on the correlation between code quality and velocity and defects. The second reference is the refactoring versus refactoring white paper, where you can read about all these detailed results and benchmarking. And the tool we used to measure the code health was CodeScene. So if you want to do this on your own code, feel free to try it out. And finally, if you want to try these AI refactorings, then they are available for free via the Visual Studio plugin. So if you go to codescene.com/AI, you get the link to the Visual Studio plugin as well as more information. So with that said, I want to take this opportunity to say thanks a lot for listening to me, and I will be back for the Q&A later. Thank you.
Thank you very much, Adam, for this presentation. Well, it's impressive, and the tool you guys created looks real promising. Well, yes. Well, in the refactoring scene, I see lots of interesting projects, and we also have this dedicated AI for software development conference where we invite startups that creating something in the field, and they are really promising. Thank you for sharing this. People, I encourage you to go visit CodeScene website and use just to play around with this AI plugin. guys created. Thank you very much. And yeah, see you on the Q&A. I have I have real great expectations of this Q&A session. Thank you very much again. And
Thank you very much.
I'm inviting here the man who's naming himself Angry Ronald. Hey Ron, how are you? Why you are so angry?
No, it's my name. So I'm coming from non-English speaking country. So my father gave me the name. It sounds good in here.
Oh, real?
Yeah,
Oh, real? But
the
it's
real
still
story.
fun.
Yeah.
That's fun. Yeah, okay. And well, how are you today? What's what you brought us to this? To this event.
CQRS, I think. Oh, it's about the trade-offs of implementing CQRS. It's very challenging and very fun. Yeah.
Yeah, of course. So Ronald is here with trade-offs, and yeah, let's give the space to this talk. I hope you're prepared, you're ready, you're supercharged, and let's do it.
Oh, thanks, Ed. Yeah. Okay. Hi guys. Yeah, my name is Angry Ronald, as you may see, and yeah, you may call me Ronald anyway. So yeah, I've been like a software engineer for professional software engineer for about 7 years now, and I mostly do backend all the time. So yeah, I think that's all. And you can find me on my social media. It's Angry Ronald. So yeah, let's start. Let's start about the talk. So I'm going to talk about trade-offs of implementing CQRS, and yeah, this is based on my previous project and current project as well. So yeah, let's start. So 1 second. Okay, so what is CQRS? CQRS is originally comes from common query separation. It's from Bertrand Meyer. It's basically kind of like separate the process of writing to DB, what we call command, and query, which is reading from DB. And yeah, I quote the statement from Bertrand Meyer, and it's very good. Let's read it. Like every method should either be a command that performs an action or a query that returns data to the caller, but not both. So this is the point, not both. And in other words, asking a question should not change the answers. Yeah, and also I think Greg Young calls this one becoming like a command query responsibility segregation in 2010, which is kind of like separate the model, kind of like differentiate the model between writing and reading. That's the point. So I also quote Martin Fowler in here, which is at its heart, it's the notion that you can use a different model to update information than the model you use to read information. Okay, so this is the basic example of like without CQRS, the service without CQRS. So the client, we have a bunch of clients in here, and then I'm going to request to the API gateway, and then the API gateway will redirect the request to the service, and then it will end up in the database. So this is basically without CQRS, which is we are only using database, the same database for reading and writing. And but there is a thing, there is a issue with this, because what happens when we have a complex query? So from my experience before, when we decided to move to the CQRS, we facing the issue which is with complex query. At first, we have like to join like 11 tables, and this is very very bad queries because the execution cost is very expensive. It's very bad, and we try to optimize the query, but what if the optimal query is still quite expensive? That's becoming another catch. And the other thing is like when we migrate to domain-driven design, so how to deal with the code complexity in terms of coupling? Because in domain-driven design, especially when we implement like repository pattern, and then one business entity should be reflected by one repository class. So there's another issue. So another thing is like what happened. Okay, so the thing is, if it's just release product, it's going to be okay with complex query. But what happened after 6 months when the data becoming enormous and it's going to be worse than before? And what if they are only atomic transaction? And I mean, like, what if we only read from one database, but after 2 years, and then the data becoming enormous? So the thing is the same, which is the execution cost is very expensive, query execution cost. And then what if we already try to optimize the query, but it's still quite expensive? So another case is, what if we store the data historically, or we use event sourcing as the data source of truth, as the source of truth? So the thing is, we faced this kind of like issue in the last project, which is we store the data of stock historically. So we have like the dynamic stock. We didn't store the stock, I mean, like the normal one, but we store it like historically. It's helped us to understand about the data. But the thing is, every time we try to collect the summary of the stock, it's going to calculate the stock. We fetch the data, which is big because it's kind of like appending all the time, and we need to fetch all of the stock data and then try to calculate it and then get the last stock, which is the current latest stock. But it's very bad because you need to do calculation during the request, during the read request. It's bad. So the other thing is like, what if we already implement the database sharding? It's very good one. It's very helpful with the writing and reading, especially with the real-time data. But to generate summarized data becoming an issue. So in this example, I show you that we already have a sharding in here, but the sharding is based on month of the orders. So this is, for example, January, February, and March, and so on. The thing is, the request coming for get order from January to April, and we are going to collect the data. But the thing is, the process of summary the data, kind of like extract, transform, and load, it's happening in the application layer. It's very bad. So this is another issue. So we kind of like implementing CQRS. So now this is the architecture design when we are implementing CQRS. So you may see that the request coming to the API gateway will be redirected to the service. And then when the request is related with the command request, which is writing transactions, it's going to go to the write DB. And if this about the read transaction, it's going to go to the read database. So in this case, I show you the sample of using hot storage, which is cost in this case. And when the cost is going to be updated, because the data is only stored in the write database. So the thing is, when the write process is finished, and then we are going to publish this event, which is the data that published at the process data in here, to the message broker. In here, I use the example of RabbitMQ. And then the worker in here, which is the subscriber, going to listen to the event and then start updating the read database. So it's going to be eventual consistency, because at some point it's going to be consistent, but not consistent at the same time when the data is written. And there's another question. I got a lot of questions from my teammate and brainstorm during this current project right now. They are asking why is it possible to use the cold storage for read and write? Because the hot storage is quite expensive. So it's possible, because last time in the previous project we used cold storage, which is the database, like Postgres at the time, and write it's also Postgres. So we kind of like using cold storage for both of them. But there's another catch, which is like, if both of them are cold storages, so what are the differences? So the thing is like, implementing cold storage as a read database require more care. I mean, like, we need to put more care in it, because otherwise it's not going to be improved significantly. So what we are doing at the time is we store the data only for 3 months data. So we limit the data only for 3 months data, kind of like partition the data. And then we denormalizing all of the tables in the read database based on the use cases. So it's becoming like a OLAP DB. And then we adding the right indexes. After all, we are going to analyze the query performance. So it's very important to analyze the query performance every time you make some change. So the last one is very important, because the data longer than 3 months going to be removed. But what happened to data with longer than 3 months? So we are going to transform the data into a snapshot. so we still can use it. So that's the case. So by implementing CQRS, the read data will become eventual consistency, and write data will be consistent during writing process, and the data will be calculated on writing process. So we don't do calculate or computational calculation on the reading process. And the process, here's the process. So latency will be very, very low, especially when you are using hot storage for as the RateDB. But yeah, there is a trade-off. We are going to talk about it later. And fetching big data is no longer a problem. You may see that the big data has become already, because the data in the read database is already summarized, and the historical data or event sourcing is no longer an issue. Yeah, because everything is already summarized as well. Fetching summary data will be as fast as the flash. Yeah, you may see. And no more bottleneck with the polling issue during the peak traffic, because what we face at the time is when we have like a peak traffic, when the operational, which is the marketing team, start giving out the promo, the coupons, and then because of the customer behavior, which is really low promo, so the traffic, the transaction is increasing significantly from 80 to 150 requests per minute to 5,000 requests per minute. Is kind of like very crazy, because yeah, they also do marketing very good in the correct way, because they use the online influencer, which is very famous one, and it's also really working well. So yeah, and then the querying complex query is no longer an issue, yeah, because the same as previous one, everything is already summarized and denormalized. So yeah, it seems really good, right? As Uncle Ben said, with great power comes great responsibility. So enough with the good parts. Now we move to the trade-offs. So there is a lot of trade-offs in here. So I will breaking down one by one to you. So it's going to increase code complexity, because we need to implement like asynchronous process like this one, because we need to publish an event in here, and then we need another worker or subscriber to update the read database. So this one, and another one is if it is a cold storage, and it's going to be another complexity, because we need to adjust the schema on the read-DB, because the schema on the read-DB is different with the schema on the write-DB. And also we also need to adjust the worker every time there is another change in the object property. So yeah, there is another one. And also the code complexity also increasing when, especially when we are using like domain-driven design with layered architecture, because we need to implement the command and query. We need to distinguish the command and query in the application layer. So the process in writing and reading is kind of like distinguished in here. And there's also an issue with the single point of failure. So what if the event failed to publish? Should we roll back all the committed transactions? From the customer point of view, when I create an order, the important thing is the order is created. The issue with the publishing event is not a problem with me. So do we need to cancel or roll back the order created because of the publishing event is becoming an issue? So I don't think so. So that's why we need to implement like another solution, which is transactional outbox pattern in here. So transactional outbox pattern will help us to not publishing an event directly, but we are going to insert the event into the outbox table. I'm sorry for the noise. My dog is quite noisy this time. Okay, and the outbox service, which is going to run concurrently and read the new event in the outbox table, and then start sending it or publishing the event. And if it is failed, then it's going to retry all the time. That's how it does the transactional outbox pattern. But there is another catch. What if the data still not there until the request fetch come? So let's say that I already create the order, and then as the customer, after I create the order, and then I try to see the order, but there is no order I created on that list, on the dashboard or the application. So I cannot find it. So I already created the order, but I cannot find it. It's going to affect the user experience a lot. So it's very bad. But we would like to avoid this kind of thing. So we need to implement like a fallback mechanism to pull the data from the write DB and then push it to the read DB. So if you, in this case, I show an example. using domain-driven design, also with the layered architecture. So the application layer will be differentiate between the comment and then query. So inside the query, we injected two kind of like services. This is iOrder service, which is the interface with the order service, and then iOrder service with the fallback order service. And the order service, which is implemented the iOrder service, is injected with the iOrder repository. And the iOrder repository going to be have two concrete classes, which is the order SQL repository and order cast repository. So what we are going to inject in the order query, we are going to inject with the, for the order service, we injected with the order cast repository. So it's going to be very fast if you are going to use cast or maybe another readDB. And then the fallback order service, we are going to inject with the order SQL repository. So yeah, when the data is not found in the readDB, and then we can collect it from the writeDB. So it's help us with this one. What if we found the data? What if the issue is different? What if the issue is about the updated data? So the data is already inserted, but the data is not updated. So here's the here's the example. Let's say that I already create the order, and then the merchant already accept the order. So the order is already there. But the thing is, there is an issue. This is normally happen. We face this issue when we found when we are having like a heavy traffic, because the system's going to be act differently when on heavy traffic compared to the light traffic. So let's say that you are in the development stage, everything seems to be seamless, smooth, good. But when you are on the production and the traffic is normal, like low traffic, it's going to be okay. But when you are in the peak traffic and it start to be drifted, I mean, like the mean time start to be longer. So what if the data is still not updated? And in here, in this case, so the example is I already create an order and then the merchant already accept the order, but I cannot see the order is already updated. For some time, I cannot see the order is already updated. If it is only for like 2 seconds, 3 seconds, 5 seconds, I think it's okay. 10 seconds, it's okay. But what if it's already 10 minutes or 15 minutes? It's still not updated. That's becoming an issue of the user experience issue as well. So what we do at the time is we adding another worker, which is running concurrently every period of time. So we have like a worker running for 2 seconds, every 2 seconds, every 3 seconds, and another worker running for every 5 seconds. This is needs to be communicate with the UI UX team and I mean like the stakeholder, because you need to understand the tolerance time in terms of waiting. Also, remember to do it wisely with batching. So here's the example that I show you. There is another worker in here. We are going to fetch the data from the database, and then after it, we are going to update the data in the read database. But remember to do it wisely with batching. Otherwise, it's going to be perform very worse. Also, avoid unquery problem, because when you are dealing with the complex query, and then you are going to most likely having like an unquery problems when you are using domain-driven design. So in terms of instead of using like facing unquery problem, you can also face passing like IDs. And for batching, let's say you can put a flag in here, like a last updated app as the flag that what we are using. So we are going to check. Let's say that the last updated app is kind of like 5 minutes ago. So we are going to collect the data only from 5 minutes ago. So it's going to be not collected all the data, but only 5 minutes time window data. So it's not that big. And then we are going to start updating the data. Okay, but the other thing is for the same issue, but on the cold storage, it's going to be more complex because the worker needs to do the extract, transform, and load. Because the data in the database in here is all of data. And we need to do ETL process in here. So what we are going to, what the worker is going to do is the worker is going to fetch the data, and then extract, transform, and load the data and put it inside the readDB, which is already denormalized. But there is another issue with the rest condition issue. Especially, this is most likely happen in the peak traffic during heavy traffic. it's happen quite often. So we need to implement kind of like optimistic locking. So here's the issue. So I already create an example. So let's say that there is 2 clients request at the same time, simultaneously, and the thing is, this the stock at the time is only 20. The first client going to buy for 10 items, and the second client's going to buy 15 items. So the thing is, the read DB is eventual consistency. So it's not going to be updated at the same time, especially during peak traffic. It's going to be drifted in the meantime. So yeah, be aware of that one. So what do we need? So the thing is, the first request coming from the first client is going to update the data into 10th, and the second request coming, and then going to execute the query. But the data is already 10th, so we cannot execute the query. And how to do the optimistic locking? So it's going to be easy. There is many approaches in implemented optimistic locking. So here's how we do it. I mean, like we update stock and then set the quantity and where the item ID passed by the item ID, and the quantity is bigger than the quantity going to be deducted. So when we are going to buy 15, the quantity must be bigger than 15. If the quantity is less than 15, and then it's not going to be good. It's not going to be executed. I mean, that's how we do the the optimistic locking. So another issue, like what happens if there are 2 requests coming? Oh yeah, for the previous one, how do we know if the data is not updated? We can check on the result from the updated result query. So it's going to be easy. So another issue is like we face this one on the customer address at the time, but I will show you the example of another problem. Let's say that there is another 2 requests at the same time. This also happened during the peak traffic. 2 requests coming and then try to update the same stale data, which is product description, for example. So we can also implement optimistic locking in here to solve this issue by passing the stale key. So what is the stale key in here? The stale key is the product description. So if you see the query in here, we are going to update the product, set the description, check the ID, and in the description, we are going to pass the description that we read from the read database. If the description is the same, and then we are going to load the update, but if the description is different, and then we are going to show another error. So the user experience is going to be smooth. So here's the example of the error. Let's say that the data have been updated just now by others, please try again. So it helps us. So yeah, there's also another consideration for the non-technical things, kind of like, we talk this about a lot, like kind of the thing is like choosing between hot storage and a cold storage. Hot storage is very expensive because it's using RAM. And you can imagine if you load your write data and then put 3 months data into your RAM, it's going to be enormous. Your RAM going to be, eat up by this data. So it's very expensive. So the cold storage is going to be more cheaper option. But the latency for the hot storage is going to be very low. It's terribly fast, but low throughput. There's another catch in here. So there's trade-offs, because when they are coming at the same time, it's going to be not scaled enough. But this one is going to be high throughput, but the latency is not that fast. I mean, like, it's not as fast as hot storage. And the complexity, the code complexity. Hot storage have like less code complexity because the structure of the key value, we just base everything on the key and store everything based on the value. So if the value is object or collection, we can just store it. So it's no problem. But in the cold storage, it's going to be more complex because we need, when we are using SQL database, we need to adjust the object domain. Another consideration is the knowledge of the team. So let's say that from my current experience because I'm setting up a new green project with this new startup. So the team, let's say that I'm working with the team, and the team is not really familiar with the CQRS. The understanding about the CQRS is not that deep, and it's going to affect the duration of implementation, the implementation of the CQRS in our in our surface. So there's another issue, and also impact the duration of the feature develop. I mean, like if there is another feature going to develop, and then it's going to be handled by the people who, by the teammates who are not really familiar with the CQRS, it's going to take longer time compared to the teammates they already familiar with the CQRS. So yeah, be careful about this one. Also, the more tools you use, the more money you spend. There is another issue in here. So yeah, there's a lot of issues actually. Okay, and the last thing is when should not implement. So for example, like chat service or real-time tracking position is very high read and write. So we need to think, is it necessary? Because the thing is, it's very, very bad if we implement the CQRS in here. Maybe we can consider using more suitable databases like Cassandra, because it's high throughput and also easy to horizontally scaled. So yeah. Remember, before implementing CQRS, there's thing you need to remember, kind of like evaluate the problems, assess the risks, calculate the cost versus benefit when using CQRS. Also prepare for mitigation plan, which is the one that we already talked. And keep in mind that your system is going to be act differently on heavy traffic compared to light traffic. And also due to the meantime, when updating the data, during the heavy traffic, the race condition going to be appears a lot. So yeah, be careful in here, because you need to come up with a grid plan for the UI flow, so the user experience going to be smooth. And remember, there is no silver bullet. And I don't really suggest CQRS to be implemented right away, right now, because you need to consider a lot of things. So please consider possible pragmatic approach if you want to, instead of directly jump to CQRS, because CQRS is having a lot of trade-offs. So yeah, for example, if you're dealing with the historical data, but there's another upper level table going to map them, like inventory and stock, but the stock is historical, maybe you can store the information of the stock, partial summary information in the inventory, so you don't need CQRS in here. And be aware of using read data, because read data is very tempting, it's very fast. So normally we kind of like tempting to use the read data. So be careful of this one, especially from the write process and on heavy traffic. Also, CQRS can be implemented in one database with different tables, but be careful with the pooling, because the pooling becoming like a sharing resources. There's a lot of question in here, so I think I already passing my time. So yeah, I will just rate it fast for you. So do we need it now? Do we need it now? And then how about the other feature priority? Should we put this ahead or not? How about the cash flow projection alignment with the release plan? What are the other dependent services we are going to use? Which type of storage we are going to use for the database? How much does it cost? Is it comparable with the benefits we got? How many resources we need to develop this feature? How many hours required to develop this feature? And yeah, I think that's all. And also I provide for you the sample of repository using CQRS with domain-driven design and layer architecture. So you may check on my GitHub repo. I think that's all I can share.
All right. Thanks, Ron. Thanks for this presentation. That was real deep. That was real technical. I kind of feel your experience. You're really deep in that. And I think I heard the other part of your team right now on the background, right? So someone was helping to actually present this presentation to you. So now we're here for Q&A session. And Adam is back, Artem is back, and Ronald is back, and is still here. And yeah, let's talk about the architecture, about the future, about the specific topics. But also, I'll ask Ronald my first question: Do you use AI for your work?
Yes, I use it most of the time. I use ChatGPT, by the way, and it's really helpful. But
all right. What do you exactly do with ChatGPT during development?
For example, that we are going to like I haven't implemented. So we are working on the chat service before, just about 2 weeks
Okay.
ago, and then I haven't I don't familiar with the WebSocket, so I can ask
Okay.
ChatGPT on the example of the chat service and then try to understand from there. So maybe the code provided is not really well executed code, but we can learn from it and then try to fix it. So I think it's very kind of like cutting off the time for the learning curve. So it's going to be help us to learn something very fast.
Oh yeah. Learning. Yeah.
Yeah.
Okay, got it. Thank you very much. And let's probably. I just wonder, Artyom, you mentioned you use uh, Copilot a lot. What do you exactly do with Copilot? Could you share some I don't know use
Yeah.
cases?
So the one of the best examples I can give that since I was speaking about specifications, I use Copilot to write these specifications because it knows everything about the schemas and what kind of data there should be. So I just provide some, I don't know, the comment in the spec, and then Copilot helps me with the implementation and the code generation as well. But most of the
All
times
right,
it just writes code.
it writes code for you. Wow, that's really your answer. Okay, so refactoring, learning, and then code generation. Well, that's nice. Speaking about AI and like your role of software architect, um, because most of functions we mentioned now is more more engineering stuff. But as an architect, where do you see maybe in future the impact of large models or AI or whatever? Here's my first question to you, my dear speakers. How do we leverage AI in architecture? I mean, in creating architecture, revising, especially at the prototyping stage. What do you think about that? Probably, probably I'll ask. Okay, Artyom, you turned your microphone on.
Yeah.
Go on.
I'm trying to be the first one to reply to this question because I personally believe, and I'm waiting for this moment when we have the technical interviews, specifically the system design step, and I believe when AI can replace the interviewer on the other side and just provide everything we need based on some requirements. I don't know, I need the video chat service, and it will, analyze all the inputs, all the users, all the workloads, and generate the whole architecture, which you can validate later with another AI or something like this. That I believe would be very, very helpful for software architecture.
Very similar to what Adam and CodeSyn does with refactoring. Adam, what do you think about like future of AI and software architecture?
It's an interesting topic, and what I personally think is that we have a long way to go. I think one of the big problems with AI assisted coding, I mean, I might come across as someone that's negative towards it. That's simply not true. I embrace it. I think AI has a lot of potential. I just don't think we're there yet, and I think it's being oversold. So this whole idea that you heard for like a year ago that AI is going to replace programmers, I think we are nowhere near that, right? I don't think anyone realistically expects that. But what I think looking into the future is that AI can help us with a lot of tasks that are extremely time consuming and super hard. I think in particular around software architecture, the whole observability feedback loop, I think that's like a sweet spot for AI, analyzing massive amounts of data, drawing conclusions based on that. And I can easily imagine like a chat interface, right, where I can chat with my running architecture, my running system, right, and draw conclusions that I could never do otherwise. So I think there's a lot of promise there.
Great. Thank you very much. Chat with your architecture. It's a nice selling point. Great. And Ron.
Okay, so from my experience, I think AI is very helpful because they are language-based model. I mean, like when we are talking about the best practice, implementing something like discussing about the system designs, it's not very common to implement the best practice of another company and just apply it right away in our company. So we need to adjust it based on our situation and conditions, like the traffic, the users, the workflow, everything. It's going to be adjustable. And when we are going to kind of like what I've been done in the past is I joined a conference and learning from the expert about how they are scaling things up. But is it really the one that I need? Is it really the one that answer my problems? Is the answer is not. So I need to adjust it. And how do I know something that which is on the gray area, which is I'm not really sure of because I'm not familiar with it. So how I can do it is by basically I can ask AI, ChatGPT, to discuss about this kind of thing, and then later on I try to understand, try to dive deep into the tools, the services. There is another things, and then yeah, policing from that. So it's going to be helpful. I'm like in terms of designing the system.
All right, all right. Thank you very much. Yes, we hope future models will be learned not from all Stack Overflow discussions and Quora and everything, but from I don't know, so somehow they will be filtered with useful only or something because sometimes it gives us weird answers. All right, so the first question from our audience, Ronald, goes to you, and please read the one and answer what you think here.
Okay, so CQRS has implementation complexity. Yeah, that's correct. Will vertical slice architecture vertical slice architecture the right choice with CQRS? I'm not quite sure I got the questions. So by vertical slice, I mean like you are going to do vertical scale. Vertical scaling it's going to be good, but it's going to be limited because the increase of the traffic it's not might be um, as the same as the your vertical scaled surface. So yeah, I think horizontal scaled will be very nice to be implemented on the CQRS. Oh, I'm on the right choice with the CQRS. On the right choice, I think you can use sharding for the right. You don't have to vertical scale for your DB. You can use sharding. It's also possible. Yeah, we experienced that one before.
All right, thank you very much. If any of speakers would like to add something on this question, if you're familiar with, please go ahead. Not really. Okay, then we'll go to All right, then we go to questions to Artem about yeah. We have two real long questions to you, so please read. It's on the first part, and then we'll
Okay.
go to second part. Not the project structure. Oh, sorry, no, it's just it stops here. Yeah, so is it
So
clear enough?
the main question here is how to fix the bug if there is no correct understanding of the project structure. I'm not sure that if it's directly connected to the specifications topic which I was referring to, but I can try to reply to this ask as well. So for me personally, when there is something what I don't understand about the project, I'm trying to follow the great principle, like 5 whys. And basically, if you have some bug and you understand the actual result of this bug, you can just ask why does it happen, for example, and then you can check the actual area of the project regardless of other project structure. You don't care about this at the same time. So basically, if you find a more deep level what might be a reason for this bug, you ask the second why does it happen on this level, And usually by asking 5 whys and going deeper into the project structure, you can find the actual reason and try to understand how to fix this bug. By the way, if you are using specifications with code generation, this will never happen because everything will be generated and you will be caring only about the business logic. So again, I encourage you to use that approach.
That's awesome, actually. Okay, I have next question to you, Artem.
Okay, I'm wondering
One,
how can we remove the code from the repository if that code is required? Oh, that's a great question. Yeah. So I also had this question when I started working with the code generation, and there is the great thing that basically the all code what was generated by this specification or by some pipeline or whatever it is, it still works on your local machine. So basically, when you work with the project, you run this generation command, but all these files will be excluded from your Git index. So technically, for all this IDE auto-completion, IntelliSense, and unit tests, it will be still in place. But you can just reduce the complexity of the code what would be pushed into your repo, because it doesn't need to be there to review the business logic. But it will be generated again during the build or release pipeline. So technically, you still have the same set of files on your local machine, but it's more optimized in your repository. And I hope that describes the behavior.
okay, thanks for answering. And next question is from me to audience. People, do you have any experience to use any AI tools for refactoring? Because Adam presented the interesting approach and explained that, but I'm interested to hear from you. Do you tried this? Can you imagine that in future you won't need like refactoring old code coming to a new job and stuff? Do you have any thoughts on that? Please share in chat. And we are going to our next question, also to Artyom. Very long question. I didn't know how to actually shorten that one. So could you please read aloud, and I will display the next
Yeah,
one.
sure. I will try to see 3 parts of the question, but okay, let's get started. For Open API, how do you solve the concerns of the developers of increasing their cognitive load added by needing to learn yet new tools, Go Swagger, handwritten YAML, and others? At our company, we tried solving this issue by creating your design document in your development language, which is by just writing the method signature without implementation and then generating the spec with swashbuckle by example, any thoughts. So yeah, this is exactly the problem I was referring to, because when you have this approach with the code first and generate the specification based on your code, you still have blockers for other engineers, because you cannot provide specification to your customer if there is no code. And basically, I'm not saying that it will be easy for your engineers to get on board to these tools like GoSwagger or YAML or something like this, but it will save their effort as well in the future. So there is still an effort to migrate from the current process to another process, but that's exactly how you can get improvements. So as I mentioned during the talk, that you should use at least 2 things to achieve this result. First of all is enforcement, and yes, it will add more cognitive load for your engineers for some time. And the second is try to use on a small projects at first. For example, if you have a small microservice, let's say with 3 endpoints, then you can apply the specification first approach on this particular service. And if everybody can get familiar with these technologies and experiment with it freely, then they will be able to migrate and apply the same approach or the development for other services. But yeah, nobody says that it's easy. At some point, you will struggle. You will spend more time. You will get some failures. You will face some errors as well. But after all of this process, you will never go back. Actually, that at least that's my opinion, because now I don't want to write code before the specification, because I can write the document and then everything is done. I can share with everyone and I can generate code, especially with AI. So yeah, that would be my answer.
And yeah, thank you. And just arrived the next question. Well, specifications like is a thing today. Everybody is like interested in. So yeah, please read this one.
Okay, when you say specifications, considering if we document our discussions probably with clients and then we have Jira stories for development, do we need to have specification document in that case? So when I say specifications, I mean all these documents which could be used for code generation. In particular, it might be Open API, which is Swagger. It might be a Sync API. It might be, I don't know, infrastructure as a code. It might be Kubernetes YAML files or whatever it is. So I'm not referring to the actual, let's say, Word document, because it is a specification, but not technical specification. You cannot generate code from it unless there is some AI tool, very advanced AI tool. But in this case, I would say that document that will describe how the project works is up to you. You can have it or you can skip it, because the main our main purpose is to deliver the product, right? And if you can deliver product without this document, then you don't need it. And I believe that this is a great thought, that everything what is optional is not needed. Since you can generate code only from the technical specifications like OpenAPI, I would say that this is the most important part.
All right, cool. Thanks for answering this question. Adam, I'm sorry we don't have more questions about the refactoring tool you described from audience today, but maybe you will share more about Code Scene. What do you guys do there? What's coming out? I don't know, to let us know what happens there. Maybe you have something useful for architects to share.
I think so. I mean, basically what I'm working on is to help us make code, software architecture, software systems easier to understand, because I think that's a must. I mean, we create more code than ever before at a faster pace than ever before. So I think that's a really important point, and I'd be more than happy to discuss this. So if anyone's interested, then feel free to reach out to me, and I'd be more than happy to have a conversation.
Great. Thank you very much for your input, Adam, Artem, Ronald. Thank you for spending time, energy, sharing with the community. Let's stay in touch. And I see, no, it's nothing. Yeah. Thank you very much and have a nice day. Bye-bye. And I mean, yeah, one more question probably to Artem, if you would answer that.
No, it's for Adam. For Adam, for sure.
Oh, for Adam, I'm sorry, yeah.
It says Adam at least, but yeah, I can try to answer it quickly. Adam, do you think that including AI code support or relying on AI for junior or entry-level developers deviates them from critical thinking and basic blocks of development? Yes, and I also don't think it's restricted to juniors. I actually think that AI in its current state is not a particularly good tool for learning. And it's not only due to what we popularly call hallucinations. It's also that I think that in order to truly learn something, we need to understand it at a deeper level. And I think trying to learn a new concept, a new programming language via AI leads to a very shallow understanding, right? So in general, I think we should be very careful with using AI for something we don't understand.
and more questions coming up. Thank you for answering. And next question to Ronald. Could you please read it?
Oh, yeah. Thanks, Ed. Ronald, for CQRS application to handle messages and handlers for all use cases, is it good to use mass transit packages? I'm not quite familiar with this too. I'm sorry. So basically, I'm using Go. So for handle messages and handlers, uh, I'm currently build the services based on Go. And then for the outbox, we create our own library to create the outbox. And it's going to do similar the way that I show you on the slide. And for the handlers, which is the one that going to like the subscriber or the worker, we are going to run it concurrently. So we register it and run it concurrently and listen to the event. So every event published or every event published which registered for that subscriber, we are going to listen to it and then start processing the data. That's how we do. So for the packages mentioned, I'm sorry that I haven't experience with those both.
That's fair enough. Yeah, thank you that for answering. And one more for now is for Artyom for sure, because it says Artyom.
Oh, yeah. So, yeah, I will read it. Is it possible to combine, let's say, Swagger and protobuf generation? I would say yes. Oh, it's just the beginning. Okay.
Yeah,
Or
I'm not sure.
is it?
Yeah, I'm not sure it was. Yeah, sorry for confusion. The question is over here. Yeah.
Okay, so let's start with this one. I would say yes, because in particular, you have two ways of keeping these specifications. And basically for protobuf generation, you usually use a gRPC in place to define what are the contracts. And for Swagger, it's more about REST APIs. So it is kind of different dimensions, but you can have it in one service and basically use gRPC for protobuf generation. And at the same time, you can right after this generate the code from Swagger. So it's still separately, but yeah, you can combine it, or even with async API as well. So you can have free specifications in your service and generate everything. So feel free to do whatever you want.
Feel free whatever you want. Thank you. And now this is to Adam about refactoring.
Yes. So should we have concerns sharing the business logic with the various AI models? So in general, yes, we should definitely be concerned. In the specific case, as tool vendors, we typically take care to make sure that your code is safe. So we went through, when we did this refactoring tool, we call it Codes in Ace, we went through all these legal hops to make sure that your source code is never persisted anywhere. It's never used for training. It's never stored. So we can give those guarantees. But I also know that it's non-trivial because it can depend on so many factors, like which API you use, which relationship you have to the AI service provider. For example, if you're an enterprise plan or in a free plan. So you have, in general, I recommend you to be careful.
Yeah, absolutely. Thank you for hinting us that it's important to be careful. Yes, I think that's all. And yeah, we'll get back to you guys in LinkedIn later, and hopefully we'll meet you someday in person. Thank you again, and have a nice day. And I'm inviting you here, our next moderator. Wait a second. Yeah, bye-bye.
Bye-bye.
Bye.
Bye.
All right. So now we have, yeah, here we are. Hello, Mihai. How are you?
Hi, I'm doing great, thank you. How are you?
So, yeah, I'm pretty good. I had that nice conversation, lots of AI stuff, lots of AI ideas. concerns somebody is real true believer in future and optimistic, someone's not really. And I think developers community is the most skeptical community on AI because we actually know how it works, right? So it's always interesting for me. And how are you? Where are you based? How you feel?
About AI or?
About anything you want. It's your time. You're moderator. You have plenty of time to talk.
Actually, I think we don't really have a lot of time. I think the next talk is supposed to be starting. Yeah, it's
really?
It says here it's 14:10. It's
okay.
In my time. I'm in Hungary, so the next talk is supposed to be starting. So let me
okay,
just
let's do it your way. Sure.
Oops, sorry. I'm not sure how much the cat is in the frame. The next
some shades of it, yeah.
The
Okay,
next
the stage is
speaker,
yours, and no more inclusion of mine.
Oh,
yeah.
okay.
Yeah.
Thank you very much. Okay. Terribly sorry, I'm not. I don't have a lot of experience as a presenter or moderator, but let me tell you about our next presenter, who will be. I will try my best. Ottavio Santana, and he will talk about Polyglot Persistence Unleashed, mastering enterprise Java architecture with no SQL databases. Ooh, that's a handful. I'm quite excited to see what this will be all about. Hi, Ottavio.
Hello, Mihai. How are you?
Thank you. I'm doing great. How are you?
Hello, Cutie. I'm fine as well. So you did almost. Is Ottavio with a strong A.
Ottavio.
Yes. And a bonus is while you're speaking, you can move your hand like Ottavio, almost Italian.
Ottavio.
Yeah,
all right.
You got a bonus. So
that's great. Could you talk a little bit about your presentation?
Yes. Today I will cover more about what is polyglot persistence. Because at the end, we understand about database, we want to use database, but usually we still use a single tool, right? So the majority is still using relational database. It is great too, it's modern, it's mature. However, you can use even more. You can explore more capabilities inside database. And that's what I will cover today. Because if you only know the hammer, everything becomes new. And that's wrong as well.
All right. Then the stage is yours.
Okay. Thank you, Mihai. So hello, everyone. I'm glad to be here. My name is Ottavio Santana. And today I will cover super crucial topics about database. Yes, you come to the right place. It is a software architecture summit. And we as software engineers, senior engineers, and architects should pay more attention in database. Because sometimes the performance issue comes from that side. Sometimes we spend a lot of time working on over-engineering, we spend time doing an hexagonal model, and for some reason, we forget to look in the database, we forget to put index, we forget to understand the strategy and the model inside the database. And that, trust me, it is a huge mistake that we do, unfortunately, more than often. So my name is Ottavio Santana, and I will invite you to understand more about why we care about database, why we care about persistence layer, and finally, how can I take advantage of this point with NoSQL database and Java. I put Java here, but because it is my favorite stack. However, naturally, if you are using Polyglot persistence, you can use with whatever language you wish or you want or you need. So that's up to you. Before I start, okay, let's forget those topics here. So let's talk a little bit more about NoSQL introduction. So what is NoSQL introduction? And why we care about database nowadays? And I love this moment because I usually mix what you do right now with the history. Indeed, because it makes sort of sense. We do have database, not just a software engineer, but humankind, because when you guarantee that the knowledge you be there for a long time. Okay, the main goal of database is to endure knowledge. It comes throughout the whole humankind. One way to structure information, to read information, to write information, to update information. And of course, nowadays we are using modern distributed database, but a long time ago, we were using temples, caves, database, and so on. So the main point here is storage information to the humankind. Octavio, okay, it is enough of history and philosophy for today. We are software engineer. We don't want to pay more attention on that. So let's talk more about database evolution, because everything that will come from that and for today is about storage information. Of course, we took information from the caves, moved to the library, and finally we are handled with distributed database. But why do we care? Why do we have database nowadays? Basically for three, if I can briefly say the reason, I can say three reasons, and as bonus, a fourth one. So usually when we talk about application, we talk about stateless applications, stateless API, but we have user, we have balance, we have accounts, we have a lot of information that must be there as the states. And where the state is at the database is where we do have our current opportunity, like the user informations, user balance, accounts, values, and so on. And the third one is the new opportunities. Of course, I usually mention the user case of a company in Brazil who had a black card, a super VIP card, and then they start to reading, understand the current opportunity, and they realize that a lot of clients consume a lot of wines. Based on that client behavior, they decide to have a winery, and that become the biggest in Latin America for 3 months. So the current opportunity, the VIP card, and the new opportunities, reading the database to create new business. On this case, the winery. But think about more about your business or the business that we are working for. And why do we handle, and what is the challenge that we have today? In the past, the data was super expensive, as you can see here. So we had $1 trillion for 1 terabyte of data. Right now, to achieve the something, we can do it with less than $100. So the storage is right now way cheaper than the past. Okay, why I explain about this? Because the relational database was born at the beginning of computer science. And the main reason or the main motivation to have normalization was mainly to save memory, to save space, because I will avoid duplicated data. Okay, so I save memory, I save storage, and based on that, I can save thousands or billion dollars. And as you can see here, that's where the relational database comes from. The normalization comes from here, where the data was super expensive. And as I said, that was the main reason to have relational database on that time. But as you might know, right now the data is super cheaper, and what I do have instead that's more expensive is the time. Nobody wants to wait anymore. So if you look to the internet 10 years ago, we need to go to the queue to get in the e-commerce to buy something. Right now, it's unimaginable. It's impossible to imagine that somebody to access any e-commerce need to wait in the line, because everybody wants to have instantaneous access. Nobody wants to wait. So our challenge today is not about memory. It's not about cost, but it's about response time. And as everything that we have in software architecture, we do have some drawbacks. We do have trade-offs for every decision that we take in software engineering. That includes the database itself. So as you can see here, you can take a look on our database, and as much information I do have, as much join I'm doing, more or less operation per second I'm capable to achieve, right? So yes, join can help me to normalize data, to get more consistent data, to avoid duplicated data. However, the performance might be hard as much information I do have. It's not bad. It's not about to be bad. It's not about to be good. It's about to be a trade-off. So normalization brings you something and put you in drawbacks another thing. And to achieve more results and to understand more what we do have and how we can move forwards, right now, we do have more flavors of database. It is not about understanding if you're going to use relational database and how are we going to use it. Because as I said, if you know Maslow, the person for pyramids, he also has or had the instrument law. That means if you only know a unique instrument, you treat these as solutions like the hammer. So everything become a nail because you only know a hammer. And that's where, to solve this issue, we do have the polyglot persistence. To understand that right now we have more flavors, we have more ways to achieve the same goal, that is storage information. And that's why we do have relational database, the classic one, with normalizations, operations, joins, relationships, one-to-one, one-to-any, end-to-any, and so on. Plus, NoSQL database that we do have right now. So we do have wide column, we do have graph, we do have document, and we do have key value. Does it mean that the relational database become deprecated? No, it's not true. That means we have more flavors. If you're capable to do analogy, if may I do, you can think about a person who is capable to speak several languages, a polyglot person. This person can be more adaptable to several environments. For example, if he speaks English, he's capable to speak with us. And beyond that, if this person can speak Italian, he can go to Italy more easily than a person that only knows English. If this person knows French, Italian, and Chinese, the flavors of opportunities will increase as much language this person knows. And that is the same idea of the polyglot persistence. So as much database I know, as much the idea of database I know, more adaptable I will design my software architecture. Okay, it's not about only know the NoSQL database, but how to use it. Most important, why use it? Okay, and based on that, okay, we cover NoSQL importance. We also have relational database that is also important, but even with that huge amount of database, we still need to face the landscape of persistence because we still have lack of documentation around maturity models, documentations in books around database, and persistence layer at all. So, for example, you as a developer might know about the CQRS. That is the most common, most popular maturity model to design an API or REST applications. But with database, you might know none because it's less popular. We do have several paradigms. Right now, I believe we do have Python, Java, and Ruby. Those language in the majority are objects. But with database, we do have key value, word column, graph, and so on. And this flavor here, this survey comes from Stack Overflow. And as you can see, we do have a huge amount of flavors. You don't have uniquely a single database. We have Postgres, SQL, MySQL, MongoDB, Redis, MariaDB. There is also Oracle, NoSQL, and so on. So we do have a huge amount of paradigms of NoSQL database and SQL database than paradigms with programming language. Of course, I'm talking more or in the enterprise perspective. So mostly all the time, we are talking about objects and object-oriented with programming language. And while that, with database, we have a huge paradigms. Okay? And every time that you come to go to understand, we have a huge amount of discussions around database and application layer, of course. Should I have a unique microservice to a unique database? Should I not have it? What are the trade-offs? And how to create database agnostics. This way I can navigate through several databases without any impact inside my application. And that is a huge challenge. And be honest, there are even more. For example, every time we talk about database, we are talking about modeling. And that is not easy to decide. Why? Because it's usually the first thing that we do. In that moment, we don't have enough maturity of the product. We don't have enough maturity of the product and the business perspective. And the price to change or refactoring code the database is way higher than application. Because with application, I can refactor the API just using the IDE. And on the other hand, with database, I need to do migrations. I need to keep things going with evolutionary data. So we are talking about a huge challenge with with data itself. Okay. And going beyond that, let's move on to talk about the topic and the challenge that we're facing right now. We live in the civil war between the application and the database, because mostly of the time we are dealing with different paradigms. So Java, Kotlin, and Python, we are mostly talking about objects. And on the other hand, we do have our database. That's not, in majority of the case, relational database. We are talking about relational database. We are talking about NoSQL database. We are talking about a lot of stuff, or new SQL, and so on. So the point here is we are talking about two different behaviors, two different words, and to unite that, we do have what we call mapping mismatch. And what does that mean? In application side, I do have inheritance, I do have polymorphism, I do have encapsulation, I do have types, I do have a huge amount of flavors that it makes sense for me on the application side, but my database has no idea, because my database only knows about normalization, denormalization, and any kind of structure that I do have on my application side. That means when I do have the relationship between person and address, in the application side, I'm talking about pointers. But of course, on my database side, I'm talking about relationships or embedded document and so on. So two different aspects to achieve the same goal. And how to handle that? Of course, we do have several patterns strategies for making our life really, really straightforward and easy. So we do have those patterns here. So driver, repository, data mapper, active records, and DAO. And those application patterns are around the proximity or the application or the database. As much closer of the database, I will navigate through the database-oriented programming. As much closer I go to my object, I go to my application, I might go in the majority of the case as object-oriented programming. And as you might know, those aspects are totally different. It's extreme. So data-oriented programming, this is a good book to mention today. So data-oriented programming with Java, but you might know have most popular with Rusty and so on. So the main goal here is separating the code from the behavior. The idea is to expose data, representing data with generic data structure, and treating data as mutable. Okay? And the last one here is separating data schema from data representation. So my goal here is to expose data as much as possible. And on the other hand, I do have my application that goes to the opposite. So if you are familiar with the clean code book from Malcolm Bob, you might know that the main goal of object here is to expose behavior and hide the data. Explore abstractions, and of course, use layers and modules and things like that. So, of course, you need to navigate between two words to use it in advance on those styles. And that's a huge challenge with persistence at all. Of course, I'm talking about polyglot persistence. And this kind of thing, that's things that we need to pay attention on it, especially because we are software architect. And every time I talk about software architecture, we need to think about how can I define success inside my architecture. And those principal rules is still valid, of course, to my database choice. I need to help the business to achieve the goal. I need to make sure that technology is for help me and not to destroy my business. For example, I'm gonna access my application or an application, and then I saw through exception of Cassandra or MongoDB. Of course, I, as a user, I don't want to care, or I should not care about database details. But once you took the decision to use that database, let's take the advantage of that. So if you decide to use Cassandra, if you decide to use MongoDB, let's use the best of the best scenario with this database. And just remember here, of course, we are in the software architecture rules summit, and there are two basic software architecture rules, right? So it comes from this book here. It's an amazing book for who is starting to understand more about software architecture. There's a new one that I'm reading right now that is head first software architecture, but this one here is still valid. And let's summarize software architecture and basically two rules. The first one here is that it's not golden silver bullet decision. So everything in software architecture is a trade-off. That's include the database decision itself. And the last one is the reason to do something, the business, in our case, is more important than how are we procedure with that. So if NoSQL can help me with that, the reason to achieve my goals, why not use? Or why should I use? That is the first question that you need to use to define and put in our mind as software architecture. So everything in software architecture is a trade-off, rule number one. And the reason to do that, to achieve that, is more important than how. Okay? And okay, right now I talked about why do we have database has humankind, the way to store information, why database is super important to us, the change of economy that impact our software architecture design. Remember, when the database was super expensive, normalization was the unique way to achieve that, because save space means save millions and billions of dollars. Right now we change. Right now we are talking about save people's time. And as a decision, normalization has drawbacks. We navigate to the world of persistence layer, talk about survey paradigms, the difference between application and database, and let's cover a little bit around NoSQL database, especially the structures. So white column, graph, document, and the last one is key value. I will cover quickly one by one, explain how does it work, and finally one of the most popular NoSQL database in each one. It's important to note that we do have more NoSQL database. Those are only the most popular ones. We do have time series, we do have vector DB, and so on. Okay. And yes, it is a huge universe to cover and discover around database and persistence layer. And naturally, I was not able to cover here today. So transactions, metrics, hard to change, the strategy to legacy modernization, and so on. The data storage with cloud, connection pool, frameworks, and manipulation, and so on. So I won't cover those things today, but pay attention that it is a huge universe that we do have here. Close the parentheses. Let's cover a little bit about the database structure that I cover today. So on NoSQL database, as I mentioned, we do have several types and structures. The definition of NoSQL database are based on how we store that information. For example, key value looks like a map or a dictionary data in some language program. So I do have the key, and the unique way to return that information is through the value. So I have my key and then my value, on this case, Apollo to return sun, Aries to return war, and so on. Here, I do have the classic relationship between key value and relation database. So there are several points here. So of course, the key value is way limited, the relation database. The scalability is way more excellent, because with key value, the majority are on memory. That's being faster than go to the database itself. And move on to the next one. We do have the white column. So as you can see here, so the structure is pretty similar. I do have the key and then a list of columns. The main difference here, instead of have a unique value, I take the information small piece called columns. Let's keep, because my time is almost over, right? I do have the document structure that looks like XML or JSON file. And I do have also the graph structure. This one here is super nice because I can do relationship even deeper than a classical relational database. Why? Because I can put direction on my relationship. So I can see that Kratos killed Apollo and Apollo was killed by Kratos. And of course, I can do recommendation engine. I can do a lot of things. Thanks for this database structure. Based on that, when we talk about database, there are much more things to take a look. Of course, the flexibility of the database will impact on your scalability in the majority of the case. Okay. The database replication strategy. So how can I replicate my data? The partitioning data is schemaless. Again, the schema, and naturally is no more mystery here. The fight about modeling, normalization versus the normalization process. I need to cover here quickly, as I said, so the scalability goes against flexibility, unfortunately, in some case. So that is the main point. So as much scalable you do have, you less flexibility. And we have strategy of replication data that my time is almost over here. And that is way more information naturally. So let's cover here quickly. And it is a huge word of NoSQL database that 30 minutes is not enough to cover in several topics. And yes, if you want to know more about this polyglot persistence with Java, I wrote a book about it. So Java persistence with Java, where you can go, you can take a look and buy this book with discount code Otavio, and you can get 20% off discount. That is all for today. Hopefully you enjoy. So of course, my goal is not to convert you to an expert in 30 minutes, but to introduce you the idea and the challenge that you need to face and pay more attention when you talk about persistence layer, when you talk about polyglot persistence, and of course, introducing more flavors in our architecture with NoSQL database. Thank you. Mihai, that's your turn. Mihai? No?
Thank you.
Yeah,
Thank you
my
very
pleasure.
much. Okay, that was, I'm not going to lie, a little bit hard for me to follow, but I hope everyone listening got something out of that. Okay, the next speaker will be, okay, once again, I will try my best, Adrian Kearns. Adrian is from New Zealand, and I will add him to the stage so he can introduce himself, actually. That's
Hey, how's it
easier.
going?
Hi, it's going great. How are you?
Very well. You got my name perfect. Yeah, not many people do, but I don't always get everyone else's name right, so it kind of evens out, doesn't it?
It's all right. So you are from New Zealand, and you started just by going to the library?
Yeah. Yeah. So I come from a theatre lighting background. So I used to do theatre lighting, corporate theatre, rock bands, that kind of thing. And I was looking for a career change. This is back in about 2000, and yeah, just started out getting library books from the library, hard copy books, Java Extreme, HTML Unleashed, that kind of stuff, and just Notepad and a browser, and just going from there really. And got my first job working for a web development firm, cutting code for websites and classic ASP development, and just went from there. So.
Very impressive. Really ties into your talk, which is a practical career advice, journey from tech lead to architect. Do you want to say a few words, or do you just want to get right into it? Or
well, I can get right into it if you like. I guess the deck will speak for itself, and make sure we're still
sure.
sticking to time if you like.
The quicker we start, the more time we will have for Q&A. So
absolutely, and I love your cat. Your cat is awesome. Are you familiar with HTTP Cat?
Not really.
Oh, if anyone does like REST development or anything to do with HTTP, check out HTTP Cat. They have a cat image for each HTTP status code. Absolutely hilarious.
Okay, yeah, that's what it was. I vaguely remember something. Yeah, okay. I will remove myself. Go ahead with your talk.
Cool. Thanks very much. Well, hi everyone. Welcome to this talk on going from a tech lead to solution architect. I appreciate that not everyone here will be a tech lead, but we'll see how we go. So my claim to fame is, playing with Lego, getting into code about 2000, getting into architecture, and just going on from there. I've had a bit of international experience working in Australia and Singapore. There'll be a lot of notes in this deck and a lot of content to go through. If you do like the deck, I really strongly encourage you to download the deck. And there's a lot of notes that you can refer to, whereas the presentation itself might be a little bit more of an overview. We'll go deep into a couple of things. And at the end, there's a QR code. So if you scan that, that will take you to a blog post on my blog, which has got the deck, and you'll be able to download it. So what's in this for you? So I got some insights on what will happen with your day-to-day work, how that will change. For aspiring architects, things to think about, things to help you make a successful transition. And then for people who are currently architects, maybe this will give you some ideas about ways that you can talk to people who are looking to make that journey themselves. So in terms of the agenda, first section, just be a really quick role recap on what a tech lead does, career paths into architecture in general, and what do architects do, providing a bit of context for where we're heading. And then the main section, looking at how we get there, which is really just taking the stuff that you already know and the things you already do, and just sort of pivoting those, refocusing those to a slightly different direction. We're touching on office politics, traps to avoid, and some preparation that you can be doing now before you head off. So a quick recap. A tech lead's basically someone who leads their team in technical matters. So very much a part of the team, doing system level design for the bits of the system which the team's working on, escalation point for engineering support, helping the project manager, manage the delivery, responsible for engineering practices, processes and tooling will be a big thing, including bringing new technology into those processes. So broadly, that's what we understand a tech lead to be. In terms of career paths, so this is all about just looking at the long term and thinking about how we can use that to inform what we do in the short term. So if you think about information technology, it's basically made up of domains, application, infrastructure, data, and so on. Now, I'm not saying that these are definitively the domains that make up IT, but I'm sure that I'm sure you will agree that you can conceptualize IT as being a bunch of different domains. And if you look at IT from, say, an HR or a role perspective, you have business analysts, developers, infrastructure engineers, security consultants, data analysts. We've already, even at the junior level, you've got role specialization to the domains. So that gives us our breadth. In terms of the depth, you find that working as an architect, you'll either be down at the project level, doing delivery, where you'd be a solution architect. At the opposite end of the spectrum, at the highest level of abstraction, you'd be doing enterprise architecture. That would tend to span the entire enterprise. You'd be doing strategy and planning, that kind of thing. And the domain architect role sort of straddles both of those. And how that basically works out is, if you think of the domains, a domain architect will work just within one domain, but they'll cover the full depth. So they'll do everything from strategy to hands-on project delivery from an occasion, whereas both enterprise architects and solution architects will cover the full breadth of the domains, but they tend to only stick at a particular level of the depth. So enterprise architects at the top, solution architects at the delivery side of things. How this plays out if you actually become a solution architect is a little bit like this. And this is where I think a lot of people get confused about what solution architects do. So I think there's an important distinction between the solution architect role and then what you do as a solution architect on a particular project, because that changes from project to project. And I think that's what confuses a lot of people. So if you take a particular project represented there by the red and say, look at the infrastructure domain and the security domain, you can see that for this particular project, it's more security dominated than infrastructure. So your security skills are going to be a lot more relevant to this project than your infrastructure skills. And you also notice the application domain, that's really blowing the scales there. What I often find is when you're working as a solution architect, it's not uncommon for you to be putting in something new, like something new for the organization. So maybe it's you're working on the project where it's the first time you're implementing a SIAM, or it's the first time you're using containerization. Well, often when you introduce those new things, you end up doing a bit of domain architecture as well. So just a bit of background there on that. In terms of the career paths, your usual starting position, I guess, in terms of this diagram, as a tech lead, you're kind of coming from more of a development background. So yes, you can go straight into solution architecture, perfectly fine. You might also consider going into an integration architect or a software architect role, and there's no reason why you can't sort of flick between the two. And so why this matters is thinking about where you want to go with your career. Think about the kind of work that makes you happy. What kind of problems do you want to be solving? What level of depth do you want to operate at? Because there is a bit of difference there, and that affects the day-to-day stuff that you do. And we'll cover that more in the talk as we go. Which leads to the question, so what exactly do architects do all day? Now, I don't expect you to be able to read this diagram. Don't be too overwhelmed. This is a talk I did at a previous Geekle on roles and responsibilities of a solution architect. So each of the items on this chart shows either a process or an artifact or something that an architect does or is involved with. The key thing there is the sort of the linchpin of this is the ones in yellow, and that stream that you'll see about halfway down, that's basically the SDLC. So everything from planning analysis to doing the architecture, the design, build, testing, release and deployment, BAU operations, and so on. So as an architect, you're across that whole spectrum. With that in mind, thinking about what you do all day, you do a lot of analysis, you do some making, but you do particularly a lot of engaging. Now, the next slide I'm going to bring up is a lot of text. Again, I don't expect, don't try and read it. Really, this is just to try and give you a flavor of what an architect does all day in terms of whether it's analysis, making, or engaging. So what I did is I sat down and I was like, oh, what do I kind of do on a daily basis? Each of these things, each of these lines is something that I tend to do on a daily basis. Obviously, I don't do all of these in one day. So in terms of analyzing, options analysis is a classic thing you're doing quite a lot, general problem solving. In terms of making, you're doing a lot of artifacts. So there's a lot of writing, there's a lot of diagramming, there's a lot of creating PowerPoints or presentations, because a lot of the role is that bottom stuff in the orange, which is all engagement. So that's all engagement. So there's a lot of explaining the current state architecture and its problems, talking about the future state and how you might get there, defending your architecture with your peers. So all I'm trying to get across in this is just sort of the weight of the work you do in terms of the work type. So I can see, after I give my presentation, Ed's going to turn around and ask me, do I think that AI can sort of do architecture? And I guess, AI can probably do some parts of the architecture, but as you can probably see from this, a lot of being an architect is about engaging with other people. So until AI can do that, we're probably safe as architects. So the key takeaway here is, day to day, the work is going to be quite varied. So now into the main part of the presentation. So how do we get there? So it's really all about taking what you currently know and the things that you currently do, and just figuring out how you can pivot. So if we remember that definition of the tech lead from previously, if we boil that down, then we've got about these 5 things roughly that you're doing. Team level, the system design at the team level, escalation point for your engineers, helping to manage the software delivery, and then engineering practices and tooling, and perhaps implementing new technology. So if we're talking about pivoting into an architect, what does that look like? So in terms of system design, obviously, well, maybe not obviously, you're going to be pivoting more in towards solution and system design, or system architecture rather. You're going to be dealing with patterns. You're not going to be so much dealing with components and class design. In terms of an escalation point for engineers, you're going you're kind of moving up the stack in that you're dealing at a high level abstraction. So you're going to be more explaining the architecture and providing guardrails to the teams and being an escalation point for the tech lead. Now, that doesn't mean that being an architect, you're only going to do the stuff in the purple and that you're not going to do the stuff in the blue. That's not true at all. It's still quite likely that you'll end up assisting with the stuff in the blue, but nowhere near as much as you would as a tech lead. And it kind of depends on the project, right? So if you're in a big team and everyone's sort of got their niche, chances are you'll just be sticking to the purple stuff. If you're in a really small team and people are having to wear lots of different hats, then it's more likely that you'll be a bit more hands-on. It really just depends on the role and the teams and what's going on. In terms of helping to manage the software delivery, really the closest thing you might be doing here is really working with the project manager and giving them guidance. So one of the things I frequently see is you get all sorts of different types of project managers with different levels of maturity, different levels of skill, different levels of technical understanding. And so it's not uncommon that you need to work with them as a partner and help them figure out how best to deliver the project that you're on. So that might be everything from talking about development methodologies and project methodologies, how you might estimate work, how you might prioritize stuff. So it's not necessarily your job as an architect to do those things. You're not responsible for them. But I think if we think of an architect as being someone with a bit of experience, and it's definitely a leadership role. If you're on a project that could benefit from your wisdom and your guidance, then you definitely need to lend that where you can. In terms of the engineering practices, again, there's not really something that you're going to be involved with. The big exception there will be that if the architecture you're introducing is introducing new technologies, then you are going to have to be a lot more hands-on. So if you imagine a scenario where, let's say, where you're introducing containerization into an organization and a team that's never used containers before, if you want that project and that technology to succeed, you're absolutely going to have to be a lot more hands-on, because if no one else on the team has that experience, then it's really going to be up to you to help carry that across. So apart from situations like that, then really it's just a matter of, as I said in that second point, providing the guardrails and explaining the architecture, and then letting the delivery teams just get on with it and just trying to stay out of their way. So that's some of the pivots, thinking about what the tech lead role was as we described it before. If we think about it a little bit more abstractly, we get these pivots. So one of them is around ambiguity. I think as a tech lead, your role is really to eliminate ambiguity as quickly as possible. You've got a team trying to deliver stuff. They're trying to write concrete code that delivers actual value. You don't want ambiguity getting in the way. The problem being with an architect is you still need to deal with ambiguity and you want to eliminate it when you can, but you tend to be working at a high level of abstraction and there's just a lot more ambiguity around. And it's not so easy just to sort of, when a bit of ambiguity comes your way, just to dismiss it. You really have to do those options analysis. You have to do trade-off. There's a lot more work and research you have to do in order to figure out what the right decision is, what the right direction is to go. So you have to be comfortable dealing with ambiguity and having that hang around for a while. It's not like a tech lead where you just need to clear it off your desk as quickly as possible. In terms of the system life cycle, so you remember that diagram I had before with all the colors in the yellow SDLC? With the tech lead, you're much more focused on the system life cycle where it's delivery orientated. So design, build, and test and release. With an architect role, you want to be thinking more about the solution life cycle. So you want to be much more holistic. You want to be much more conscious of not just delivery but operational as well. So really, if you think about it, once the solution is delivered, that's just the beginning. That's not the end. You also need to be thinking about decommissioning stuff as well. What does that look like? So just very quickly, a lot of the work that I get given in my work here in New Zealand, particularly in the public sector, is we're replacing old systems. So often they're on-prem. Often the organizations want to move to the cloud. So there'll be a lot of decommissioning old systems. And you can really tell when a system's been well architected, because that really affects what the migration and the decommissioning's like, and how the whole rollout of the new solution is going to be. It does have an impact. So having a system that's really well architected, does have impacts that far down the line. Another pivot is being sort of away from being more concrete and detailed focused to sort of more abstract in the big picture view. So you're kind of changing your focus there up the abstraction layers. Design versus architecture. I'll talk about that a bit more in a following slide. And you're going to go from being managed to being more self-reliant, showing initiative. So I think even as a tech lead, you're going to have to be self-reliant and show initiative. But as an architect, that's really where you're going to be. You're not going to have anyone telling you what to do every day. Being an architect, that is a leadership position. So you basically have to understand what's going on. You need to be looking ahead, on behalf of the team, sort of clearing the way for them, identifying where the problems are. And that requires a lot of initiative and a lot of self-starting. So you really do need to be prepared to show initiative and self-reliance. And you're not going to be so hands-on. So you're going to be pivoting away from being hands-on with the tools, and your role is going to be much more about facilitating and guiding others. Just in case it's not obvious, if anyone's confused about solutions versus systems, within solutions you can have one or more systems. Within systems you can have one or more components. Within components you can have one or more classes. Obviously classes is where the code is. That should hopefully make sense. That should hopefully help sort of inform this. So when you think about the level of abstraction when you're a team lead, you're dealing much more with the components and with the classes and scripts, the stuff that your team's producing. When you're working as an architect, you're working at a high level of abstraction. So you're thinking more about the solutions and the systems. You're thinking about the components as well. You don't really be thinking about the classes and the scripts. This slide's not trying to say explicitly where the differentiator is between architecture and design. It's more just trying to give you a sense of, as you become an architect and when you start looking at systems and solutions, kind of where the focus tends to be. You're kind of moving up that stack and working at a more abstract level. And that affects the type of work that you do, the types of problems that you solve, and so on. So architecture versus design. So this is quite interesting. So this is a couple of definitions which I found quite useful and quite interesting, to help me conceptualize it and talk about it with other people. So very quickly, so the first definition says that architecture is just about the arrangement of components, how they interrelate, and their roles and responsibilities. It's not talking about the implementation inside them. So the key one there is how components relate and their roles and responsibilities. And one of the projects I'm working at the moment, that's very key to what we're doing. We've got a couple of services that we're designing, and they're working with a bunch of line of business applications where the master data is. And one of the really important considerations we have is thinking about the system roles and responsibilities. Which systems are responsible for which responsibilities, and where do we draw the lines and demark those? Whereas design is, you're looking at implementation specifics. And that kind of contrasts nicely with the other definitions there. So this is about change. So I would suggest that architecture is intentionally created to accommodate certain types of change around which the architecture will be the same. Whereas with the design, if you change the design, that usually means a new design. And so architectures are intentionally designed to accommodate certain types of change. Designs are. System lifecycle, I touched on this before. So with the tech lead role, you're kind of focused on that stuff in the red, it's sort of the design through to the release and deployment. You're focused on the build, getting stuff out the door. Being an architect, you really need to think more holistically. The full life cycle. And just a warning, if I start babbling, it's about almost 1 in the morning here. So and this is after a work day, but it's all good. I was actually debating before whether I try and have a sleep before this, but I was petrified about falling asleep and just sleeping through my presentation. Anyway, so recap. So there's probably a lot of things that you're already doing that you'll do as an architect in terms of the skills and the experience that you can bring to bear, but your focus is going to have to change. So you'll be solving problems, but at a higher level of abstraction. You need to think about the full system life cycle, not just the initial development. And you're not going to be on the tools. But the good thing, though, is that your technical knowledge is still going to be really valuable and really, really heavily used. It's just that you're going to be using that knowledge to guide and facilitate others. You're not going to be on the tools yourself. So, office politics. So the reason I want to include this is that it's not uncommon to come across people who say, I don't do office politics. And you can sort of understand why you don't want to get involved in intrigues and nastiness and toxic personalities and stuff like that. Like, that's just not what we want to do, right? So I completely understand that. But in another sense, there's more to office politics than that, and you actually do need to get involved with that as an architect. So office politics, what do we mean? So drivers of office politics, you've got diversity of perspectives, interdependencies, and scarcity of resources. So diversity of perspectives, what we mean there is, say, the arguments that you might have with developers with the security team. You both want to put out a really good solution, but you're coming at it from different perspectives. Interdependencies, you might have interdependencies between different teams, the infrastructure team versus the development, the coders. We might have different projects, each developing different parts of a wider program, and scarcity of resources. One of the big bottlenecks that we have in a lot of New Zealand public service organisations is around security testing and security consultants. There's a lot of emphasis placed on that for public services, you can imagine, and so getting those people time and booking them into projects can be a little bit tough. And then you've got courses of action, so building bridges and cultivating allies. So the takeaway here is that often office politics, at some level, it's really just, it's a normal, natural tension of people just dealing with those things. There's nothing, it doesn't have to be Machiavellian. It's not necessarily about toxic people. They happen, but they shouldn't stop you from taking those courses of actions, building bridges with other teams or other people, cultivating allies to help fight your corner in a professional way, to help you deal with the different perspectives and the dependencies and the scarcity of resources. Another way to quickly look at this is, now this is a model I've dreamt up myself, so I could be, this could be vaporware, but just based on my experience, there does seem to be a bit of a matrix here where you've got a couple of things going on. So we look horizontally, you've got organization and team strategy and direction. And usually that's given with varying degrees of clarity. And what I think is the case is where there's clear direction and it's clearly articulated to you, it's more likely that teams are going to be able to align on those shared goals. Whereas if the strategy is not clear, then that's going to create unnecessary tension and it's much, much harder for teams to align. And then if we look vertically, if we think about motivations, so it could be the motivation of people as individuals, it could be the motivation of teams. Where those are increasingly shared and where the direction is increasingly clear, that's obviously the happy place, right? If you've got someone who's toxic, someone with a toxic personality, or someone who's increasingly selfish on that spectrum, you hit a threshold, I think. Not everyone is sort of happily smiling and humming a hand. You're not always holding hands and humming and singing songs all the time. The happy place isn't always where you are. Sometimes the motivations are perhaps just a little bit selfish in favor of your team, not necessarily in a toxic or unprofessional way. But I think once it gets below a certain tipping point, to that toxic level, then that does become a challenge. And I think where it gets worse is where you've got toxic people working in an environment where the direction is not clear. When those two things come together, that's just chaos. So if you say, I don't do office politics, if the meaning behind that is you just want to avoid chaos and you don't want to deal with toxic people, completely understand and respect that. And that's a good way to try and be. You want to try and remove yourself from toxic politics. But I don't think we can really say that we don't do, as architects, you can't say that you don't do politics, because you should be doing office politics, but it should be in that happy place. It should be about, just working with those natural tensions, working with other teams, finding allies, building bridges, and getting stuff done for the good of everyone. So I've got about 4 minutes left. I'm just going to rip through the last bit here. So 4 traps to avoid, 1 big one, 3 small ones. So the big one really is about staying on your comfort zone. So clinging to technology, implementation level problems, your old familiar ways of working. A big one is, a tendency to help people by doing rather than letting them fail and just facilitating. I've seen a couple of tech leads, one in particular I'm thinking of, on his first role as a solution architect. He'd come from a tech lead role, and he really, really struggled with this. It's not necessarily his fault. It's just a challenge in the transition. So I think it took him about, realistically somewhere in the region of 3 to 6 months to sort of really let go of the tech lead role that he was doing and adopt the architecture mantle, to the point that, when people came to him with, tech lead stuff that he would sort of deal with, he would sort of say no, and you provide the guidance, but not actually do it for them. It sort of reached that tipping point where he was being more of an architect than a tech lead. But I think that took him about 3 to 6 months. So the big trap here, I think, is, everyone has a comfort zone. If you're a tech lead, you're going to be coming from a comfort zone. I think you need to acknowledge that and just try and be conscious of it. Another few here is, gravitating towards options that suit the project rather than the enterprise, assuming that every problem can be solved by technology. Those are probably quite common if you're coming from a tech lead background, because you've been working with the tools, you've been at the coal face. That's kind of the bias and the mindset that you're carrying with you. As you work at a high level of abstraction, you really need to start consciously putting that to the side a lot more. I mean, for one thing, you'll be working with enterprise architects, and they will see you as a vehicle for getting their changes made, sort of across the organization. And you do need to work with the enterprise architects. They, depending on the dynamics of the organization, in the organization I'm at the moment, the enterprise architects have a lot of weight, and you really need to have them on board if you want to get stuff done. So you can't just flippantly turn around and say, oh, we're not doing that. To the enterprise architects, if you think it's the wrong thing to do with the project, you really have to be a lot more balanced about how you make those decisions. And emotional level investment, sometimes, you don't want to get attached to the project. It's not your baby. You do need to have a bit of Olympian detachment at times. So preparation, there's a lot here that I was hoping to get through, but I think I'm going to be running out of time, so I won't get into this too much. So let me just sort of skip through this, give you a flavor of the sort of things that you might be able to do in preparation, and then I encourage you to download the deck and go through the notes and use that knowledge where you can. So there's a bunch of obvious things that you can do, meetups, mentoring, self-directed learning. In terms of the less obvious stuff, so there's sort of a game that you can play with yourself. Pick a topic, something relatively complicated, and then think about how you would explain that to someone like your mother or your son or your friend, someone who's not in IT, someone over at a barbecue or at a restaurant. This is something I actually do. Typically in the shower, I'll think about, how would I explain such and such? Because so much of the role is engagement, and so much of it is also translating, say, between the business and the tech teams. So you have to become really, really good at explaining stuff. And what you want to be aiming for is to give the maximum amount of clarity using the least number of words. Okay, so no one will be interested in listening to your voice as much as you. So you want to focus on clarity and being succinct. You need to be comfortable writing, and writing well, and presenting. think about the specific things that architects do all day. So you go back and have a look at that list, have a look at the roles and responsibilities, research how you can do those. You pick out some individual things and do some research into how you would actually go about doing those. That knowledge might come in handy for job interviews. Architectural katas, if you've heard of those, they can be quite good. Befriend your in-house architecture team. How do they work? Talk to stakeholders of architects. How do they find the architects that they're working? What works for them? What do they think their weaknesses are? See what you can learn. One of the things that I've been paranoid about the whole time as an architect, coming from my developer background, is I don't want to be an ivory tower architect where I wasn't providing value, where I was just sort of getting in the way. So one of the things I consciously try to do all the time is think about how I can add value and not get in the way of the development team. Cheat sheet, I'll skip that for now, but that's a good technique you can have for. That was a technique I used that was really good for helping me get up and running in my early days. And lastly, if you want to be an architect, start being an architect. Devise a strategy for your own career. Don't overcook it, but just start approaching things like you're an architect. And lastly, into the resources, I got 5 pages here of resources. So these are really just links to further information, which go into more detail on some of the stuff I've mentioned here in passing. Roles and responsibilities, your first project, where to start, cheat sheets, bunch of architectural links there that might be of interest. Tom Graves is quite interesting, a little bit more on the enterprise side. This is the Harvard Business Review actually had some quite interesting videos. This is the one on office politics. That was the basis for some of the stuff I presented before. You'll see this was posted in 2011, still relevant. And then lastly, Amy Gallo's got some really interesting stuff sort of on if you think of the soft skills, how to disagree with someone more powerful than you, how to work with a passive aggressive co-worker, stuff like that. Some quite interesting stuff there that should help you with the soft skills with a bit of luck. And that's it. Hope that was useful to you. Just feel free to reach out. There's the QR code. Please feel free to download the deck. As I say, there's a lot of notes in behind the slides. And all the best with your career.
Are you staying for the Q&A session?
I'm absolutely staying for the Q&A session.
Great. Thank you very much for the presentation. Very informative. Let me, is it okay? I wanted to leave this slide up a bit, but I think I will need to remove it for the Q&A session.
That's fine.
So. And I will add Ottavio.
Ottavio, how are you, my friend?
Ottavio, yes. I will add Ottavio back for the Q&A. We already have a lot of questions. First, I think this is something that that Ottavio wanted to talk about, just didn't have the time. How do you keep data consistent in multiple databases?
Whoa, that's a good one. In the end, there's no perfect world, right? So we're still facing the cap theorem. That means we need to choose between consistency, availability, or fault tolerance. Given that, it's up to you to define, based on the architecture, on the decision, what is the main point of your structure. For example, in finance, we are mostly looking to consistency. This way, of course, you can aggregate in multiple database and using relational database to make it super strong. However, the fault tolerance usually is not okay. When you talk about social media, for example, Twitter, you can decrease the consistency and allow more availability. On that case, you can use, for example, Cassandra as database or MongoDB, some horizontal database that you can multiply the information by the database itself. So to keep the database consistent, first, make sure that you do have consistency side, the application side. Of course, avoid bugs. Make sure that they're going to use the right and the proper database for that scenario. And understand that there is no perfect world. So consistency, availability, and fault tolerance. So one thing you're going to put behind.
Can I just jump in there as well?
Yes,
Sure, of
please do
course.
it.
So it might depend on the technology you're using. So some technologies, some database platforms will have replication and stuff like that built in that you might be able to use. If that's not the case, the architecture is important. So think about patterns. There's a lot of different patterns I think out there that will deal with that. And roles and responsibilities. Thinking like, do you have a master? I think one of the big problems is when there isn't inconsistency, then who do you take as being the right record? So just planning stuff out, really.
Okay. Then another question for Tevio.
For us,
was
come on, Adrian here. Okay,
how do you balance use?
Okay.
Sorry.
No, go ahead.
How do you balance using the best tools for the job and reducing maintenance and learning costs by limiting the number of tools used? Ooh.
Whoa, it's a philosophical question.
Yeah.
First, because there's no best tools, means go to the context. Ada said everything has a trade-off. And what I'm exploring right now is using more database as a service. So I can use the best of the words, use the best of the modeling, if without caring about, for example, maintains or know more how to configure a database in the cloud. So I don't need even to touch in Kubernetes to make it possible. So to balance the price and the cost is a discussion in the software architecture layer. And every time I talk about any kind of PaaS or database as a service, what I put in my drawback is the time to deliver a product. So I can negotiate this kind of thing on this way. Adrian?
Yeah, it depends. I guess I would look for issues. So I mean, you don't fix something if it isn't broken, right? So if people are getting their jobs done, if things are being done to a good quality and a good time, and people are saying they have the right tools, then you probably don't need to change them. On the flip side, if you do start introducing too many tools, people will complain. So I think if there's no noise, then that might be a good sign. But it's there's no sort of golden rule, is there?
If there was a golden rule, then everyone's job would be a lot easier.
That's right.
It would be fantastic, right?
Oh, just ask AI.
Sure.
AI will tell you.
Yeah, I mean, imagine a world without tough decisions. Of course, there's no software architecture.
Yeah, so often when you have a software engineering question, the answer just becomes, it depends. It's sort of a joke at this point.
Yeah,
this one is for Adrian. Sorry?
Oh, yes, go ahead. No. My
Which
point
organizations? Oh, I really don't mean to interrupt you. Sorry.
No, it's fine. We're all friends here. And Ottavio, please feel free to jump in. So I think there's a distinction between architecture and architects. So no matter where you are, there's always architectural work to be done, but it's only going to be organizations above a certain size that have architects. So certainly in government departments here, there's whole teams of architects. I think, I don't know, Ottavio, what would you say would be the smallest team that you've seen where there's been a dedicated architect? Would it be a developer team of, say, 4 or 5, maybe 8, and above that you're getting into having a dedicated architect?
Yeah, usually between 8 and 5, because unfortunately,
like that.
more time somebody to go to oversee the issues, right?
Yeah. So there's always architectural work to be done, but yeah, to the question in terms of a dedicated architectural role, probably medium to large businesses. I mean, small businesses are unlikely to have an architecture team or a practice, but yeah, medium to larger size for sure.
Depends how you describe architect. No, like it's not a, there is not a fixed definition. Sometimes tech lead and architect get mixed up. It's more that if you work for a smaller organization, you are more likely to be called a tech lead and do the architect work and not
Exactly.
get the, well, that's sort of like, I don't mean this as a, I think this is just like a, how do I say this? So I think it's more likely that someone will do the architectural work and they won't really get the benefit of being called an architect or getting the same benefits as a architect at a larger organization would get, to put it nicely.
It's certainly true that on the pay scale, someone who's called an architect, that tends to attract more money, and that's one of the things that attracts people to being an architect is you get that career progression. But yes, completely, you don't have to be an architect to do architecture.
And Ottavio, do you want to contribute something here, or?
Yeah, I mean, every time that we talk about software architecture, it's hard, right? I mean, it's not only a good practice like code design. I do have multiple ifs. So can I use strategy pattern instead? Yes, it's clear, right? So it's super focused, it's super clear to do that. But for example, okay, should I use consistency or availability? I need to understand better the context. I mean, if you go to finance, of course, the consistency is super strong because we are talking about money. But if you go to social media, it's way better to delay 4 seconds than stay out for that moment because you might lose a trend. So the business is super strong in on soft architecture. And that's why, I mean, if you don't have a soft architecture or someone who's taking a look at that, the soft architecture will be there. A good or a bad one, it is your choice or your organization choice.
Exactly. Yeah. The other key thing is one of the phrases I'm always telling myself is, and one I'm always asking my team is, what problem are we trying to solve? Instead of just racing off and doing solutioning, you always come back to that basic problem. What problem are we trying to solve? Because if you understand the problem you're trying to solve, then the answers usually become a lot clearer.
That's sort of something that really separates the tech lead from the architect now, that an architect has to look at the business problem. A tech lead can just do technical things. Not sure how to phrase that. An architect has to look at the business problem, and they might have a business analyst to help them, but in the end, it is the architect their responsibility to provide a solution for the business problem and not just come up with an architecture that might solve the problem.
So I mostly agree with you. Yes, the tech lead role is very much focused on delivery and dealing with the technology. I think if you think of an architect as looking at system roles and responsibilities and where they sit, some of the projects I'm involved with as an architect, yes, I will be talking to the business and I will need to understand the business problem. But there are also some projects I get thrown on where the business is sort of put off to the side and I don't really talk to them because of the dynamics of the culture, or the solution I've been brought in to put in is much more of a technical bent. So if you're thinking of, say, adopting cloud, sometimes there's infrastructural services and stuff that you need to put in where you're putting in a solution, but it's more of a supporting foundational solution and the business isn't necessarily involved. So yes, architects definitely talk to the business, but not every solution that you make as an architect necessarily has a strong business flavor. Yeah, it very much depends.
Yeah, I mean, there is no regulation or global regulation around both, right? Tech lead or not that. For example, tech lead itself. There are people who relate that to entry level of manager. So someone who goes to educate the people, the team, do education, something like that. And also it might be a profile of a staff plus engineer. For example, the book from Will Larson, The Staff Plus Engineer, Leadership Beyond the Management Track. And he mentioned this tech lead as a entry level or at least an archetype of a staff engineer. So the term of occupation is super hard to define. It's like if you decide to try to define DevOps. So it's occupation, it's a culture. So it's like over 1 decade of discussion. And it's impossible to go to the end. It may vary with the company, the organization, the country, and so on. So try to define the rules precisely between architect and tech lead. It might be an endless history. And what I usually recommend is architect is the one who took the architecture. And architecture is a strategic way to take care of the business on the technology perspective. This way, in my opinion, everybody should look to that. I mean, if I'm a senior engineer, am I doing something else that is not impact the business? I'm doing something wrong.
Here is a long question that's in 2 parts for Adrian. How do you approach new problems? I am referring to the solutions you propose for new problems in a short period of time. In startups, we often do quick and dirty things as software developers, but as a software architect, I don't think it works the same way.
Oh, I don't know. I feel dirty sometimes as an architect. So with the first one, if you go to my blog, I've got a post on dealing with ambiguity, and I got another presentation on being a consulting architect, and both of those covered sort of ideation to a certain extent. So part of dealing with a problem is thinking about how you're going to frame the problem, because you need to understand the problem before you can start going into solution mode, right? And so if part of the problem is dealing with ambiguity, there's different ways that you can approach that. So if you've got a big complicated problem, maybe you need to break that down into smaller parts and then sort of address those individually. Conversely, if you've got a lot of individual bits and pieces, sometimes you need to group those into themes and try and apply patterns to them. So it's quite an open-ended subject, and it's 1:30 in the morning here, so I'm not quite sure how coherent I'm going to be. But yeah, have a look at that blog post if you can about different approaches to dealing with ambiguity. Coming up with problems in a short space of time. So I like leveraging the team around me a lot. I think a lot of the success in being an architect is getting consensus, because if you try to ram through an architecture that no one agrees with, the moment you go off the project, people are just going to pull it apart, right? And as an architect, I really try and leverage the skills and the knowledge of the people on my team. So if Ottavio was on my team and we had a problem and data and databases, it was clear an aspect to it, I'd be going, Ottavio, what do you think we should be doing? You know, leverage your team. Don't be afraid to leverage your team. Don't be afraid to say, hey, like, I don't know what the answer to this is. You know, what do you think? You know, involve other people. There's lots of different ways you can approach solving problems in a short period of time. You know, that would just be one. You know, just leverage the people around you. And what was the second half of that? So if you're doing stuff quickly, then you're creating technical debt. So that's a trade-off, right? Sometimes you need to do something quick and dirty to get over a hump, but then the danger is that will stay in place. One of the problems I have as an architect is you'll be working on a project and there'll be the current state solution that you're working with, there'll be the future state that you're trying to get to, but it's not necessarily an easy straight line from one to the other. And sometimes you have to put in a transitional state. So a classic example would be, let's say you're putting in a new digital service. It's going to be external facing. You want your customers to come in and use this service, but you don't have a SIAM in place. You don't have a centralized customer identity and access management solution. There's a project in progress that's going to put one in place, but they're not going to deliver in time for your service. So what do? I mean, do you let the business people fight it out amongst who goes live first? Do you wait? If it's going to cost the business money by not going live, they'll really want to go ahead. So then you start having conversations about, okay, well, do we put a tactical solution in? And the moment you say you want to put a tactical solution in, that can make people really antsy, because what we've discovered, certainly in New Zealand and the kind of work that I do, there's a real risk that if you put a tactical solution in and that addresses the immediate problem, sometimes that can take the heat out of the problem, and then there's not the same motivation to fix the problem properly as there was before. And so what was a tactical solution by default becomes the strategic solution, and it's not the solution that people wanted. So that can happen. So yeah, that can happen at the architectural level. You sort of, it's the same problem, but just sort of at a bigger level of scale. I don't know if that answers the question, but
I hope so.
It depends.
I kind of felt like it did.
It depends. We say it like it's a joke, but the irony is, it is actually real. It is a question you should be asking yourself all the time.
So, unfortunately, we used up not just the Q&A time, but also all the break time. So thank you guys for being here. And
real quick, I want to say thank you to Ottavio and to Adrian. Thank you guys for joining us. It is a pleasure to cooperate with you every time. Thank you.
You're most welcome, Sia. Ottavio, good to see you again.
Good to see you, Adrian. Good to see you, Tia.
Slava
Nice to meet you.
Nice to meet you. Bye. All right, and the next talk will be, I have to apologize in advance, Vaclav Pavlin will be the next speaker, but I'm fairly certain once I add him, he will correct me. Hi,
hey.
How are you?
I hope you can hear me. Yes, I will happily correct you. It's Václav, but it's okay. Still not the worst pronunciation I've heard. I think the weirdest one was Wicklow, which was southeast England.
It's okay. I also used to people not knowing how to pronounce my name, so that's sort of comes with the
same boat.
Yeah, comes with it. And you will talk about decentralized infrastructure.
I will try to. Let's see if I am able to pull my thoughts together well enough.
Do you want to say a few words, or do you just jump right in?
Let's jump right in. I had a slide with like introduction and
sure. The stage is yours.
Thank you very much. Thank you very much. And thank you everyone who is A, joining, and B, who has organized this, because I know it's a lot to organize events like these, and this one is very well organized. So thank you very much. I would like to talk about Deepin, which is a hyped up term in Web3 space. So I'll try to make it less hyped up and more real. My name is Václav Pavlin, and I'll tell you more about myself on one of the following slides. So first of all, so that we kick it off the right way, I'll want to tell you what I'll be talking about. And I will be talking about Deepin, and we'll start with introduction of myself and what I do so that you have context. Then I'll tell you a very short story about, I think, how internet evolved to the point where we are now. And then we will talk about decentralized infrastructure architecture. So how does it actually work? What does it consist of? I'll go over a few projects, not in detail, but just to list a few that you can do some research later if you are interested in the particular topics. I'll talk about Kubernetes. I am quite sure that many people will be familiar with Kubernetes, but I want to just give you a very, very high-level overview so that we are on the same level. And then I will talk about Akash Network, which is one of the Deepin projects that I'm a big fan of. And I'm going to use it as an example of how a real decentralized infrastructure project can work and can actually be useful. And it's not just about that hype. As part of that, we will kind of compare hosted Kubernetes and Akash Network. What does it mean for each to use that? And then we'll conclude with some conclusion slide. I was gonna say we go home, but I don't know about you. I'm home, so I don't have anywhere to go now. So hello again. My name is Václav Pavlín. You can find me on socials as vpavlin, basically on all of them: GitHub, Twitter, LinkedIn. So if you want to connect, if you want to ask questions after this, just find me and ask. I work for a company called Institute of Free Technology. You can go to free.technology. Yeah, free.technology. And under the umbrella of the Institute of Free Technology, there is one program called Logos. And Logos is focused on decentralized, privacy-preserving, and censorship-resistant infrastructure, and building those so that we stay free on internet, and free not as in beer, but free as in speech. And then very specifically, I work on a project called Waku. I'm a solution engineer for Waku, so I deal with the partners. I help them integrate Waku, come up with ideas how to integrate Waku, resolve issues, and things like that. And Waku is a set of protocols for decentralized peer-to-peer communication. So if you're familiar with things like Kafka, maybe, if you're familiar with client-server architecture, so I want to send something from one location to another, some message, some data, in a Web 2 world, in a standard cloud world, that would be a client-server architecture, or you would use something like AWS SQS or Kafka. In a Web 3 world, Waku is the answer to that, and it has a very similar pub-sub approach as for example, Kafka and RabbitMQ and all these projects. But my talk is not about this today. It's about something slightly different. And just to make sure you understand, I like new technology. This is why I'm in this space. And I also talk a lot. That's why I'm in this event, I guess. And you'll see how much I like talking. So let's start with the story. So let's move a couple decades back and let's think about how internet worked. I mean, obviously, we had all these connections starting to be built. But then if you wanted to serve something to the audience, so run a web server and run a website on their web server, host your website on the web server, in many, many cases, and with high probability, the web server will be just a computer under your desk. It will just be sitting on your desk or under your desk or in your office, and it will be running some kind of web server, and it will be hosting your files. And at that point, we basically had the decentralized internet because there was no one giant data center that would be hosting all of these applications. And if the data center goes offline, then none of us can work because GitHub is down, Twitter is down, Telegram is down. All these things are just gone until the data center comes back up. It was just a bunch of computers running around the world, serving content, and then we would search for that content and use it. As time progressed, and as we demanded more compute power and more reliability in a sense of, well, maybe a cleaning lady will turn off my computer and then my website is gone, we moved our servers to data centers. But it was still our servers. It was our hardware often, or we rented the hardware, but we rented a very specific, precise type of hardware, and we knew what our software is running on, right? And oftentimes it was just our server. I would take a server and I would put it into a server room, install a Linux operating system on it, for example, and then they would make sure it's powered. But for me, that would mean I would have to watch it, make sure that it runs, make sure that it's alive and well. And as time goes, again, we move to clouds. And if I say cloud, I just mean someone else's computer, as the saying goes. But then also I mean these huge data centers which run commodity hardware, where I don't really care about the underlying infrastructure and underlying hardware and underlying components. I just want to have an access to a particle API so that I can deploy my application, right? And on one side, this is great. I don't have to care about many things that are complicated and that I had to care in the past. At the same time, I have very little control. I have very little privacy. And I can't even talk about censorship resistance, right? Because what if something happens, someone changes mind, and then my application disappears because the data center no longer is willing to host it, right? And then there's this project called Bitcoin some time ago. Some people also call it magic internet money. And we got back to running our software under the desk, right? There was this computer, this miner that you put on your desk or in your garage or wherever, and it started to producing this magic internet money. It's starting to do productive work, and we can discuss whether the work was actually productive or not. Like, I don't want to get into that, or whether it is productive right now. But at that point, basically, we started decentralizing internet back. We started going into, okay, we can now run an application that provides compute and partially also storage under the desk with some reliability of the whole network working together with some common goal. And that's interesting. And that's part ideas. And that's part the idea of, like, what if we go and we just decentralize everything? What if everything works on a kind of peer-to-peer architecture? What if everything is censorship resistant and permissionless? Because permissionlessness is very important, and we'll talk about that more. And some projects started going in that direction, and some projects started trying to do things. We have blockchains in general. There is many various types of blockchains and various instances of blockchain. We have decentralized storage. We have decentralized communication, like I mentioned, Baku, the project I work on. And that brings us to general term, or, well, not that general, but a very specific term on the rather, DePIN, Decentralized Physical Infrastructure Networks. So what is that? I've took a bunch of definitions that I found online, and I put it into a chat, into an LLM. It was not ChatGPT, it was an LLM running on a decentralized open cloud. And I asked it, okay, summarize these definitions and then explain it as if I'm 5, right? So what it came up with is DePIN is like a special team that helps build cool things in the real world, like roads for cars, charging stations for cars, super strong Wi-Fi towers. This team is powered by magic computer or magic internet money, cryptocurrency, that rewards people for helping these things together, making infrastructure awesome, one decentralized step at a time. I love it because there is everything. So it's tied back to real world. It is helping with decentralization. It is a community effort to build something very interesting and very important for what we are already using, but we are using the instances of that infrastructure that is provided by either governments or large corporations. And we do it in a way so that people building these things are paid by people using these things, right? Using this infrastructure. So I think this is a very good definition provided by an LLM. Now let's break it down. So DePIN means decentralized physical infrastructure network. So what does decentralized mean? I think it's potentially obvious, but just to be clear, decentralized basically just means that there is not everything runs in a single location or 2 or 3 locations. It runs around the globe. It runs on a relatively smaller machines than it would if it runs in a data center. And those things communicate without a central point. So if there is a failure in the network, it does not mean that the whole network is unusable, because if the failure happens in a centralized system where the center point fails, then everything is done, right? But in a decentralized system, it would have to be a large portion of the network to fail so that the network would be unusable. So here with decentralization comes also some kind of higher reliability. Then I'll leave the P word because I have a separate slide for that. Then we have infrastructure. So what does that mean? We do use infrastructure every day. So if we are talking real world infrastructure, we use electricity grid, we use roads, we use water supplies. If we use internet, if we talk about online or digital worlds, we use DNS, we use we use cloud computing. So we use some compute, we use some storage, we communicate, we use streaming of video. So that's various kinds of infrastructure. And then networks. So what does network represent? It represents on one side what I said about decentralization. There is a peer-to-peer network, which means the nodes communicate with each other and synchronize between each other, form some kind of mesh, rather than going through a central point or central server with the database or something. But they communicate with each other. They may communicate directly, or they use some kind of broadcast to spread information and spread the consensus of things, how things should happen. But then also we have the other part of networks, and that's human networks, so social networks, social graphs, how things get agreed on between humans. And that's also important here because the network effects of decentralized solutions are very important, where the more people use it, the more people have access to it, the more it scales usually. Now, the P word in the DeepIn is officially, based on definitions that I've been able to find, means physical. So DeepIn should always be tied back to the real physical world. I don't think it's always the case, because as a term gets hyped up, it also, like, all the corners get kind of rounded. And it's like, oh yeah, it's gonna fit in, right? So not all projects in DeepIn ecosystem are physical, but most of them would be. So maybe, for example, Akash, I'll keep coming back to that one, Akash Network provides physical compute to people. And for example, they focus on AI a lot lately, so they provide physical GPUs that you can rent for some time, right? If we talk about storage, there will be some computers having a large storage arrays that they are providing to this network. So there is a lot of physicality in these things, but there will be other that may not be that physical. But for me, the P can be also expanded. So it doesn't have to be only physical, but it can also be private and permissionless. And what I mean by private, there's a, I'm not sure if it's Cypherpunk Manifesto or Crypto Anarchist Manifesto, but in one of those manifestos, there is a sentence, privacy is a freedom to reveal information about yourself on your own terms, basically, right? So in a current world, a lot of information that we give out when we live in a digital world is taken from us without our consent, or it's an implicit consent, right? And these decentralized networks are supposed to be built in a way where privacy is inherently incorporated in there. So you are not leaking information about yourself unless you're willing to give that information. So all these various nodes, I don't need to know where they are and who are they run by, because I trust the system, I trust the network to be fair and to follow its own rules. So if I want to connect, and that goes to the next one, to permissionlessness. If I want to connect to the network, if I want to use the network or contribute to the network, I only need to follow the rules set by the network. I don't need permission from someone. I don't need permission from the central body of the network, right? So these three, I think, all should be kind of hidden in that P in DeepIn, because they are all very important for an actual decentralized a network system. Okay, let's move on. So if I break down the general architecture of any DeepIn project, you will have two main pieces there. You will have the actual infrastructure. So if we talk about cloud, decentralized cloud providing, I need to have the compute, and I need to have an API to be able to use that compute as the user. If I talk about storage, I need to have a way to upload and download the data. if I talk about deep-in streaming network like Livepeer, I have to have a way to provide the data, and then on the other hand, to consume the processed data, right? So that's the infrastructure, and it's not extremely different in this sense from the centralized world, because the infrastructure has to be sufficiently similar to what people are used to. For some cases, it will be very different because it may be actually a hardware device that you put in a car, like with HiveMapper, where you put a device in a car and it maps the surroundings of your car, and by that building better maps than Google. At least that was their goal. I'm not sure in what state they are right now. And then the second part of this architecture is marketplace. And that's very important because that also goes back to the privacy and permissionlessness. We all interact with marketplaces every day. Be that I want to rent an Airbnb, or I want to buy something on the market, which is a marketplace in the real world, or I want to actually use a service from AWS. That's also a marketplace, but there is one massive caveat, and that is AWS is a marketplace with only one seller. So if you think about going to a marketplace and there being only one stand selling eggs, they are the ones who are actually setting the prices, right? And setting the conditions on which you can buy the eggs. Obviously, we have some competition in the Web2 world. So we have Google Cloud and AWS, and they compete with pricing and with services and with the rules and things like that. But then once you get into that one particular provider, you are in a marketplace with only one seller. So in decentralized infrastructure networks, the marketplace is there so that you can have potentially unlimited number of providers providing same or similar service, but maybe at different prices or different quality. Maybe I want to pay more for higher quality, or I just care about it being cheap, and then I'm fine if the service is not 100% awesome and perfect. And then both of these are tied with some kind of token and accounting, usually built on top of blockchain. So if I want to leverage an infrastructure, I have to go to the marketplace and say, I want this much compute for this amount of time, and I'm willing to pay this amount of money. And then the infrastructure providers will give you bids, and you will select one of the bids and say, okay, this is awesome. For next 2 months, I would like to run my software on your hardware, right? And then it happens. I mean, all of these things are automated. You don't have to actually. Not always you have to select a provider. It can be selected for you based on some rules or something like that. But what I mean is there is some kind of value transfer tool, which is usually a cryptocurrency, or in other words, token, that allows this transfer of value from a user to the provider. So let's quickly go over some of the deep-in projects. And I also, this is not a comprehensive list. This is just stuff that I've heard about in the past that I was able to do a very little research on. The list can go on, but I didn't know the other projects in that list, so I just didn't put them in. And then also the list would be too long for this presentation. I've also categorized it in a very free form. I don't think that these are any official categories. I mean, compute and storage probably are, but the other ones may not be. So you may also find these projects in other categories or not categorized at all. So from compute perspective, interesting projects are Akash Network, and I'll talk more about that in a bit. And Golem Network, for example, which is solving similar issues, running applications or running software in a decentralized manner, but it's using different approaches to the solution. Then we have storage. Filecoin is a very large representative there. And there is, for example, StoreJ, which is also very interesting. And then Codex, which is something that we built, not we as me personally, but one of the projects under the Logos umbrella, which is also a storage archival system, distributed decentralized storage approach. Then we have video, where I mentioned already Livepeer, which is a streaming encoding decentralized network, where basically if you are streaming, if you want to do a live stream, for example, and you don't want to push the full amount of data to the users, which is very impractical, you would use YouTube to recode your stream, and then it would show up on the YouTube website. But the problem with that is, A, YouTube can censor, B, there is a lot of privacy leaks, C, there is advertisements which you may not want because people are giving you money in some other way. So you can potentially use LivePeer as a decentralized permissionless alternative. And there is Tether with data and event brokers. If you're familiar with Kafka, Kafka is a data or event broker. Streamer is very similar to Kafka, and I think they also have on their website that it's like a decentralized Web3 native Kafka. So maybe it is. I haven't used it. And then Source Network is aiming for the same. I think at this point they just air quotes, have a decentralized peer-to-peer based database, which is very interesting. And they are looking at like IoT use cases and edge devices and things like that. Then I've mentioned HiveMapper for building better maps in a decentralized manner. There is a big push on Deepin in energy sector because obviously all the power lines are centralized in a sense where it's a company running those. But then also with the push on solar, on photovoltaics on your roof, there is a big potential for decentralized marketplaces of selling and buying energy. Why would I sell it to a large company if I can sell it to my neighbor, right? So that there is some potential in there. And then as AI has gained and is gaining more traction, there are a lot of contenders in the AI space in decentralized projects. And the reason for that is obviously money, but then also centralized AI is problematic because whoever controls the data and the model training controls the output of that model and can very easily make it biased, right? So if we want to have an unbiased models, or at least have an ability to build unbiased models, we need to have a decentralized way, an open way how to build the models. And for that, Akash Network is pushing for people to have access to GPUs, kind of commoditizing GPUs. And then BitTensor or Fetch AI are doing other things, and I don't want to get into details on this, but you can research them if you will. Okay, so we are behind the theory, or we are over with the theory on the Deepin projects. Let's quickly take a look at Kubernetes. So Kubernetes is an open source platform designed to automate deploying, scaling, and managing containerized applications. So what it means, I have an application, I put it in a container using tools like Docker or Podman. I push it somewhere to registry, and then I tell to Kubernetes cluster, hey, deploy it with this set of parameters, this set of resources, and keep it running. And that's all it does, basically. And it handles the container orchestration. It does whatever it needs to do. Service discovery. If I have multiple containers in my application, it will help me to discover the various containers and bridge them together. It will self-heal if something crashes. It gives me storage automatically if I ask for it. And there is many, many, many more features. Again, as I said, I'm pretty sure you're familiar with Kubernetes ideas. And if not, it's very easy to study and to learn more about. Now, there is a very specific or special type of Kubernetes in a sense, and that would be hosted or managed Kubernetes, where cloud providers usually offer Kubernetes as a service. I come there, I click a button, a couple of minutes or hours later, I have the Kubernetes cluster ready, and they make sure, the cloud provider makes sure that the Kubernetes is up and healthy for all my needs as much as I need, as much as I require, as long as I pay. So the benefits of that is that it's very simple to deploy. Click a button, provide some parameters. Usually, it's way easier to scale because I don't have to put in more compute. They will just do it for me, and they will just install new nodes and connect them to the cluster. The problem with this is that I'm now in a marketplace with a single seller, as I described with the X example, and I'm in for a potential vendor lock-in. Right? That's always the case if you're using a specific cloud with specific services. It might be very hard to migrate in the future. Now, against that goes the Deepin projects for decentralized and open cloud. So I want to talk about Akash Network because that's one I use almost daily for deploying my applications, and the one that I'm very optimistic about, let's say. So Akash Network, it is a decentralized, open source cloud computing platform aiming to provide permissionless marketplace for infrastructure and applications, incentivizing users to share their access, resources, and earn rewards. The last part, I'm not sure if I 100% agree with that, because I wouldn't probably use my laptop to plug it into the Akash Network, and that would be what I would imagine to share my access resources. But if I am a company that has a bunch of racks of servers and nobody's using them, then yes, I could imagine deploying Kubernetes, plugging it into Akash, and maybe earning some money on a hardware that would otherwise just be sitting there. Not sure if you're familiar with blockchain space in general, but Akash's blockchain part is built on Cosmos SDK. It's interesting to you. There are providers, and those providers run Kubernetes. So we've talked about Kubernetes specifically because Akash uses Kubernetes, leverages Kubernetes for container orchestration and application orchestration. And those providers run Kubernetes, and they plug the Kubernetes into the permissionless marketplace. And then I can go there, and if I have the right tokens to pay for, I will just say, hey, deploy my application. They will give me offers of how much money they would want from me for a month or for a minute, and then I'll select one, and they will deploy my application and take my money. I think that works pretty well. There's one quote from Akash co-founder Greg Ossory: "You will own your cloud, and you will be happy." And he posted it based on a tweet and a blog post from 37 Signals about how they went from a cloud provider to their own hardware because cloud got too expensive, right? And the belief there is that since cloud is getting expensive as much as you scale, it gets more and more expensive. It does not get expensive linearly, but usually it gets expensive exponentially. You will want alternatives, and having these decentralized providers who can usually go lower cost because they use excess compute that they would not use otherwise would be much cheaper and much more efficient. So since we're talking about Akash, I just wanted to show you, and I think I made it too small, but this is their console. This is a beta version of the console, so you might not be able to find this particle version, but it's showing where the providers are currently. There is 80 active providers, basically all around the world, mostly US and Europe, but Asia is popping up. If you're sitting in Africa or South America, there is a huge potential for you to be the first Akash provider. I think if you reach out to the community, they'll be happy to help you. And then there is 20,000 CPUs, 400 GPUs, 100 terabytes of memory, and 1 petabyte of storage available in the Akash cloud in general, distributed around the world. I think that's pretty cool. So now how it works,
Sorry.
you come to
you have about 1 or 2 minutes left.
Yeah, that's perfect. I'll be fast. You come to this console, you select a template, or you build your own. The template is a YAML similar to Kubernetes manifests, or you can use this builder, and then you submit it, and you get these bits, and it tells you where the provider is, how much uptime they had in the last 7 days, and a bunch of other information. You select one, and it gets deployed, and then you can get logs and shell access and things like that. So just to compare the hosted Kubernetes and Akash very briefly. So with hosted Kubernetes, the big benefit is that you get a full Kubernetes API access, which you don't get on Akash, for example. You get more granular security, and you get integrations with other cloud services because the cloud provider will give you probably other cloud services than just compute. But you're in a single provider, high potential for censorship, and no way to contribute or influence because it's probably not open source, right? On the other hand, these decentralized platforms usually go with lower cost permissionlessness, so nobody can prevent you from using it. Akash itself has a focus on AI, so if you're doing something on AI, it might be interesting because they have plenty of GPUs there. And you have multiple providers which can offer you varying prices and other things. The negatives are you have limited Kubernetes API support. You have potentially non-professional providers, which can happen, but there is some way, there is some check mark that you can look for that gives you some assurance. And then you have limited automation integrations like Terraform or Ansible. I don't think that Akash has any packages for that. On the other hand, the traditional cloud providers usually push on those. But that's, for example, a good place to contribute to the project if you are interested in contributing to open source. So in conclusion, Deepin is gaining traction, not just in cloud, but other spaces as well. But you need to be very careful whether what you are looking at as Deepin is actually permissionless, private, along with physical. And also need to make sure that the Deepin project facilitates open marketplace supported by digital economy. If it's not open marketplace, so not anyone can join and not anyone can use it, there is something wrong with the project. And just to conclude, I want to say that Kubernetes is awesome, Akash is awesome, and you should definitely build open source projects. And that's my last slide. Thank you very much. I think it worked pretty well. Again, my name is Václav Pavlín. You can find me as V. Pavlin. I will be very happy to answer your questions in the Q&A section or after online. Also, by the way, we are hiring. So if you go to free.technology/jobs, there are jobs posted. They are pretty complex right now. Like the skill set you need is very deep, but something to look at. And then if you're interested in that free communication, go to waku.org or just let me know, and I'll be happy to answer questions and give you pointers. And sorry if I ran over, but also started late and I talk a lot.
Sure. Thank you for your presentation. Okay. We are starting a little bit late. I'm very sorry. The next speaker will be Piotr Zaniewski. I'm fairly certain he will correct me if I said it wrong. Hi, how are you?
Hi everyone. Excited to be here, and you said it right. So first try.
Great. And you will talk about the architecture of developer platforms. Sounds exciting. Well, the stage is yours.
All right, awesome. I hope you can see my screen. So the architecture of developer platforms. This is really kind of a new and upcoming architecture discipline. So platform architecture, or platforms rather, is a relatively new phenomenon. So you must have heard about things like Heroku, or people building their internal platforms. And for now, it's a little bit free for all. So everyone builds their platforms however they want. But there are emerging patterns in architecting platforms. So on top of being a software architect, systems architect, and so on, there's a new exciting role emerging that I want to talk about and convince you that it's a great space to invest your time in. So a little bit about me. I specialized in Kubernetes, Docker, container technologies. I write a lot of Go, specialized in cloud and so on. Currently focus on, building and architecting platforms. So this talk is going definitely to be relevant. In my free time, I spent way too much time in GitHub and specifically tweaking my .files and writing lots of scripts, but hey, it's fun. You can find me online at cloudrumble.net or on LinkedIn. Just search me there, pick whatever social media works for you, and I will be really happy to connect with you. So let's start by talking about what is platform. So the way I like to define it, because there are of course plenty of definitions as you can imagine, I like to talk about different kinds of platforms, and this helps us understand what actually platform is. So at the top, you can think of business as a platform. So applications like Uber or DoorDash or Lieferando, if you're in Germany, those essentially are platforms that connect consumers and businesses. So this is already this notion of building something that other third parties can use to accelerate and build something on top of. Another level of platforms is domain-specific platforms. So the good analogy here, a good example would be using something like map services. So imagine that your application needs to display a map or needs to calculate a distance between two geographical points or something like that. You might have a web app, you might have mobile app, you might have an API. So that's a platform in and of its own that could provide this kind of geo-related services. So that's a domain-specific set of SDKs, maybe frameworks, something that a dedicated team could work with. And finally, kind of the lowest level of platforms, something which we will talk about today, is domain agnostic infrastructure platforms. So those types of platforms provide services that don't directly relate to the value that is delivered downstream to a customer, but rather empower, software projects by delivering building blocks and services that those projects can use. A very good example of a platform could be Kubernetes itself. Although one might argue that it's not a ready platform, you might need to invest a little bit of time to adjust to your needs. But those three levels of platforms help understand what is the scope or space where we think about platform engineering. So really quickly, what are the benefits of infrastructure-focused platforms? Why do we do this, right? So first of all, it simplifies and standardizes resources management. If you think about CI/CD pipelines, cloud resources, no matter what kind of cloud is it, or SaaS offerings or various other providers, you want to have all the teams using similar language and ideally similar API to simplify and standardize so that you can move faster as a company and deliver on things like compliance or security. Another benefit is increased development efficiency. So that's essentially the goal of platforms. I want to make sure that development teams move fast and break things, as a famous saying from Mark Zuckerberg goes, but break things in a safe way. So platform does it by providing guardrails around best practices and so on. And finally, platform is typically built from ground up, thinking of scalability and reliability. So something that developers don't necessarily consider or not always consider, focusing on application features, you might easily overlook those things. Those are by no means all the benefits that platform does, but just handpicked a few just to give you an example of how platforms benefit organizations and developers. So as an architect, you might have a challenge of creating a platform. So your company might grow and your CTO or your manager can say, hey, I've heard about these platforms. They are awesome. Can you please design me one? So very briefly and kind of a 10,000-foot view, what are the platform components? When you hear the word platform as an architect, you might want to map this to a nice component diagram and kind of see what are the very common things that each platform should typically have. So first component is a self-service portal. So we want developers to use a self-service, typically web UI, to interact with an underlying infrastructure, and this web UI would expose only certain functionality in a certain way. So again, remember guardrails, this is something important. We don't want developers to necessarily have to create various bespoke files or just use complicated API calls. We want them to be able to use a self-service portal. Two examples of this technology currently in the wild is Backstage from Spotify. I'm sure a lot of us heard about it. And another one, a new, rather new offering is called Port, which is a little bit different take on developer portals. That is a SaaS offering, but it boils down to the same idea of exposing to developers something that is easily consumable. Another component that I will talk about much more, and this presentation is kind of centered around it, is a programmatic API. So APIs run the world on top of software running the world. So if you think about banking transactions, ordering anything online, all those things are powered by APIs. Most of those APIs will be either RESTful APIs or simply JSON over HTTP. But there is more to APIs, and there is certain type of architectural patterns or thinking that I'll talk about later that APIs are critical for. Another component is automated workflows. You can wave in chat if you heard about Argo CD or Flux. Those are really interesting ways of actualizing your desired state into an actual state. That's where applications like Argo or Flux, together with Kubernetes, essentially create a pattern that is a new way of deploying and managing infrastructure, including obviously developer platforms. Another pillar is monitoring and observability. This is very critical because typically modern architectures are distributed. So as we've heard in the presenter before, we had plenty of distributed systems. Those systems are created really, really fast. And this is important to understand how we can observe and monitor those things. Another point is security and compliance. This one is actually very important because typically as a developer, you're concerned by, okay, I need to deliver the feature. That's my job, right? I'm concerned with delivering functionality to the customer. Sometimes this means cutting corners, or sometimes this means incurring technical debt. Whereas platform, actually, what it does, one of its tenets, it provides to the developer only a very small subset of properties that whether deployment or something else that developers are working on or application would need, and then obfuscates, abstracts away all the settings that developers don't care about. And this is typically motivated by security compliance, being forced or being compliant with SOC 2 or other certifications. And a very important point, platform is a product. It's ever evolving. It's always changing. And this is something that is very important to have in mind. As an architect, you want to think about platform as a product, similar way how you think about customer-facing product. All right. So what are the emerging patterns or kind of best practices around designing platform? So first of all, we want to make a platform API driven. And I'll show this later in the demo, but this is something that we'll focus and explore a little bit more later. Cloud native principles. Kubernetes obviously is a leading project in cloud native landscape or CNCF ecosystem. So all those projects have something in common. They follow certain design principles that make them cloud native. So they can be deployed to any clouds, and they actually can be decentralized from the get-go. And finally, GitOps, as I mentioned earlier, is not really emerging. It's really well-established pattern of working with desired state and applying this state to the destination. API first design, why this is important. So real briefly, API stands for Application Programming Interface, and it's a set of rules, standards, and protocols for building and interacting with software. I bolded out the two parts, interface and interacting. So if you think about API, the way how we really want to architect a platform, we want to be able to arrive together with developers by agreeing on a certain API shape. We want to say, hey, if you want to create a software or an infrastructure, that's what you want to be providing. And this is typically will be, a file, right? A JSON file or a YAML file. And interacting means, how do I provide API? And I'm going to argue that Kubernetes, specifically Kubernetes API server and API machinery, already provides a very robust and rich ecosystem which we can standardize on and interact through Kubernetes. Right, so why all those things matter? Why do we want to choose API? Where they are everywhere. APIs simplify operation, they standardize. So whether it's HTTP protocol or just simply standardize on our internal decisions, APIs can be 100% automated. They will obviously scale. Well, we kind of inherit all the luggage or all the good things that APIs already gave us. So OIDC or other ways of securing applications. Doing it in this way, so architecting platforms around APIs brings this space closer to us and makes it available for us. All right, so one more iteration real quick, just a reminder that when you are an architect and you're kind of thinking of building a platform or you have a challenge around building a platform, you need to understand that platform is a product. You treat it exactly the same like you treat customer-facing products. So you need to have appropriate organizational setting, you need to have a product owner, project manager, and you need to have a product mindset. So very simplistically, you want to understand your customers' needs, design something, obviously test it, implement an MVP, minimum viable product, and deliver it to customers, gather feedback, improve, and then the cycle repeats. All right, so now I'm going to switch to the demo. And the idea behind the demo is really to show you that the architectural patterns that we've discussed earlier about developer portal, GitOps principles, and so on and so forth, when you apply them in a real world scenario and create a platform around them, the experience from both developers and platform engineers side is really nice. So it is empowering developers, following cloud native principles, is fully API driven, and it applies GitOps workflow. So let me swap real quick to the demo. So for the demo, I'm going to change hats a little bit. Let me know if I should make it a little bit bigger so guys you can see. So now I am a developer. You should see my GitHub repository with a sample app. So as a developer, I live in my repository, my editor. I am concerned about delivering features, and this is my world. So in this specific app, I have a very simple Node.js application. Here I have a server, and the server interacts with Azure Storage Account. If you don't know what Azure Storage Account is, it's like AWS S3 bucket, but better. So Azure Storage Account provides capability that I need in my app to consume it. So this scenario clearly makes it so that as a developer, I will need to interact with cloud, or I will need to consume cloud resources. All right, great. So this application has a very naive, simple Docker file. And from my perspective as a developer, that's more or less where my interaction with infrastructure ends. I have my editor, I have my application. I am concerned about testing functionality and making sure that everything works well. All right, great. Now I am changing hats. Actually, no, I'm not changing hats yet. I'm sorry. So as a developer now, I want to deploy my application. So here I mentioned earlier that there are two types of, or at least two kinds of well-known developer portals. One is Backstage, another is Port. I am using Port in this example. Port, if you're watching this presentation, please add a dark theme because they don't have a dark theme. So I'm sorry for all the white. All right, as a developer, I want to create my application, which you've seen earlier. It interacts with storage account, and I want to create all the infrastructure. So what I'm doing is I click Create button. I have a default values that I care about as a developer. I want to know the name of a connection string if I change it in my application. I want to be able to provide an image. Maybe I change the version, and then maybe I want to change a port. So when I click Execute, what's happening behind the scenes, you will see that port is actually talking to the repository that contains all the deployable elements from my application. So all the things that are going to be deployed. And it started already triggering a CI/CD pipeline. Great. I, as a developer, didn't have to interact with it. I just clicked a button. This CI/CD pipeline created a PR in GitHub. So remember when we talked about common interface, we don't open a ticket, we create a PR. And a PR is an actionable item that I can exchange between myself as a developer and platform engineer. So now I'm a platform engineer, I'm changing my heads, I can see that PR arrived. All right, so we have some kind of generated by port, something, I can see what this PR is. So we have this simple YAML, right? So I have something which is called app claim. I have the values that you might remember from submitting them through port. And I have a value that the developer couldn't submit because it wasn't present on the port form. All right, so I as a platform engineer, I'm happy with it. Everything looks great. I'm going to merge this pull request. Cool. So when I merged it, I, again, a platform engineer, created here, in this case, Argo CD. Let's refresh this and let's see what's happening. Oh, so based off this small YAML file, I have actually created multiple resources that my application needs. So those resources are a webhook, Slack webhook. What does it do? As a developer, I go to my Slack channel and I can see, hey, your app is ready. And observability Grafana dashboard is ready. Let's start from Grafana dashboard. Let me see if I can log in here. I wouldn't, of course, log in as admin, but I was lazy. All right. So as a developer, I can see that's my namespace. I don't have data yet because I didn't I didn't play with the application, but I can observe, I can test. This is all my infrastructure that was deployed alongside of those other components. Great. So I also have a link to my app. So let me see if our app works. And yeah, what do you say? It works. So it's, of course, a naive app. It reads from Azure Storage Bucket, and it just reads the content of a blob, so a content of a text file. Okay, cool. So how does it all work? Let's first prove that this actually is not a fluke, and we're actually reading something from the file. So now swapping to Azure, you can see that those resources in Azure were actually deployed when I submitted this small YAML as a developer. So I have this storage account, and inside of the storage account, I have a container, and inside of the container, I have a blob that contains my data. So I can go to the data, I can edit the file, and I can say something like, yeah, the demo worked, because it doesn't always work, right? So when I save it, we can go back and refresh the application, and lo and behold, we are reading from the file. So everything works, our developers are happy, and we essentially help them as a platform architects and then later platform engineers design a solution that is fully automated and doesn't require any handoffs, essentially. So now I tested it, everything was fine, and as a developer, I want to get rid of it. I am not interested in this anymore. Similar process as before. I'm going to port to my developer platform. I have another action that I can use here, and in order for this action to work, I need to know the name of my file. So here it is. I'm just going to copy it and then paste it here, select my application, And you guessed what's happening probably behind the scenes, port opening another PR to my application repository. And then as a platform engineer, I can again approve this PR. And once I do it, the whole infrastructure will be removed. So you can still see that my Argo CD, well, it's huge. Let me make it smaller. My Argo CD still has all the components, but now I'm going to go back, see if a PR is already ready. There it is, removing Azure Storage Account file. So I know it's working. Merge and delete branch to make it clean. And now when I go to Argo and refresh it, as you would guess, all the things are gone. The state is clean. We are not paying for Azure resources, and everybody's happy. So that's that's a quick demo, and now I'm gonna really quickly summarize what we've learned. So let's go back to presentation here. And first of all, the tooling that I've used. Why I used Kubernetes. As I mentioned, Kubernetes obviously orchestrates containers. Everybody would agree with it. It does orchestrate containers, but I would argue that Kubernetes, most of all, is a universal control plane that reconciles anything that you give it to reconcile. In this case, we have used Crossplane, which is a control plane framework that reconciles external resources. So we were able to create Azure resources. We were able to create HTTP call using various Crossplane providers. We used Port, as I mentioned. We used GitHub as an interface. We used Argo CD. And believe it or not, all this demo runs on my local kind cluster, which is Kubernetes in Docker. So I didn't need to spend money on cloud credits. Right, real quick, as a recap, how the demo works. I hope it's not too small, the diagram. Let me make it a little bit bigger. As a developer, I interacted with a portal, in our case, Port. When I submitted an action to create infrastructure, including my application, what Port did, it actually created a PR and it pushed the changes to a repository that Argo CD was observing. A third step was me as a platform engineer, saw a PR, I approved the changes, and once the changes were approved, Argo CD observed a specific folder and said, yep, I got YAML here, I'm going to apply it to a Kubernetes cluster that is configured. Once this happened, Crossplane picked it up and composed all the resources that are necessary for me as a platform engineer to create when a developer says, I want my storage account up. That's what's happening behind the scenes. All right, great. So what we have achieved here, just a conclusion, we reduced friction. As architects, we created a platform that reduced friction almost to zero. There's no need to create a complicated processes. Developers just went to IDP, internal developer platform, and deployed whatever they needed. We eliminated waiting times. The only touch point between platform engineers and developers was a PR. So we essentially only did this, and we could also not do it. We could automatically approve PRs if it's those environments, so let's say test environments, then the waiting times will be actually zero. We use GitHub PR as a unified interface to exchange data and feed it back to Argo CD and through Argo CD to Kubernetes. The setup we achieved is very easy to collaborate on and very extensible. We could keep adding all the elements under the hood or behind the scenes that the developers would need to use. We introduced zero trust security principles. If you notice, developers didn't need access to Azure. They simply interacted with SDK through their application, and behind the scenes, everything was provisioned. So we used zero trust settings and make it more secure. And a bonus point, I didn't even mention AI once, which is great. You can, of course, use AI to create the setup, but it's not needed. So key takeaway from my presentation, if you want to remember anything, remember this. As an architect, if you ever want to design a platform, you want to design this platform same way as you design API. So think about versioning, data exchange, API contract that you want to shape with your developers, and this will guide you on the right path. And then all the other pieces are, of course, implementation detail that you might swap as long as your architecture is strong. I think that's all I have time for. If I'm not mistaken, that's my time says time is up, but please correct me if I'm wrong. And thank you for your time. Again, you can find me on cloudrumble.net. I'll be happy to chat about all things platform.
Thank you. Great presentation. Let me add Václav, I think, back to the stage. And now we have time for a couple questions. Václav in particular got a couple, mostly about, it seems to me that there is a common theme between these questions, which is about trust. So for example, Václav, how can you trust that the output of a service is not altered by a host? A centralized provider, for example, can be sued.
That's very interesting. So first of all, we should all assume that everyone lies to us, and we should always verify and not trust. But in this particular case, I did not want to go too much into the detail, but in all the decentralized systems that are permissionless, especially, you usually have some collateral that the provider of the service has to post. And then there should be some kind of way to verify that what you are getting is actually what you're paying for. And if not, then they should lose the collateral or part of it. So the simplest example is Ethereum and staking, for example. So proof of stake. You stake some Ethereum in a blockchain system, and you are producing blocks and validating blocks. And if you start proposing false blocks or like wrong blocks that are not true, that you are trying to fake something in them, then your collateral can be slashed and you can lose the money. And that's usually how it works. There are other approaches like proof of authority. So we have a bunch of trusted parties running something, and then if we stop trusting them, we just kick them out. But that's less permissionless and less open than these other approaches, where economical value is usually what gets involved. And then the risk of losing that value is the punishment. And the goal is to build a system that is trustless in a sense that you don't have to sue as long as rules are followed. And if the rules are not followed, it's very obvious. I hope that answers the question. We'll see. They can find me. Just don't sue me, please. Can't hear you.
Sorry, I muted myself. With the centralized provider, you have an SLA. How does it work with decentralized providers?
Again, a good question. I think this goes back to the trust as well. Sorry. There is one thing. Basically, the idea is that if you're paying for something, you should get a service. If you're not getting a service, you should have a way to opt out or switch. It's called exit cost. So if a centralized provider does not follow the contract, I can leave, but there may be exit cost of it being complicated. If you have a single system, like I explained Akash Network a lot, so I'll stick with that. If you have something like Akash Network, you can easily switch providers by redeploying to a different provider that may give you better service, right? And the exit cost is very low because they are all providing service on the same API the same way in general. And then there is usually also some reputation system involved. I'm not sure if Akash actually has that, but it would be very beneficial if people could, or the users could actually vote based on their leases of like how long am I using this provider and how happy I am, and it will give it will give other users a good guidance. But yeah, I mean that's a risk of decentralized systems. And again, this is the same. As I said, there should be some economic value involved, and if the provider is not fulfilling the contract that is being agreed on by connecting to the system or leveraging the system, they should lose the collateral.
And same vein of questions, it seems. So how can you ensure uptime? It seems that's the core of the question.
That's a good question. I don't have an answer for that. I'm not from Akash Network. I'm just liking the project and contributing in spreading the word and using it. But I will definitely ask this question. I'll just if you can copy it to the chat after, I'll just copy it as it is and I'll post it and I'll tag the Akash Network account on Twitter, and then the co-founder usually replies, so we can have answer for that. And then if you follow me or follow Akash Network, you will probably see the replies. So yeah, I completely agree. That's a very good question, and I'm not sure if it's solved. I mean, Akash Network is still a relatively young project given the complexity of the decentralized system. So maybe this is unsolved yet. Maybe there is an issue that they are working on it on a research in a research phase. So I don't think I have no answer for that, or at least not definitive answer.
Okay. There was one question that's kind of a general question that was more for, I think, the last that was for the last Q&A session, but it's kind of a generic question. So I'm also interested in your guys' answer. Do you have a particular strategy to stay up to date with the latest trends and advancements in software architecture? So we can kind of make up for the last speakers running out of time by asking you guys. For example, Piotr, you didn't have a chance to talk yet?
Yeah, right. So obviously, I mean, what I do personally, I have a few newsletters I'm subscribed to that I like and that are within my domain. I also have a few podcasts. So whenever I go for a walk, I try to be involved and do it. And it depends a little bit if you want to just have a general overview of what's happening, like what are the news, what are the trends, or do you want to be more involved in specific domain? So for example, in my case, I stay a little bit deeper in Kubernetes and like a cloud native ecosystem, whereas for general stuff or generic news, I would be mostly subscribed to some newsletters. But I think it's important to know what you want. If you want to learn, that's your reason for staying up to date, then probably better is just to have hands-on experience, engage with the community, get on Slack. There's a lot of open source projects have typically Slack or Discord. That's much better than just staying up to date with news, because you can get overwhelmed, and now 80% of it will be about AI, generated by AI. So it's a little bit hard to sift through all this. But yeah, if you have newsletters or some podcasts that you like, that's a good way to stay up to date.
Yeah, I'll just add. I think from my perspective, and what always worked for me is more, if I'm interested in something, I'll go deeper in the topic and I'll find more information. Just generally consuming what the trend is did not usually help me that much, because I would not know enough to actually leverage it anyway, right? So I agree with Piotr that like maybe having some general overview. I follow a lot of people that are very active in space I'm interested in on Twitter, and they post about new project and new developments and new features. So I know about these things. But then where it actually gets interesting is when I try new stuff. So trying Akash here, trying Kubernetes many years ago, using something called Radical, which is like a decentralized GitHub alternative. Just going and getting my hands dirty is usually how I learn the most. And then it also leads you to various rabbit holes of things that you didn't think might be interesting, or you might actually want to try as a next step.
Okay. It seems we don't have more questions, and we are practically at the end of the time slot as well. So I think I will add Sia to the stage.
Of course. Hi, Piotr. Hi, Václav. Nice to see you here. Oh, we have one more question for Piotr.
Yes, Piotr. Naive question. I'm not really sure. Why would you, as a company, build your platform having already plenty of cloud providers with their APIs to choose from?
Right. So typically, companies would have policies around access to cloud. How, for example, if you give developers, access to AWS and just say have at it, without control, then you would quickly rack up costs. You would quickly experience various security issues, and then your infrastructure would spread all over, and it would be very, very hard to maintain. It's also impossible to have any security certification. So it's very critical actually to have some form of ability to control access to cloud providers and cloud services, and this becomes even more important when there are more than one cloud provider. If your company uses various SaaS offerings, maybe they use AWS, Azure, or something else, they have some parts on-prem, then it's even more critical to make sure that the access is properly gated and there are guardrails around it. So there are of course situations where you would be okay doing it. So for example, if you work with teams that are mature and developers actually work with cloud on a day-to-day basis and they need full access for testing, for example, then of course it's absolutely okay. There are then ways to wipe a whole AWS account or Azure subscription at the end of a week, for example, so you don't incur more costs. But generally, I would say you definitely want to make sure you have guardrails in place to prevent all kinds of disasters.
Great answer. Thank you. So yeah, I guess that's it. We have no more questions for this Q&A session, and also Václav is back with us. I will add him to the stage just for a moment to say thank you to Václav and to Piotr for joining us today, for taking time to educate us, to taking time to provide the insights to our audience. And also I want to say thank you to Michał, as he handled 2 blogs, 2 Q&A sessions, really great, moderated. And yeah, that's it. Thank you, guys.
Thank you very much.
Thank you.
Bye-bye. And now we are ready for the last block of presentations for junior track of the Worldwide Software Architecture Summit. And it will start in 5 minutes. We will have a little break, but before, I would like to kudos to TechDev Technologies for their support in our community. They are doing good stuff. So if you know someone who needs some extra help with coding, please consider those guys who sponsor and support our community first. They specialize in creating innovative software solutions with experience in web and mobile applications, blockchain, and AI. TechDev Technologies helps clients to thrive in today's technical world. Yeah, link is in the chat. These guys are really cool. And yeah, let's have a break, and we will be back in the stream in 5 minutes. And we are back. Hi, guys. And it's the last block of the Worldwide Software Architecture Summit 2024. And our next speaker is Adam Bender, Principal Software Engineer from Google. And he has a really great topic for the career track about software engineering, and that's it, decision making. Hi, Adam.
Hello. Can you hear me?
Yes, I can hear you. I can see you. It's great. How are you?
Lovely. I'm doing well this morning. How are you?
Also great, thanks.
Excellent.
And yeah, let's start. I'm sharing your slides, and the stage is yours.
Oh, thanks. How exciting. Hi, everyone. My name is Adam Bender, and as was mentioned, I'm a principal engineer at Google. And perhaps more relevant for this talk, I'm also our code health practices lead. So it's my job to think about how we make better software long term at Google. We have a lot of code, and thinking about how to make it better is apparently a full-time job. So today, I want to talk a little bit about what I see as a different way of thinking about software engineering, different than I think we teach, different than the way we talk about it. To me, software engineering is about decision making. Now, before I explain what that means, let's take a look at some code, right? This is a software engineering conference, so it would be wrong of me not to have at least some code to share. So here's a couple C++ functions, and I'll state for the record, I am not an expert in C++. I know enough to get this code properly formatted on the screen, but there's some interesting properties in this code that I think you will all see whether or not you speak C++ fluently. So the first question is, how many decisions were required to write this code? When you look at this code, how many distinct decisions do you think it required to get it written? Well, let's highlight a few. First, we had to choose two function names, in this case, create and get new transaction ID from monitor. Then we had to choose two return types, two different preconditions. There was a decision to perform a retry loop. There was a decision to name a local variable. All of these are very, straightforward kinds of programming decisions. There, of course, was also one decision to compose this work into two functions in the first place, which probably involved another decision about choosing where to do the different precondition checks. There was a decision not to create or handle any kind of errors in this code. There was a decision that every new workflow that passed through this code should have an ID. There was a decision made that ID should be a global ID, and that ID should come from the global ID service, right? And I should point out that these are all the decisions we can see. Who knows how many it took to actually work through, or how many decisions were made in the process of creating this code that we don't see because the author decided to do something different, right? There's some other harder to see choices, right? There's the decision to use C++ in the first place. There's the decision on how to do indentation, the decision to use underscores for local variable names, a decision to use capitalized words for function names. And you may say, but those are obvious choices. Those are probably in a style guide. Sure, but a style guide is really just a collection of somebody's choices, some decisions that someone had to make, right? There are even more difficult to see decisions. Things like, why was this work prioritized in the first place? Why should it be located in this file? Why should it live in this service? There were decisions about how to test this code, how to compile, ship, and support this code. And of course, you can't forget all the decisions you depend on that led to the design of the language and all of the tools necessary to express it in the first place. That's a lot of decisions, right? That's a lot of decisions. And to my mind, this speaks to a really underappreciated point about software engineering. And that is that literally everything in software development is a decision. I just covered 20 plus decisions for 20 lines of code, right? Now, some of these decisions work out just fine. Some of them do not. Can you see the one decision that led to 130-minute downtime and many, many dollar signs of outage for YouTube? It may not be obvious if you're not familiar with the code, so let me help you out. It's right here. See, the root cause of this issue was that an API, which was designed for low QPS usage, this new global unique ID, it was designed for circumstances where you would occasionally sample like 0.0% of all traffic and call this method. That's what it was intended for. We had a change which accidentally put it on the request path for every single request. So this low QPS usage suddenly became very high QPS usage, right? In this case, QPS stands for queries per second. And I can't tell you the specific details of what went wrong beyond this, but I can tell you it was bad enough that YouTube ended up in the news that day, right? Almost anyone making this change, the change here in this code, would have had a hard time recognizing the cost of the mistake they made up front. Sure, you could argue they could have had better testing or better developer documentation. I actually don't think either of those remediations would have guaranteed this problem goes away. See, the impact of this change was magnified by several factors that were not immediately in evidence to the change authors, and it's very likely they could have imagined this test scenario ahead of time. After the fact, obviously, it's clear what went wrong. But as many software engineers, as any of you probably would confess, it's very hard to know for a given choice which one is going to be the bad one ahead of time. So I've said the word decision a bunch, but I should probably define it a little bit. When I use the term decision or decision making, what I'm referring to is a sort of process that looks like what I have here on the right. It's a process where you define a question, something you need to answer, some choice you need to make, something you want to do. You gather some data about that choice. You refine the available options to try and narrow down to a set of things that you think might be good. You eventually commit to one of the options, right? That's making the decision. You probably communicate that decision to other people. And then if you're doing it right, you evaluate the impact of that decision for future use, right? It's no good making a decision and not learning from it, bad or good, so that you can do a better job next time. Now, decisions ranging from the trivial, like what to eat for lunch, all the way to the complex, like what data store should we care about for this, for this new system we're building, they can all be mapped back to a process like this. Obviously, more complex decisions have more going on, but I'm pretty sure that nearly every decision you make will eventually go through most of these steps. Now, it does go without saying, I'm pretty sure, that decision making is sort of a self-evident activity. We make decisions so frequently in day-to-day life that it's kind of hard to see it as a thing with parts, right? It's hard to break down a decision into these individual steps, which makes it hard to learn how to get better at them, right? That invisibility camouflages the fact that decision making is a skill that can be learned and can be optimized for. Getting better outcomes from our decisions is possible by improving the outcomes for each of these individual steps. So that kind of begs the question, how did you all learn to make better decisions as a software engineer? Maybe you took some classes. I mean, I've never taken a class on decision making. I'm sure one is offered out there, but maybe that's what you did. Maybe you had a really good mentor. Maybe you had someone who happily spent time explaining all the things that they had made mistakes on in their career and passed on all that wisdom to you. That'd be amazing if you had such a mentor. More likely than not, though, you went to what I call the school of hard knocks, which means you made a lot of decisions, some of them went poorly, and you learned not to make those mistakes again, right? In other words, trial and error is really the best tool we have for teaching people how to make better decisions. I don't think that's good. I think we can do better than that, right? I don't love that we seem to lack a really good idea about how to train software engineers. Now, you might ask, why does this matter to software engineers? We just write code. Well, in my work at Google, I study a lot of different projects. I look at projects that are doing well, projects that are doing poorly. Nearly every project that I look at, nearly every time I talk to a team, there's some form of decision fatigue that seems to be plaguing them. Decision fatigue meaning just the sheer number of decisions that they have to make to get stuff done starts to overwhelm them and make it difficult to make progress. Right? So, as I said before, nearly every act of a software engineer requires making a decision. And every decision that you make is built atop a mountain of previous decisions, each of uncertain quality. You don't really know how the libraries you depend on were built. They work, thank goodness, but you can't really vouch for the quality in the same way, or in the same way you can vouch for your own code, right? We also have no laws of physics in software engineering. There are no hard rules except maybe the speed of light and the speed of your CPU, right? Everything else from there on is an arbitrary set of decisions. The only constraints are those that we decide which should exist. We can make pretty much anything, any set of abstraction, any shape of code. We can decide any sort of concepts are the way we want to build our system. There are no real constraints. And that's sometimes why using new tools or languages can feel like all you're doing is just trying to memorize tons of arbitrary rules, tons of random facts that help you to make progress learning the language. It's kind of a daunting experience sometimes. Our decisions are also risky and expensive. They're risky, in my opinion, because we don't really have a mature approach to making decisions. The best tools that we really offer ourselves and our colleagues are things like YAGNI, or you ain't gonna need it, and DRY, don't repeat yourself. And these are clever little slogans, and there's some truth to them, of course, but they don't really offer you a clear strategy for how to apply in uncertain circumstances. Like, How many times is too many? What does it mean to repeat yourself? All of this is entirely left up to interpretation by the people who are trying to use these tools, right? All our decisions are also interconnected. A decision about a low-level API can affect an entire company or an entire ecosystem. JavaScript. We can't predict which decisions are going to be consequential from the get-go. Simple errors like the YouTube bug that I showed you caused a massive impact. But we often don't know ahead of time which of the tens of thousands of decisions we make will be the cause of the problem. So those risks create costs. Those costs come for a couple different reasons. First, if getting a decision wrong is really expensive, we're going to invest a lot of time up front trying to figure out how to mitigate the potential impact, right? And this isn't strictly bad, but because so many decisions can go wrong, we spend an awful lot of time trying to analyze, or at least I hope we spend time trying to analyze all the things that could go wrong, and that costs a lot of time and money, right? If each decision requires us to walk this tightrope between too much and not enough analysis, that can be wasteful. We're spending too much time on the wrong things or not enough time on the things that matter, but we don't know which is which. Imposing decisions also, decisions also impose a cost on the people around us, right? When we develop software libraries or tools or frameworks, every decision we ask other engineers to make has a cost, whether it's a command line flag, a new dependency, confusing API name. All of these create cognitive load that may require extra days or even weeks to reason through. I'm sure all of you have had the experience of trying to make sense of a new API that just didn't seem to make sense, right? It seemed confusing. There were too many options. You didn't know what they meant. Confusing names, duplicate stuff. We've all experienced that, right? And that cost adds up. The accumulation of all of these costs and all of this risk leads to a sort of risk-averse behavior and poor outcomes that I think overall slow projects down. The thing is that as our software systems grow, it becomes harder and harder to maintain velocity because our ability to reason about software deteriorates. The number of choices that we have to think about, both the ones that are in the past and the ones that are in front of us, just seem to never stop growing. Now, I find this interesting a little bit because in a lot of ways, everything that I've sort of described up to now is just what we call the job software engineering, keeping track of all these random facts and knowing which APIs do what. We've kind of defined the job of software engineer to mean someone who can memorize a bunch of random trivia and apply it when necessary. Now, I know there's much more to it than that, but honestly, how much of your time do you feel like you spend doing like real computer sciencey things versus just trying to remember how to make an API call, right? I don't think this is a good thing, right? Unsurprisingly, probably, since I'm giving this talk, I think that we can do better. Now, before I tell you how, I want to give a quick aside, a personal rant, if you will, on something that I call primitive obsession. I borrow this term, by the way, from a sort of design pattern smell of the same name, which tries to emphasize the problems you run into when all of your code is defined in terms of primitives and you haven't built up any higher levels of abstraction. That's where the name comes from. So in my opinion, we have a sort of primitive obsession going on with the way we do software development. What do I mean by that? Well, we have long celebrated the kinds of software engineers that excel at accumulating random bits of trivia. Our languages, libraries, and tools are littered with random inconsistencies, poor names, and undocumented behaviors. Successfully navigating even a small project often requires committing to your memory all manner of code paths, URLs, special cases, historical footnotes, config locations, and more. And it's not just that we have hundreds of details to keep track of. We are hopelessly reliant on informal mechanisms to convey all the details of our systems because we have not developed the tools or the culture that make doing otherwise easy and valuable. Have you ever found yourself staring at a new code base, or maybe just one you haven't looked at in a while? And if you've been given the task of adding a new feature, what are the tools at your disposal to help you make an informed decision about any impact that your changes might have? For most teams, the answer is go and talk to the developer that's been on the project the longest. I got to say, this is not a systematic solution to the problem of knowledge management. This is how we maintained history prior to the invention of writing. We can do better than that. So what is the impact of operating at such a low level of abstraction? Well, in many cases, it means making many more decisions, right? At a low level of abstraction, everybody has to make the same decisions over and over again, often with little context. It means each developer has to reason about the inconsistencies, which pattern should be followed. Is this change worth putting behind a flag? Where should this code live? And many times there's no real good reason why things are the way they are. That's just how we've always done it. The sum total of this sort of decision space that we inflict on our fellow software engineers has a tragedy of the commons kind of an effect, right? What's the cost of defining one more config option when you already have to memorize 100 or 1,000 other bits of esoteric knowledge? We are writing code and designing systems with tools like text editors and line-by-line debuggers that have existed for nearly 50 years and which operate at the level of, something like an amino acid, when our most complex systems have emergent properties that feel more like complex life, right? The thing that frustrates me is that we know how to build better tools, and we tried, tools that operate at a higher level of abstraction. Unfortunately, we have also created really powerful social archetypes for how the wizened bare-knuckle engineer works, and it's always a multi-monitor setup covered in reams of plain text. Those archetypes have power. They've come to define what real engineering is, and they frame how new engineers aspire to do their job, right? It becomes the ideal for thousands of new engineers. Here's the reality. Today's systems contained millions and millions of lines of code, written in dozens of languages. They may be spread across millions of individual processes, thousands of individual servers all over the globe. We cannot hope to reason about the trade-offs required when making decisions in a system of this magnitude if we are still trying to reason about our code one file and one line at a time. No disrespect to my VI and Emacs users. I know you love your tools. I just want us to find a way to build software systems and to think about them at a level above the plain text. All right, thank you for permitting my rant. So here's the question: what can we do about this? How do we think about this problem? Well, here's a simple suggestion. Why don't we center the concept of decision making in the software engineering process? What if we talked about it more? What if we made it a central activity, something that we trained people for? What are the implications of taking decision making seriously as the core activity of software engineering? Well, here's some thoughts that I have about this. First, we should all become students of decision making. You can't and won't make every decision personally. So you need to find a way to learn from what others are doing. You need to discover what problems they're having, what decisions they're making, what are the outcomes. Take an interest in how decisions are made, what the decisions are about, how things went, right? You have a wealth of information around you. There are decisions being made around you all the time. Learn from them. Like I said before, heuristics such as Yagni or Dry, they're valuable, but they're poor guides for rigorous decision making. We as an industry, and I'm not just talking about academia here, we who are building software every day need to invest in understanding how to make better software decisions. We should really study this process and see if there are tools that we can develop to get better outcomes. Now, keep in mind that better techniques here doesn't just mean more and longer analysis. I'm perfectly aware that we still need to move fast. So we need techniques that are both good and fast, allowing us to deliver higher quality software faster. One of the most effective tools I've seen in my time at Google is the embrace of constraints, right? One of the most effective things you can do to make better decisions possible is reduce the number of decisions required to get things done. That way, your team's energy can be spent on the important choices. Now, reducing the number of decisions your team or others using your code will have to make will likely lead to better outcomes. That's what we've seen at Google, but it may mean less flexibility, and that may feel less exciting. The trade-off is it saves a lot of wasted time and reduces a lot of risk. Now, of course, there will be some cases where having flexibility is a good thing. The trick, and the real trick for any good software engineer, is figuring out where that flexibility matters. It's not uncommon that everyone working on a project feels like their project is the special snowflake, not realizing that they're probably actually a potato. And no one cares that potatoes look very different, right? It's just the way it is. If you own a library or service, maybe consider adopting something like a decision budget. Track the number of decisions that you impose on the users of your tools. Try to keep that number low, right? Constraints can help all of us reduce the space of complexity, reduce the set of options and the things we have to reason about, which makes it easier to get our jobs done. Now, making good decisions can't be done in isolation. If you really want to make good decisions, you need feedback loops. Feedback loops are how you drive the learning process. The good news for us is there's lots of opportunities in software development to introduce feedback loops. You can do things like code review, design review, post-launch reports, post-mortems, retrospectives. And something that I've been trying to pilot recently is sort of a long-range architecture review. In other words, you look at a system that's been running for 2, 3, 4 years, and you ask, How has it been performing? If we were to build this system again, would we do it this way? I think feedback loops are perhaps the most powerful tool for shaping how we make future decisions. Of course, if you want to have good feedback loops, you can do a little bit to help optimize for that outcome, right? You can improve the quality of your team's decisions by practicing a deliberate preparation for the eventual software archaeology that will happen. Your system is going to live for a long time, very likely. And that means you need to keep records of what's been going on for its entire life cycle. Nobody wants to inherit a system that's 10 years old and has no documentation, no evidence about how the decisions were made, no evidence about what choices had been made. If you really truly invest in documenting past decisions and putting them in a place where people can find them, you will help future maintainers, including yourself, when you come back to this project in a year, understand why things look the way they do. Right? Importantly, when you're doing archaeology, or when you're preparing for archaeology, make sure that you document the why for your decisions. The what can sometimes be self-evident. We decided to use a microservices architecture, but the why is what really matters. That's where we start to understand the thinking process you had when you were building your systems. This will be incredibly valuable to someone who has to understand both choices they need to make, maybe in new systems they're developing, or ways to extend the system that you already built. And finally, as you might imagine, I'm a big fan of raising the level of abstraction of your tools, of your libraries, of your frameworks. You should work really hard to build higher level abstractions that let people working in your problem domain and on your system work at a level that's much closer to the problem domain itself rather than assembly code. Of course, it is entirely possible to go farther, right? Those tips that I just gave you are relatively simple. These are things that you can do tomorrow if you want to. They don't require a lot of additional effort. I know writing docs always seems like effort, but trust me, it's not relative to the time it saves you. But if we really want to change things, if we want better outcomes for software long term, I think we can go farther. I think we can start rethinking how we train software engineers. Right? I think we can reapproach the software developer education. I don't know about you, but my computer science education didn't really do a lot to prepare me for the kind of decisions I was going to be making as a practicing engineer, right? In my mind, computer science and software engineering have really diverged as skill sets. And I think there's something unique and different about software engineering that we aren't really talking about. To me, it's this fundamental idea that decision making, the ability to think about how to make choices in an informed and structured way is really missing. Right? So if we want to prepare better software engineers, here's some skills I think we might want to emphasize. For example, you could teach new engineers how to prioritize constraints. You've got a list of 10 things that you got to choose from. How do you build a prioritization function that lets you choose which options are probably the good ones? We can teach about the impact of cognitive biases, how to recognize them, what the impact of those biases are. We can talk about how to document and communicate decisions with the appropriate context. We could talk about how to think about the total cost of ownership of a decision, right? When you make a decision, it's not just the cost to implement, it's the cost to own that decision for 5 or 8 years that really adds up. We don't teach that today. We should. We can talk about how to classify decisions into types like reversible and irreversible. We can look at the effect that limiting choice has on the complexity of a system. We can teach how to assess the impact of decisions in a structured and blameless way. We made a decision. What happened? Let's look at it. How do we figure out what to do next as a result? We could teach the importance of situational awareness. How do you create an environment for better decision making, right? How do you create an environment where you are consuming the right kinds of information so that your decisions are informed? And if nothing else, we should be teaching every new graduate of a software engineering school or boot camp or whatever how to uncover the decision-making processes going on around their organizations, right? Software engineering, as distinct from computer science, is not an iterated set of sort of tiny hackathon projects with discrete ends. Software engineering projects last for years. They come with things like maintenance and team turnover. They have to figure out how to adapt to an ever-changing world. That requires a different set of skills. Every choice in a real project carries consequences that will last for years. And that's something we need every software engineer to be ready to wrestle with. Now, our systems are not getting smaller, and absent effort, the rate of decision-making, like entropy, is only ever going to increase. And all of this was bad enough with humans writing all the code, but on the horizon, AI is coming. It is going to change how we think about the role of a software engineer. And I think it could pose a potentially existential threat to our ability to understand the systems that we are working in. At their worst, an LLM is going to produce a ton of code at a rate never before thought possible by humans. Great. So now we're just making our systems get ever bigger. We're going to have to write LLMs to help us understand those systems. Where does it end? At their best, though, I think an LLM or any kind of AI could transform the experience of being a software engineer in a meaningful way, right? Imagine that everyone, new grads included, suddenly became the tech lead, the TL of a team of 10 intern level AIs. Instead of writing all the code, your job as a TL is to make decisions. Anyone who's a TL could tell you that. So that means everyone is suddenly responsible not just for making sure the code is written well, but deciding what code do we write, which part of the teams of these sort of AI teams are working on which problems. This is a really fascinating potential opportunity, but we're not ready for it right now. We don't prepare people to think about software engineering as decision making. Now, I think that we can improve our present and prepare for our future, right? I think we can start to study the role of decision making. I think we can center it as one of the most important things that every software engineer does. But to do that, we all have to take seriously the idea that software engineering isn't just programming, it's actually decision making. Thank you.
Thank you, Adam, for the presentation. It was really nice to hear your insights, your thoughts. Thank you for taking your time for educating us, and see you at the Q&A session, I guess.
All right. Bye.
Bye-bye. And let me announce our next speaker, who is Saravanan K. Nagarajan, architect and sustainability community lead at Rabobank. He will tell us about sustainable technology, a path to greener future. Welcome to the stage.
Hello everyone. When you look at this image, it probably reminds you of the movie The Matrix. In 1950, Isaac Asimov, the science fiction author, wrote a series of short stories called I, Robot. These stories talk about machines taking over the world somewhere in the 21st century. Well, we are now in 2024 and almost a quarter past the 21st century. Machines have indeed taken over the world. In fact, there are more machines and processors in this world than humans. And that includes the laptops, mobile phones, and the various devices that are connected to the internet. And they are growing more powerful as we speak. Let me give you an example. I assume most of you have smartphones lying around. I want you to imagine this. You have more computing power in the palm of your hands than the Apollo 11 guidance computers that were used to fly man to the moon. The Apollo 11 guidance computers had a processing power of approximately 14,000 floating point operations per second, whereas the smartphone in your hand have processing powers in the range of trillions of operations per second. You almost have a neural engine in the palm of your hands. To quote Neil Armstrong, it is indeed a giant leap for mankind, or in this case, artificial kind. But such great power comes at a cost. With great power comes great responsibility, goes the popular saying. But I say that with great computing power comes an even greater carbon footprint. Now, what is carbon footprint? It is an indication of the amount of greenhouse gases, that is carbon dioxide and methane, that are emitted as a result of our action. That includes the technology we use and the software we create. So today, we are going to look at the 3 Ws of sustainable IT and green software. Why do we need to acknowledge sustainable IT? What is green software and how do we build expertise around it? What are the ways in which we can make the most impact that leads to a better future? So why now? Why do we need to talk about sustainable IT now? For this, we need to look at some of the facts. According to the United Nations Environment Program, the tech sector is responsible for 2 to 3% of the global greenhouse gas emissions. 2 to 3%, that doesn't sound too much until you compare it to the global aviation industry, which also accounts for the same amount of global energy-related carbon dioxide. And we are not even talking about the global e-waste problem. According to the World Health Organization, in 2019, around 50 million tons of e-waste were generated globally, out of which only 20% were documented to be efficiently recycled. Looking at all these facts, we can acknowledge that this is indeed a big challenge ahead of us and that we need to take urgent steps in order to address this challenge. Are there any recommendations towards solving these challenges? Well, one such solution is to look at moving the technology infrastructure to the cloud. Well, there are positives and negatives to this recommendation. On the one hand, gone are the days when organizations had to spend millions of euros in order to set up data centers of their own, procure expensive hardware and processors, and also train IT staff in order to maintain these data centers around the clock. There are major cloud providers nowadays, such as Microsoft, Google, Amazon, that have ensured that organizations have reduced capital expenditure costs. They are also scalable up or down depending on the business needs. They also provide backup in terms of whenever a data center is down, there is always another data center that ensures business continuity. But the key point here is that most of the cloud providers are also sustainable. They are already, the three major cloud providers are already carbon neutral data centers. That is, the amount of carbon that they emitted are being offset by these cloud providers. They are also aiming towards net zero data centers. So instead of using energy based on fossil fuels, these cloud providers are moving towards renewable sources of energy such as wind turbine and solar. But moving to the cloud does not solve our challenge until the cloud resources are optimally used. There have been instances of virtual machines being run continuously around the clock, even on weekends, on the development and quality environments. Running these virtual machines on development and quality not only increases the cost of maintaining these resources, but it's also not a sustainable way of working. These are some of the topics that are being addressed by the FinOps Foundation. There are various training programs that talk about how to optimally use your cloud resources and how to ensure that your teams are being trained in these aspects. I encourage you to visit the FinOps Foundation website and, if possible, to follow one of these courses. For major organizations, in order to set up optimal usage of cloud resources, there is a need for a governance wherein you have FinOps trained DevOps teams, and there is a central FinOps team that drives optimal resource utilization. And how do they do that? Well, there are various dashboard options that are possible nowadays, wherein you can highlight the cloud utilization and also have recommendations in order to optimally use the cloud resources. Well, now we have looked at the technology aspect. What about the software aspect? That is where the Green Software Foundation comes in. Green Software Foundation is a non-profit set up by Microsoft, Accenture, GitHub, and ThoughtWorks, along with the Linux Foundation. They are an ecosystem of standards and best practices for green software. In fact, they have, along with the Linux Foundation, also have a course wherein you can go and get yourself certified as green software practitioners. And the best part is that this is a free course that you can do right away. It is also good for your LinkedIn profile. For all the Microsoft fans, of course, Microsoft also has a sustainable software engineering course that you can follow on the Microsoft Learn website. Well, now that I have told you about some of the ways in which you can build expertise around green software and sustainable IT, let's assume you take my recommendation, go through these courses, get yourself FinOps certified, become green software practitioners, and also follow the Microsoft course. Well, how do we apply this and make the most impact? Well, there are certain recommendations for that as well. The first step to spread our knowledge is to communicate and collaborate among our colleagues. One example is within Rabobank, where I work. We have within the organization a sustainability community. This community has more than 3,000 members spread across the globe within Rabobank. Here we talk about all topics related to sustainability, and one of the chapters is, of course, sustainable IT. We share the best practices, lessons learned, and also tips and suggestions from experts around the world on how to be more sustainable in IT practices. I encourage you to promote the culture of communities within your organization, wherein you can talk about this particular topic. I previously talked about the Green Software Foundation. They also have a very active community which you can join and learn from experts around the globe. For people within Netherlands, we also have a Sustainable IT Netherlands meetup that you can join and also collaborate with like-minded colleagues and technologists about sustainable IT. I encourage you to visit these forums, these meetups, and if possible, also start initiatives on your own in your regions. This is the first step towards communicating and collaborating about this topic and to ensure that many people know about sustainable IT. In fact, recently, the Green Software Foundation also conducted a hackathon called Carbon Hack. This was an opportunity for individuals to apply in real life how to promote and to build sustainable software. This hackathon in particular was about utilizing a plugin called Impact Framework, which the Green Software Foundation has come up with. I encourage you to visit the Green Software Foundation website and also read more about the Impact Framework. In fact, this plugin can be an opportunity for you to do a hands-on and also to measure software sustainability for your applications. To summarize, we talked about the need for acknowledging sustainable IT and green software. We talked about what is green software and how to build expertise around it, and what are the ways in which we can make the most impact. I leave you now with a final slide on the United Nations Act Now webpage. The Act Now is a campaign by the United Nations in order to promote individual contributions towards the Sustainable Development Goals. If you are having any doubts whether your contribution as an individual can have any impact, I urge you to think of the butterfly effect. According to the chaos theory, when a small butterfly flaps its wings somewhere in the Amazonian jungle in South America, it sets off a chain of events that leads to a big cyclone in North America. Such is the power of that small action, and such is the power of that small butterfly. Ladies and gentlemen, I see that butterfly in each one of you. So flutter away, take action, make an impact. Thank you.
Thank you, Saravanan. You really inspired us to think of sustainability in our works, and it's something everyone should keep in mind. And yeah, we are having our last presentation for today, which is by Sebastian Tiemann, who is a senior API consultant at Code Centric AG. He is live with us. Hi, Sebastian. You are on mute. Could you please unmute yourself?
You are totally right. I'm sorry.
No worries.
Hello, everyone.
Hi, how are you?
I'm a bit nervous, but yeah,
No,
I'm very happy. Yeah, thank you.
Yeah, so we have your presentation. It's right there. And yeah, the stage is yours. Do your magic.
Great. Thank you very much, Sia. Hello, everyone. My name is Sebastian Tiemann, and I represent Daniel Kotzert as he cannot attend today. But nevertheless, we think that API thinking is not less important because API thinking is a way we think, again, thinking that will hopefully a bit mind-blowing, but let's begin with the bottom, as our talk will be most likely on a quite high flight level, but maybe first some words to me in person. Hi, I'm Sebastian. You can find me on LinkedIn. I am API consultant at Concentric, and I'm also organizer of the Java user group in Dortmund. And I'm trying to tell you something today about APIs and about our way we think our mindsets may change. But first of all, let's begin at the very bottom. Let's begin with what we call the pure integration mindset. So when we have a look at our developers or at one developer, and I'm writing, for example, I'm writing code for my backend application or for my frontend application, whatever I do, I'm most likely trying to access data in some kind of visual perspective from a database, for example. And my API is more or less an interface that is somehow providing data from a backend to my frontend. Okay, so there's nothing wrong with it, right? I do have my task. I create my, for example, REST endpoint. Hopefully it is REST. And I create my API and my frontend displays the data. Everything's fine. Is it? To focus maybe on a bit wider level, not me as a developer, but the whole team who might be responsible for a service or something. Yeah, same scenario. We also have some kind of data we want to present, we want to show in an app, in a web app, wherever. And also we are creating an API, we are sharing this data, and everything's fine. Is it? This is what we call the old way or the pure integration way. So we focus on connectivity. We focus on connecting, for example, front ends and backends. We have a quite, what we say, implementation-driven approach. So we write an API when we think it is necessary to expand an existing API. Or if we need a new API, we just write it. Is it a problem? Most likely it is not always a problem. But as a consequence, we have a quite limited scope. Either it is me as a single developer, or it is the team where the scope is limited to. And scalability, it depends, right? So if I'm, let's say, trying to use or to implement this one of those new hype topics like large language models or AI, and I'm thinking about, what can I do to access this data or this API? I may get into trouble. And that's the point where our new way of thinking or API thinking comes into play. What we think about API thinking is a more strategic vision. So we are taking off from this very ground level to the upper flight level, to a more strategic vision, because we think that APIs play a more strategic role to generate more value for example, as a shared asset in a company. How do we achieve this? Well, we have the idea that we should have a look at the user experience, for example, or that we emphasize reusability to improve things like scalability and flexibility. Okay, user experience, well, that is something I use to create my frontends, right? Yes, it is the same thing we want to figure out, because maybe we also can provide more interesting insights for our API and then be able to create a better API. But let's take a look at this, because we think that it is more useful not to have an API as something that somehow is being created during your development process, more than a product or an API product, what we call. This API product has, of course, different properties. For example, a value proposition. So when we talk about an API product, we have to make sure that this API has a clear value. It needs a task. It needs to address a specific problem a consumer has, because we have an API, we have data, we are providing with this API, and therefore we can hopefully provide some kind of value. To make sure that this works, maybe we need some monetization strategies, but at least we need some analytics to measure it, or to have an idea, or to get an idea about business impact. And most likely we want to improve it in the future. So we have to have a look at it. Also, when I say business value, maybe ownership and lifecycle management are also some topics we need to cover, because somebody needs to be the owner of this API. I have to go to someone if I need improvements or if I want to update this API. And last but not least, what we also heard before, it is necessary to somehow make it understandable for other developers to use this API, or how to use this API. So when we think about it, many things that I mentioned are some kind of consumer-driven or consumer-centric, as we say, because this is not falling off the development, right? I am trying to create something that I want to use as a consumer. So maybe I should design first, or in other words, let's talk. Let's talk about some things that I need, some company standards we need to follow, validations. Maybe we should talk about, before we start to code, about validations, other quality aspects. And that's where API thinking comes into play, or what we summarize as API thinking. I believe some of you already gathered that we talked about design, we talked about thinking, and about APIs. And yes, design thinking is something we would like to use as a kind of example, or not example, we would like to extend here. Of course, classical design thinking consists of 6 phases if you Google it, but we think the empathize phase can be summed up to 2 phases. So what are we doing? First of all, we want to try to figure out the what, the problem. What do I need my API for? What is my business case? If I have the what, then I can say, okay, this is my goal. For example, I am currently working in an insurance business, and the issue we have that there's an API that is only used 2 times a year, but then with a very heavy load. So the rest of the year, the API remains just dead. Therefore, it is totally useful to talk before, so that we know, okay, this API has to be able to take this load to work. And this, yeah, only 2 times a year. Nevertheless, we should collect ideas how we can approach this problem and how it can be solved, hopefully. And then maybe, at least in classical design thinking, we can build a prototype to somehow tackle this problem or tackle what we want to do. And of course, we need some kind of validation. Well, when I take this and put it to classical software development or API development, then this is a kind of approach we think that is useful, because the development itself comes nearly at the end. Before, we want to collect everything we need to know for the development. We need some data, hopefully. As I already said, an API is nothing less than a kind of an interface that provides data. And of course, we should talk to our stakeholders for requirements, for non-functional requirements, for performance needed, whatever is necessary. And then after that, I can get back to my keyboard and type the API, write the code, write the service, whatever is necessary. And then I can try to validate it. As I said, the customer or the consumer, as we say with APIs, is more important. Let's focus on the 2 steps before the API development. In this case, let's take a look at, maybe Chucky. Hopefully, Chucky is not our consumer, but the question is, who is it? And maybe some of you realized that also these questions are part of user experience. And when I know who is going to use my API, I can also say what are my use cases. So what do I want to do with this API? What about response times? What about availability? And also user experience. What is also important that 2 of my brilliant colleagues, one former colleague, created some kind of user experience series on YouTube. You are not the consumer. I love this image. But also what it should say. You cannot have a look in your glass ball and decide what the consumer needs. Talk to him, ask him. You are not the consumer. But maybe there are some tools where we can make some use of to figure out what do we need. I have no time here to go that much into detail what we are using or what is useful for you, but there's plenty of tools you could use. Apart from those API and user experience, let's talk about data. And when we think of data, maybe we should also think of data products and data contracts. And somehow, wait a minute. I heard that before, right? Yeah, we have some quite similarities between APIs and data again. So we again have these four points. I need my data for what? Yes, for what? For a value, for an output, for whatever. So, for example, for an AI, I need to encapsulate the data and algorithms to provide actionable data-driven and user-facing insights, for example. For the user interaction, I maybe need to somehow develop my data to improve it with user feedback. It's the same thing as before. The cross-disciplinary development. Again, let's talk about it, because most likely you will have more than one data scientist. You do not have a data scientist per team. Maybe you have many teams with data scientists, with domain experts that can ensure that this data is understood correctly. And as always, monitoring and maintenance is something we always need to make sure that everything post-development works as expected. But when we have a look at such a data product, it seems quite abstract to me. Let's have a look at this beautiful graphic from our friends from InnoQ. When I have a look at this data product, the obvious thing is I have an input and somehow I have an output. Okay, so we might have some input data products, and we also might be the input for other data products. Everything else you see here should be also familiar with software development. Oh, software development? Yes. Or API development. The only thing that is not constant here is the node in the middle, the data storage. It could be as well as your source code. It could be as well as your API. Because you always need some observability, potentially some CI/CD pipeline. You need some documentation because you need some context, some information about your data or about your code or about your API. And also transformation code may be totally useful for your data in context of ETL or ELT. So also here we have some recurring patterns that are not quite different from what we saw before. My friend Stefan Hochhaus from Codecentric also proposed this data product business canvas. Apart from these technical aspects I mentioned before, we should also document somehow things like cost structures because, for example, all this infrastructure is costly. We have some target users who is using my data product. We should somehow track it. Data providers, who is going to provide me the data that I need or that I have to transform, for example, and so on. This is also something you should take into consideration. And when we talk about data contracts and this data we want to use or we want to work with, we should also use these 4 steps or properties to somehow make it better. Because a formal agreement may structure somehow the data we need, or may at least be in agreement between 2 parties of providers and consumers. That's important. Also, schema definitions. How is the data structured? Nothing is worse than unstructured data that I found somewhere, I don't know, in the cellar, maybe. So it's better to have some kind of definition for that. Data governance is also something, especially for data. We have some potentially policies or quality and security that needs to be taken care of. And last but not least, the interface specification for data exchange is also something really important we should take care of. If you want to know more about the data mesh topic, I can really recommend you this book from Zhamak Dehghani. This is great. And I would like to sum my talk up with 2 important thoughts about data and API because they correlate to each other. When we think about an API as an interface that is only providing data, then it is easy to say, if my data has no high quality, how can this API deliver high quality? It's just not possible. So in order to have a good API or a valuable API, I need good data. And the second thought I would like to share with you is that we also need to make sure that we do not produce a big pile of data just to have a big pile of data. We need a value to work with this data, or at least some business value for this data. If I do not need this data or these data products that I produce, I don't need it. That's it. The same goes for observability. An example about APIs. If I do not know who is using my API, then I may have a problem because what's the value of the API and what's the value of the data? I hope I could bring you to some thoughts. And I would like to thank you. I have here some recommendations. And I guess I'm done with my talk. Thank you very much.
Thank you, Sebastian, for the talk. It was great. Thank you for stepping in and joining us today on behalf of Daniel. It's really helpful. Thank you.
Thank you.
So I guess we are about to start the Q&A session. I can't see Adam and Saravanan here yet. Maybe we can take a 5-minute break so other speakers from the block will join us and start Q&A session, okay? Works for you. Great. And I remind our audience to type the questions in the chat. Maybe you have some questions for Sebastian as well, for other speakers, because they all will be answered just exactly in 5 minutes from now. Thank you. All right, and let's start the Q&A session. We have Sebastian and Saravanan with us in live stream. Hi.
Hi, hello.
Hey.
Okay, nice to see you, Saravanan. How are you?
I'm doing good. Thanks, Sia.
Also great. Glad to hear that. So let's start the Q&A session. And firstly, I will start with questions for Sebastian. What are possible architectural solutions for the problem with API that is heavily used only 2 times a year?
Wait. So there's no special architectural pattern that we applied. We have some kind of you want old school Spring REST API at the moment, and time is not a constraint. So the workload is it's not about getting the work done as fast as possible. It's about just waiting and some kind of like praying at the moment that everything holds. And if not, running, it's a kind of a batch job, running the remaining batch job again. It can be, there will be a better solution, but from a organizational perspective in that company, it's a bit difficult. So it is, how can I sum it up? It's a difficult situation because technology might not be the ideal solution for this problem.
Thank you for answering. And I wanted to tell that the questions are open. So Saravanan, if you would like to add anything or you have some thoughts to share as well, please feel free to share your thoughts. And next question is also for Sebastian. What are best tools to use during the API design thinking process, like planning endpoints, models, headers, etc., to have them as a roadmap before start coding?
I think that it is best to, at first, just get away from these technological aspects. So I think it is best to think of for what problem am I going to use this API? How is my organizational structure of the company? I know it's a huge thing, but as I mentioned during my talk, those recurring patterns, like user experience for whatever you use it, or personas to mention a tool. There are many good use cases, but if you throw this more or less what Sperlim, I'm sorry if I pronunciate your name wrongly, mentioned, I'm not sure if it is always a technical problem that you have to solve first. Therefore, I would recommend to at first talk about who is going to use your API, with what functional requirements, what non-functional requirements. I believe this is the most important thing, and then go after and have a look at how does your organization work, and how can I then make a proposal for an implementation or for a prototype and then validate if it works. I would at first stick away from quite technological aspects like endpoints and headers. I hope this answers your question.
I hope so. Thank you for answering. And we have 2 general questions, but they are sustainability related, I see. So I guess it's for Saravanan. How the PIN blockchain and others come into the picture of the sustainable technology?
Yeah, it's a good question. Thanks for bringing this up. Yeah, with all the technological advancements, especially nowadays, it's more about Gen AI that's being talked about, machine learning, Gen AI, blockchain. All these also come with their own carbon footprint. For example, I read the other day that when you are trying to when you use DALI to create, from a prompt to an image, so every time you ask for an image, it consumes as much energy as charging your mobile phone completely. So that's the amount of energy that's being utilized by all these technologies, and we have to, keep that in mind, that we use these when we put large systems into production, that we keep this in consideration. And also, if you look at the latest cloud offerings, they also talk about calculating or measuring your carbon footprint, right? So those are also, large organizations have started to already put these as services on top of their cloud offerings. In blockchain specifically, I'm not sure if we can incorporate that, but with the cloud offerings, definitely there are carbon footprint calculators. So technology improvement is good on one hand, but on the other hand, we also need to keep in mind the impact of these technological advancements.
Great. Thank you for answering. And I'm glad to see that Adam joined us. So we have some questions for you as well.
Uh-oh.
So, let's start from one of the biggest ones. So it consists of 2 parts. How do you manage the decisions and connect them? How do you make sure we don't repeat and make conflicting decisions across teams?
Yeah, it's a full-time job. In my view, the job of a tech lead of any kind, whether you're like a team lead of 5 or an organizational size lead, maybe you're leading a team of 20, 30, 50 people, your job, I believe, is to think about the decisions all the time. How is your team making decisions? How are you tracking the decisions? How are we judging the outcome of those decisions? So on my teams, I have a number of different techniques that I use here. So we do, I talk to a lot of people. I do sort of little mini postmortems on a lot of the types of decisions that we do. I tend to record those things in various docs and places that folks can find them. I encourage people to talk to each other. I make sure that every junior engineer on the team has an opportunity to talk with other senior engineers about the kinds of decisions that they're making. We do a lot of pairwise mentoring, so junior engineers work with more senior engineers on given projects so they can see how that works, and they can see what the outcomes of decisions look like. I'm a big fan of something called a decision log, which is just sort of a running log of the important decisions the team has made. You can just use a simple spreadsheet or a Google Doc for something like that. It doesn't need to be complicated. I mean, if you have a team of 5 people, this looks very different than an organization of 500. So calibrate your tool set appropriately. But the most important thing you can do is care. The most important thing you can do is recognize that every time you make a decision, you are making you are leaving behind a question for someone who will come later who wants to know why things are the way they are. Take that responsibility seriously and do something that empowers that eventual, whoever it is, that person. It could be you, by the way, 18 months from now, who wants to know, why did we do this again? Right? So treat your decisions as precious objects that you intend to share with the world.
Great. Thanks for giving us this answer. And second part, we'd like to work on a higher level of abstractions. We seem to lack an equivalent of IDE for decisions. Writing decisions feels like programming with punch cards.
You're absolutely right. We do not have great tools that I'm aware of for tracking how decisions are made. And to the extent that we do, they feel incredibly heavyweight. Anyone who's ever worked in a highly processed software development environment where like safety critical systems are at play and every decision has to be vetted, it can feel overwhelming. So we're missing that sweet spot. I agree. The IDE for decision making, or the companion to our IDE that helps us track decision making, is pretty hard to come by. The closest I've seen is honestly the commit log, whether it's your GitHub commit log or some sort of internal version control system. You have the ability to record for each change you make the reason that you did that. And it wouldn't be hard, I don't think, to write some sort of batch processing job across those comments to help build a picture of what you're doing. You factor in tools like LLMs that are good at natural language understanding. Perhaps you could generate like a good technical summary of the work that has been done for a given week or a given month. But a lot of this is still speculative. I don't think we have a good answer to this question. You're right. I think we should, though. I think we should invest in making these sort of invisible decisions more visible. I'd love to see companions for our IDEs or tooling environments that help us recognize when we're making decisions and help us record them properly so future us can find them.
Great. Thanks for sharing your use. Another question for you. What is a decision budget?
Ooh, a decision budget. Yeah. So I mentioned this briefly in the talk. This is an idea that I came up with, I think. I'm sure others have had this idea. I don't think this is unique. When I build larger systems, we used to talk about something like a novelty budget, which meant if you're going to build a big new system, you can pick, let's say, up to 3 new technologies. Everything else has got to be bog standard. You can pick 3 new cool things, but no more than that. And you get to choose, but after you've picked your 3, that's it. To me, a decision budget is kind of a similar thing. If we want to allow configurability or optionality in our tool, we should limit that optionality to where it is most valuable. Not everything needs to be configurable, right? And figuring out what are the right things to provide command line flags for or options to, I would argue, it's probably still more art than science at this point, but you need to think about this from your user's point of view. Where's the optionality really going to help? Where's the 80% or 90% use case? You don't want, I don't know about you, but I've looked at tons of Unix or Linux command line tools that have unending options. And of course, for one specific use case, there's absolutely one person out there who can use that flag. But for that one person, you are asking everyone else to pay the cognitive tax of understanding, why does this option exist? Should I be using it? Is it useful to me? And you should ask yourself if that's worth it. Yes, I know having infinitely configurable tools can be super valuable, but if you're going to go that route, you also need to document the heck out of them so that everyone can clearly understand why you've made the choices that you have and where they're valuable. So my argument for a decision budget is probably balanced by the lack of interest most developers show in writing documentation. If you're not going to write good docs, limit the number of choices you give people so that it can be more self-documenting. But in general, think about the number of choices anyone has to make in order to use your code, whether it's a UI, a command line tool, a library, whatever. The more questions I as a user have to answer, the less likely I am to get it right. So minimize that number. And if you want, set a target for it, just like you would for performance. No one should have to make more than 3 decisions to use this library correctly.
All right, thank you for answering. Another question for Adam as well. We started before you joined, so...
No, it's fine. It's fine. I'm good.
Yeah. So for an engineering team to make better decisions, do you think the team composition with various decision-making types, analytical, conceptual, directive, accommodating, have a high impact?
Absolutely. Right. This is a strong argument for having a diverse set of people making decisions. And when I say diversity, I mean diversity of all kinds. You need people who think in various different ways to get good outcomes. A lot of the time when we're building software systems, we're doing something entirely new. We're not just building a copy of something we've done before. Otherwise, we would just copy the thing we did before. When really important decisions need to be made, you want to get a good outcome, you should have different perspectives. By the way, that also means different in the way that people think. So some folks are good in a room live, just knocking ideas around. Other people work better asynchronously in a doc. There's lots of different ways to make the decision-making process accommodating and getting people to shine through. But this is where the technical crosses over into the sort of more humanity-ish aspects of software development, right? Sometimes called soft skills, although I don't really like that term. If you want to get the best outcomes out of people, you need to recognize and amplify the things that are best in each of those people to get good decisions. And decision-making is ultimately a human process. So whether you're choosing a database or a front-end framework or a particular architecture, there are trade-offs in every direction that you look. There is no decision that comes without trade-offs. Those trade-offs are not all going to be apparent to us because we all carry around different cognitive biases. Different kinds of people will have different biases and different strengths. So yes, you absolutely want a room of people who don't always agree. You're not just looking for people who can always agree and seem to always herd towards the same answer. You want folks who can challenge each other respectfully and get a better outcome as a result. The goal here is to deliver better software. It's not for anybody to win.
Great. Thanks for this answer. And we have one more sustainability-related question for Saravanan. How can we promote sustainable software if we are considering that there will be increased usage of GenAI tools like ChatGPT, which makes the server operate a lot, which can increase carbon emission?
Yeah, so that's also the topic that I touched upon earlier, that with large language models, LLMs, that we are going to train, what happens is that with the lot of data that is being used to do all these trainings, of course, there's a lot of carbon emission based on the size of that model, right? So there are researches being undertaken now to look at instead of having a general LLM model that can be trained, there are companies that are looking at specific use cases. So, for example, in the legal department, if you take, there are models that are using only the legal regulations, for training the model. So then the machine learning model is only focusing on that data set and not the entire data set that's like an LLM that's used for ChatGPT, for example. So there we can look at not only reducing the carbon emission, but you're also looking at providing more value to your customer, right? Because then your model that is trained is specific for the legal customers. So they know for sure that all the regulations are covered in that particular model. So it can be applied for different industries, not only legal, it can be banking, financial industry, or any other industry for that matter, which with that particular data set. So that could be a trend that could reduce the carbon emissions. Your focused models based on industry sectors. That's something we have to look at from a business point of view as well. But for the larger models, that's one step that can be taken in that direction is to publish the emission results, so people are aware of each time a model is trained, what is the carbon emission. So measuring is the first step. So if there is a use case that you have to train a large model, then please make sure you publish the results of the emission as well. So that can be a good step to maintaining that balance.
Thank you. Thank you for clarifying this aspect. Really interesting. And the next huge question of 2 parts is for Adam. Adam, your presentation, very good, spoke of concepts such as lateral thinking, bias in decision-making, decision techniques, minimax, maximax rules, intuition, use of assumptions. Do you think it's the role of architects to help improve the decisions team members render, even if close to psychological context?
I'm impressed my talk did all those things. Yeah, it probably did. Yes, of course, right? I think it is really easy to imagine software development as something that looks more like raw programming. Programming meaning like you type keys into the keyboard, the computer does something. And that's a part of software engineering. But when you really talk about, at least for me, when you talk about engineering, you're talking about programming integrated over time. We say that all the time here at Google. And if you're talking about programming integrated over time, you are necessarily talking about a human driven process. We need humans to be able to make choices, understand choices, have novel ideas, feel confident making mistakes. You need to have the conditions where all of that is possible if you want good technical outcomes, right? Yes, you need sharp people who can think creatively and abstractly. All of that's true. But to get the best out of them, you need to understand why they think the way they do, how we get better decision outcomes, right? You can't just put 10 people in a room, walk away, and hope you're going to get something good. You, especially as a lead, need to figure out how you can get the most creative output from the team. So yeah, I think it's worth knowing about how people think, why they make mistakes. I got this great book here that I've been reading lately called The Logic of Failure. It's really helped me think through how we end up making mistakes, even when we all do, despite all the effort, we still end up making mistakes. I think taking an interest in the way the human mind works is a great start to understanding how do we get the best outcomes from a group of people trying to do something good together.
Great, nice answer. Thank you. Thank you for sharing the book with us. And the last question for Adam, it's not really related to your presentation, but what, if any, AI tools are in use at Google, and do you encourage using those tools?
So I think the answer I'm allowed to give is we use Gemini. You guys have heard of Gemini. We talk about it publicly. We have versions of Gemini for our internal systems that that understand our code base and other sorts of things. I find it, it's interesting, but an often forgotten detail that the original paper that sort of led to this current LLM revolution started at Google as well. We published the Transformers paper. Was it 2016 or it was a while ago? And obviously there's a lot of leaps before that. I don't want anyone to take, no one can take singular credit for where we are, but Google is absolutely trying to figure out the best ways we can use AI to make the software development experience better. And some days it's terrifying, like, oh my gosh, what am I going to do? The machine can write code. And then other days I see the code that it writes and I go, oh, my job is safe. But only safe if I can have a more expansive view of what it means to be a software engineer, right? It used to be that when computers were, first a thing, and someone mentioned this when they mentioned punch cards, there was a whole set of jobs related to collating punch cards, getting things in order, actually running them through the machine. Those jobs don't exist anymore because we have compilers. But software engineering is still here. My expectation is that LLMs will, I hope, be a massive augmentation to the way we do our job, but it will require us to change what we think about as the value we bring to the table. If you are over-identifying with your ability to memorize various API intricacies, you're going to struggle with this. But if you can take a bigger view of your work and think about how it's the choices that you make, it's your judgment, it's understanding second and third order consequences. These are things that even the best AIs today cannot hope to do. And so I think, to the extent you have an open mindset about what's possible, at least this is what I tell myself. I hope I'm right. These AI tools at Google or elsewhere they're going to be amazing, but we are not going to get through this without changing ourselves. And I think that's something that we all have to reflect on. So yeah, we use them all the time. They're equal parts terrifying and they bring me hope. I hope the hope is right.
Great. Thanks for sharing. And that's it. We addressed all the questions audience asked. So thank you for joining us. Thank you for delivering your talks, Sebastian, Saravan, and Adam. Thank you for taking the time to educate the community, and hope to cooperate with you next time as well.
Thanks all.
Thanks you so much.
Bye-bye.
Thank you.
Bye.
Bye.
And also, I would like to say thank you to our amazing audience who stayed with us to the very end of the summit for the whole 6 hours of digital content. Thank you for staying with us. And for those who are watching, we have a promo code which you can use to buy a ticket for tomorrow for senior track. with a huge discount, so don't miss that. And yeah, jump in for tomorrow. We will have 9 hours, senior topics, great experts. It will be a nice opportunity to dive deeper into current software architecture field. Yeah. And that's it. I would like to say thank you on behalf of the whole Geekle team to our speakers who shared our mission and devoted their time to preparation, tried very hard, and we are here today with great knowledge. And yeah, thank you. And we will meet tomorrow. Bye-bye.